Okay, good morning, everyone. A big welcome to the workshop. My name is Yan Chang. I'm really glad that you can join us in a very exciting and very wonderful workshop. And welcome to our institute in Taiwan. I'm going to give a few information and some remarks before we formally begin the workshop. Okay. And you might wonder why initiate a workshop. I would say that computational social science is getting more and more attention globally. There are many conferences probably in Europe, in the US, but not quite many in Asia. So I think it is a great opportunity that scholars in the region can have more communication and connection with each other. And secondly, not just knowing what others are doing, I think it's also important that we try to have more in-depth discussion. So today and tomorrow, I'm arranging two special sessions such that we can have more in-depth discussion on what computation is about and what kind of challenges and what's the promises we can have in the future. And of course, that is a great opportunity to invite you to get to know Academic Sinica and Taiwan, especially now we are focusing on more interdisciplinary research. And also, on the other hand, at a governmental level, our government is promoting the so-called digital democracy. For example, now we have a new ministry called Ministry of Digital Affairs, trying to digitize the data and also to prevent misinformation and other kinds of attacks. And of course, probably stereotype of Taiwan is that we are quite strong in computational engineering, although it takes a lot of time for social scientists to communicate with engineers, because computational social science is not just about computation, but also about social. But still, I think this is a great asset in our country. Okay, now you might wonder how everyone is invited to the workshop. So let me start with my scholarly lineage. Okay, here's me. Okay, I actually have two lineage going upwards. Okay. They are James Kiss and Catherine Stovall. Okay, I followed James Kiss to do computation model. That was during my graduate school for my master thesis. Then I followed Catherine Stovall and to do experimental work. So this is my right hand and my left hand side. And because I graduated from University of Washington, then I get to know Xiaoyu sitting right there. Okay, so we are all so-called UW people. Okay, okay.
I'm also from UW.
Oh, really? Okay.
I graduated in 1992.
Okay, okay. So we have another anonymity. Okay, great. James Kiss go always all the way to Michael Macy. Michael Macy is very important in sociology doing computation modeling. And now here we know that Professor Sato also has some collaboration, friendship with Michael Macy. And the other lineage go all the way to Peter Bierman. And I know that Siqi is right there. She's doing work with Peter also. Okay, and Professor Higashi, and we are serving in the same editorial board. He is the editor of a journal, Computational Social Science, which he's going to talk about tomorrow. Okay. Of course, I'm trying to build some weak tie to Professor Mukherjee in Singapore. I know there are not quite many computational social science in Singapore, so welcome. I'm very glad to have you join us in the workshop. And of course, I'm surrounded by a lot of very supportive and beloved colleagues. Shen Wei is over there, and Da Qian is over here, and Professor Fu is over here. Wenqin is over there. Okay, they are all very great people to talk to and work with. And through the contact of Professor Fu there, and then we have Professor Martin. He is going to visit us for over the next 2 months. So welcome. I hope you enjoy the visit. Okay, so everyone here in this room is connected some way or another. This is a small world network, okay. Now, then I would like to give you some useful information for the next 2 days. Here's the floor plan of our institute. Most important of all is that here you have, okay, never mind. So the conference room is on your right-hand side, and the coffee and snacks will be served in the reception and lunch area in A. And if you want to go to the restroom, go along the hallway, and the restroom will be on your right-hand side. Okay? Wi-Fi is right here. Feel free to log in to use the Wi-Fi. And we also have 3 ushers, Chang Xianghao and Wang Yizhu. Oh, she's not there. Okay, over there. Okay. And they are each probably not here. Okay. If you have any question, just go to them or go to me. Either way is fine. Okay. Now, some tips for presentation. We are using microphone not because that your voice is soft or not, because actually we are now making live broadcast online. Okay, so we also have online participants. So it would be great that if you use microphone rather than just speak out. Okay, and also we provide pointer right here and here, just in case. I know it's difficult. We have two different screens on either side, so it's not easy to choose one to show to the audiences. But feel free to use the pointer. Okay. So that's all I want to share with you before we start the workshop. Any questions? Okay, let's begin. The first section is going to be mediated by Professor Fu.
Good morning. We are going to start a workshop with a keynote speech by Professor Martin Everett, even though we did not use the word keynote on the agenda due to the nature of the workshop. Professor Everett has both bachelor and master's degrees in mathematics and a DPhil in both mathematics and sociology from Oxford. After teaching, doing research, and being top administrators, such as vice chancellor at 6 different universities in the UK and the US, for nearly 3 decades, he has been a professor in the Department of Sociology and the joint director of the Mitchell Center for Social Network Analysis at the University of Manchester since 2009. Professor Everett has published very widely. He is one of the co-authors and designers of UCINet, a highly popular software for social network research that has a user base in more than 140 countries. For his outstanding work in social network studies, he has won several key awards, including the Zimmel Award from the International Network for Social Network Analysis, or INSNA. In 2004, he was elected as an academician of the British Academy of Social Sciences. Professor Everett has also served as the president of the INSNA, the co-editor of the journal Social Network, and the current co-editor of the journal Network Science. His most recent title, a visiting scholar of the Institute of Sociology at Academia Sinica. How fortunate we are to have him attending this workshop in his first week of visit. His speech is Computational Social Science, History, Challenges, and Opportunities. Professor Everett.
Thank you. My first challenge is to get the technology to work, of course. Yes. So, let's find it. That's one of these. Can't be, not that one. Is it this? No. Okay. Why is this not worked before? Yeah, it's on this. Where is it? Oh. Okay, that's better. Okay, here we go. Okay, first, thank you so much for your kind words and the invitation to speak here. It's an honor to be in Taiwan to start with. This is my third visit to Taiwan. I first came in 1989. It was a very different country in 1989 to it is now. Nobody spoke English in 1989. At least I couldn't find anybody who spoke English. Okay, I just really want to talk very generally. I'm actually drawing on works of lots of other colleagues, so this is not particularly, it's my take on a lot of their work, so I don't want to claim this is entirely mine. I want to be a bit more general. When I think about computational social science, the first thing I thought about was what exactly is computational social science? So I decided to ask ChatGPT what it thought computational social science was. But first of all, let me just briefly, you've had a brief thing to me, a little bit about me. So I said I was basically started as a mathematician. I did a first degree at mathematics at Loughborough University. Then I went to Oxford University to do my master's and my DPhil. That's what they call a PhD at Oxford, in case you wondered about that. And really unusually was my DPhil, I had two supervisors, one who was a mathematician and one was a sociologist. And that was in 1980, and I assure you that kind of interdisciplinary thing was very unusual back then. To point out that I was not a statistician, but a mathematician, which is very different. Okay, so what did ChatGPT say? It said, computational social science is an interdisciplinary field that utilizes computational methods and tools to study social phenomena. It combines elements of social science, computer science, statistics, and data science to analyze and understand various aspects of human behavior, interaction, and society. Computational social scientists often leverage large-scale data sets from diverse sources such as social media, online platforms, government records, and surveys. And in the end, I thought that's a pretty good definition when I actually look at it. So I do have to take my hats off to the people that do that. It then goes on. It goes on to expand in 6 different categories, which include data collection analysis, modeling and simulation, network analysis, text analysis and natural processing, social media analysis, and it talks about ethical and privacy considerations. So it's pretty thorough coverage in what it actually does. But I wanted to pick up on the one thing that it said, network analysis. And if I look at that, it says network theory is central to computational social science, as it provides a framework for studying the structure and dynamics of social networks. Researchers analyze networks of social connections, such as, and it goes on to explain what it's about. I think what is interesting is the way that it's decided that network theory is so central to computational social science. I think the reasons for that are actually quite important. And I really want to talk about why those reasons and what we can learn about the success of social network analysis in terms of what that can help us to direct what we want to do in computational social science. Let's look at the rise of social network analysis. There's been an exponential increase in papers published, and there's been expanding fields of application. I came to social network analysis in 1976, was the first time I looked at it. And if I had to look at the work there, as you can see, I've taken a 5-year period slightly before I was there, but 69 to 74. If I looked at articles that had the word social network analysis somewhere in the article, there were just 20 papers. So what that meant is when you did your PhD, it was actually really easy. There was a lot of very easy things to do. The trouble was, of course, nobody read what you wrote. But if I look at the period 2014 to 2019 with the same thing, there's 106,000 papers. So that's a dramatic increase. The more recent period, it appears like the numbers dropped. But I suspect the answer is the number hasn't dropped. It's just people do not have to say social network analysis because people know what the discipline is, so they can actually go straight into using the tools of that analysis without actually saying, I'm doing social network analysis. I might be wrong, but I suspect that that's true. A quick graph of those early years shows you the takeoff point was really mid-1990s into the 2000s. And the thing then to say is, what were the reasons for that? Well, the reasons for that were quite obvious, I think. First of all, development of software and textbooks. More and more people could read about this, the Wasserman and Faust book for people that know about social networks, and the development of software tools that were very general. Before those general tools, anybody who wanted to do this analysis had to write the computer programs themselves, and that wasn't a very popular thing to do, particularly amongst social scientists in those days. Obviously, the advent of electronic data collection and the expansion of computers in general, all at the same time. The multidisciplinary interest that's come from information computer scientists, more recently the physicists, development of the area of network science, the expansion of application areas. Really now, if I look at social network analysis, I really see it as a branch of network science in general, but just with the added thing that in formation of the networks, we require agency of the individuals. So I'm not interested, like some network scientists are, in protein-protein interaction networks, because there's no agency there, there's just a chemical process. Some history I'm sure you all know, but I think this is actually important. Many people would actually chase back, in terms of sociology, back to Simmel. He first person talked about dyads and triads of individuals and kind of introduced the structural approach. The work of Moreno here on the left, bringing to the sociometry and developing the idea of the sociogram, the first real networks that were actually drawn. If I look at, here is one of his Moreno's sociograms taken from his book, and it's about attraction in a fourth grade classroom. He's drawn it such that the females are, I think, the circles and the males are the triangles, and there's showing about the attractions between the two. As we can see there, that the males are only interested in the males, the females are only interested in the females, but that's because it's a fourth grade classroom. If I look 2 years later, it would be a very different picture. I briefly want to mention Manchester, as I'm at the University of Manchester. The work of John Barnes, first of all, in terms of becoming more formal in the way he applied various things to social networks. And then the work of Elizabeth Bott, who wasn't at Manchester, but she used to visit Manchester all the time and was considered part of the Manchester group. And she really came up with the first theory that involved networks to explain certain things about how structural classes changed, particularly in the UK, how people changed class, about the connections they all had. I have to mention J. Clyde Mitchell, who developed a lot in the field. He was the first person really to integrate a lot more graph theory and data, the networks ideas. And he produced the first book on social networks in 1969, called Social Networks in Urban Situations. And he was my supervisor at Oxford. He was at Manchester, and that's why we call it the Mitchell Centre at the University of Manchester for Networks. Okay, how about some success stories from social network analysis? So I'm just going to run through a few of which I think are the big ones. This is Stanley Milgram, of course, psychologist, very famous for pretending to electrocute people. But his work on Small World is what the social networks community knows, and the 6 degrees of separation. To point out that actually, okay, this was developed just by a simple experiment that he was actually doing. But it's been taken on, and people actually have picked this up within the whole social media field. And one example I like to give is for those of you old enough to realize that before Line or WhatsApp, people used to communicate with MSN Messenger. And basically, nearly everybody in the world, that was the mechanism for communicating. And in 2007, the data was analyzed. There were 180 million users. There were 1.3 billion edges between them, and they worked out the average distance, and that was 5.5, which I just round up to 6, showing 6 degrees of separation, even on this big data set that we're used to looking at these days. Okay, so that's this kind of small world idea. Homophily, the 3 individuals here, on the top left is Miller McPherson, on the right is Lynn Smith-Lovin, and on the bottom left is James Cook. They didn't really invent the idea of homophily, of course that's a lot older idea, but they wrote a very seminal paper called Birds of a Feather, in which they brought together and harmonized in terms of networks lots of things about homophily. What we have to see now is this is still a big area. Again, if I look at it in the kind of small world idea, these are, this is a euphemism, these are acquaintances among drug users. These are people that share needles, and these are heroin addicts. You don't ask them who you share needles with, you ask who you're acquainted with, and they only tell you people they share needles with. But if we look at the racial profile there, we see in the green are African Americans, the red ones are the Puerto Ricans, and the US white are yellow. And we can see very clearly that they all clump together showing homophily. Okay, that's in that kind of data collection, but let's go on to big data. This is a classic image. These are Democrats and Republican bloggers, and it's whether they're responding to their own blog. And we can see basically that the Republicans respond to the Republicans and the Democrats respond to the Democrats. And in the US, the bifurcation of the political parties is getting more and more strong as time goes on. So homophily has been taken on, picked up, used by the big data people. And I really had to mention probably the most cited paper in sociology from Mark Granovetter on the top left, The Strength of Weak Ties. I've also thrown together Ron Burt for Structural Holes. Both of these are the kind of similar ideas. There are differences, and you can read papers about what the big differences actually are. But they are still about how you can lever things within networks to your advantage. And a big data example, I'd say, from The Strength of Weak Ties would be actually LinkedIn. Which actually, in a sense, capitalizes on the idea that it's these kind of weak connections that allow people to get jobs in different fields. So all of these things are good examples, I think, of social network analysis, and that's gone on to actually be a major part of the field, but has been picked up in the sort of computational social science as a whole. Can I mention two other examples? Oh no, I thought I had to put Nan Lin in. And social capital, as I know he's doing a very important role here in the summer. Obviously, Nan Lin didn't invent the idea of social capital, but he actually put it in terms of network forms. In particular, the way he did the networks for us is for bridging social capital and brokerage social capital. Again, things that have been picked up and used extensively within the whole computational social science area. Now this example, if you don't know, on the left is Barabasi, on the right is Albert, and they came up with the big statement that basically all networks are scale-free, that they actually, and in fact I meet a lot of network scientists and they say, well, you know, all networks are scale-free. I just want to bring your attention to this paper. A paper by Brodio and Clausette, I don't know, it's in Nature Communications in 2019, and they took 1,000 different networks and they tested rigorously whether these networks were scale-free. They had social networks, biological networks, and technological networks. Not one single social network was seen to be scale-free, and very few of the others were scale-free at all. It's complete nonsense. Networks are not scale-free. As they point out, they're actually log normal. It's a far better fit. There are some examples. The World Wide Web probably is an example of a scale-free network. It's probably one of the only ones that there really are. So basically what we've got here is something that's became very popular, it's very attractive, but is probably wrong. Let me give you another computation example that's non-network. I thought I'd better give a non-network. I don't know if people know about the Google Flu Trends trial. What they did, they launched in 2008. They launched something which they said would predict infection rates better than the method that was currently used in the United States. In the United States, it was done by sampling. And they basically, Google said, oh, the trouble with that is it's 2 weeks out of date. We can do it far better. So they examined the search behavior on flu symptoms and made predictions about what the actual infection rate was. But when it came to actually finding out what their prediction was like, they dramatically overestimated the level of the flu. So why was that? In both these cases, I think these two cases of failure of bad computational social science, the answer is the data is not fit for purpose. And the scale-free, there was insufficient data in size and diversity for them to really make the assumptions that they made. They looked at too few examples, and they didn't really analyze it in the way you should have analyzed it. So the methods weren't totally fit for purpose. In Google Flu, the big confounding effect was the algorithm itself. Basically, of course, Google looks to see what people are searching and makes recommendations to other people based on what other people's searches were. So if people started searching for flu symptoms, then actually, if you went in and looked for something completely different, it would just say, oh, I bet you're looking for a flu symptom. And it would add that in, and then people would click on that. So basically, you got the confounding effect of the algorithm itself exaggerating what people would, encouraging people to search for things they wouldn't have searched for before. A sociologist would call that reflexivity, in a way. It's a kind of new form of that. That's David Lazar is the person who came up with this idea of this kind of technological reflexivity. So why were the other things successful? Well, I think the most important things from these, that they were hypothesized ideas from observation and theory. They were not actually starting with the data. Yeah. The data that was collected in order to test the hypothesis. In other words, they made sure the data that was collected was fit for purpose. None of these ideas started with the data. They started with other ideas. And when they did start testing them, the examples we've got here, all were done initially on small data and then extended to big data. And those examples I gave you was this extension from small data to big data. Some people I know start calling the small data fat data, because it's richer in context. And because it's richer in context, then we can delve deeper into it to get a better understanding. When we've got that understanding, only then do I think we should extend it to big data. So what we're really saying here is, I think what was crucial for those successes was the micro-macro link, which they utilized completely. So what are my issues with big data? What have we got to be aware of? So what we've already talked about, that reflexivity idea, the fact that the algorithms are actually driving a lot of people's behavior. And we have to remember various things about how people use big data. Other answer reflexivity is the idea that you use a virtual private network to hide your location, something that's pretty big in Russia and China. Distort pictures. People distort the pictures to prevent facial recognition, for example, or just to hide their identities. Very important thing is that the media itself can affect your behavior. Some actors, for example, behave differently on different platforms, and perhaps that's what people here do. And obviously, a very obvious statement, Facebook friends are not friends, and it's very different from your LinkedIn contact or your Twitter, X, connections, etc. All these things are very different on different platforms. But I think what's very important is the interaction between what the media actually is and how it affects how people behave. I don't know if people are familiar with something called the 61 million person experiment. If you are, then I'm sorry. If you're not, let me explain what happened. Basically, this was something that was set up on Facebook. And basically, what they did was they sent a message to just over 60 million people who were over the age of 18 years of age, and that was on the congressional elections in the States. So these were just people in America in 2010. And this message went straight to the top of their news feed. That's the first thing they saw. So these 60 million people saw this. It says, today's election day. Find your polling place on the US politics page and click I voted button to tell your friends you voted. And then at the bottom, they had pictures of various friends and said, these and 18 other of your friends have voted. So they had pictures of the friends. So that was to that 60 million people. They sent a different message to just over 500,000 people. All they did was they sent exactly the same at the top, but they didn't put the bit at the bottom about your friends have voted. Okay? And then they decided to find out what difference did this make, if any. And the answer was the users who saw the faces of friends were 2% more likely to vote. Now, 2% probably sounds like a very small number, but it's not a very small number. For example, in the presidential election, George Bush beat Al Gore in Florida by just 537 votes. That's just 0.01%. So basically what this is saying is that Facebook itself could actually swing an election. I mean, 2% is enough to swing the election. They could have sent that message just to people that said they were Democrats, or just to those that said they were Republicans, and that would have changed the whole nature of politics. I think the important thing, though, is the way that actually the social media has affected somebody's behaviour, and we've got to be really aware of that. A problem is that the data is not designed for research. Yeah, the demographic attributes are often not known. We've got the problems of whether there are bots there or not. I know there's lots of technology to detect whether there's a bot doing something, but the bots are getting cleverer at circumventing that technology. It could be a whole group of individuals. And so as a consequence, things like Twitter papers are about tweets and users. They're not about behavior. Yeah. We have to remember all the time that algorithms are designed to increase engagement or to make people spend money. That's their purpose. Their purpose is not to actually collect data. They just happen to do that on the side. And of course, the fact they're controlled by media corporations doesn't really help us very much in terms of us as social scientists trying to do some serious work. We have to remember, of course, as well, that anybody using any media platform, they're not going to be representative. Users of any system are always from some socioeconomic category. Yeah? And these change over time. Yes? Young people now don't use Facebook because their parents use Facebook. And further back, of course, it was just university students. And if I go far back enough, it was just Harvard University students. So we do have to realize the time component of the data and how people's behavior changes when they use this over time. I think that's very important. So outline lots of problems I actually see with this that we have to be aware of. So what are our solutions? Well, obviously to acknowledge the shortcomings in data and not to make unjustified generalizations. It's very, very easy to make these sweeping generalizations. And as social scientists, we're perhaps guilty of doing that in lots of other fields as well. Try and triangulate any findings where possible. Yeah, try and find some other method by coming to the same conclusion, some other techniques, some other data sets in particular. I would say start at the micro level and develop micro-macro testable hypotheses. That's the key. That's the way to do it. And make sure your research questions are consistent with your data. I want to finish with one final example because I want to show you how it can be done and can be done well, because I think this is. I talked about one Facebook study which was worrying. I want to talk about another Facebook study. I don't know if people know about the Facebook 2020 study. It's a joint project of academics with Meta, i.e. Facebook. But the academics are in charge of the research design entirely. Meta could reject only for legal, privacy or infeasibility reasons any request they had for collecting the data. They did a platform-wide analysis and plus put some experiments in place and did some surveys on a sample of users over a 3-month period. And these were 4 areas relating to the 2020 election. Okay? There's a whole series of papers about this study. I'm just going to focus on one because I think it's good. One area. Basically, it came to the blatantly obvious statement that algorithms are extremely influential in terms of what people see and in shaping the online platform experience. That is hardly a surprise. We already knew that. There is significant ideological segregation in political news exposure. This again is the United States. Going back to the blog thing I showed before, we actually know that as well, but it was nice to confirm it. But then the real thing was algorithm adjustments significantly changed what people see and their level of engagement, but did not notably affect their political attitudes. Now that is a real finding, in my opinion. And that finding was only possible because the social scientists went in there and did a properly well-designed experiment and survey to find out how people would actually behave given the knowledge they had of the first 2 parts there. They did not make the assumption, which a lot of people did before them, that this would affect their behavior. They understand that the media, the network, the whole thing is not about behavior. It's about the media itself, and the behavior is something completely different. And I think we should be very careful to make sure we separate those things out. Okay, on that positive note, I just want to say thank you and ask if there's any questions. Does that say any questions? I don't know. Any questions? Or comments, or, yeah. Yeah.
Yeah.
Dr. Everett, Yuan Xiao here from the University of Washington. Great talk, I really enjoyed it. Okay. A lot of questions, but I'm going to focus on the last one, on the Facebook study. So one of the critical findings in the Facebook study was that though there were effects on how information was basically diffused, as well as how people engage online, essentially there were very little effects on offline types of things. For example, political attitudes, and as well as 20 other outcomes. Then, what are your thoughts on this whole algorithm hype that is still currently dominating pretty much the field of communication as well as media sociology? Do we still need to focus on these effects of algorithms, or are they just in terms of linking to offline behavior? Because you mentioned two different things that are superficially contradicting. The Facebook study on voting showed that there is actual offline effects between the two messages. But then this much newer 2020 Facebook study shows that there are very little effects on a whole suite of political outcomes. So I'd love to hear your thoughts on that.
Sure. I mean, I think the most important thing is that they were very, very different in terms of, one was just about posts and how people are looking at posts. And I think people's attitude to posts are changing. People are becoming more and more aware of algorithms themselves and realizing that they're seeing this stuff, but actually that's just because this algorithm's thrown it at them. And I think, therefore, their behavior in that respect was actually different from that earlier one, where actually that was a deliberate attempt to try and see what people were actually going to do and encouraging them to take an action. Whereas the other one, they're not encouraging to take an action, they're kind of providing them with information. And I think that difference between encouraging an action and just providing information is the reason. I agree with it. It does look like they're contradictory to each other, but I think that is a big difference. And I think people are getting more and more skeptical about the information that they're actually receiving from these different platforms. I could be wrong on that, and it'll be interesting to see. But I mean, there are obviously some groups for whom it really does get action, but we're now getting into kind of more the extremist groups, the people that actually completely immerse themselves in some really odd area of things that we would consider completely outrageous and stupid, and there's lots of examples of that. But I think outside of that group, then people are far more skeptical about what they're actually reading, and so that they're moderating their actions because of that. But I could be wrong. We need to find that out. Yes.
Conventional social network analyst in sociology think that network scientists and computer scientists are invading their territory. But I think introducing such cutting-edge technology in sociology is a good way to open the door to new research fields. So do you have any suggestion to promote good collaboration between sociologists and computer scientists and network scientists? Yeah,
I think the trick there is finding the right computer scientists, and they are there. I know, I now edit the journal Network Science. Before I edited Social Networks, and if I go to some of the big conferences in which there are both social scientists and computer scientists, mathematicians are there, then I do find individuals there that are willing to listen and talk to people from the other discipline as far as they're concerned. And I think we need to focus on those individuals, the open-minded people. And there are a lot of them. There are also, yes, another minority, another group that are very much within their own computer science and think they've invented something new when sociologists usually invented it probably 70, 80 years earlier. But most of the time, most academics are quite open to communication and being told, oh no, this has already been done. But I think it's about you getting interdisciplinary teams together in which people learn the language of the other side. And that language difference is really important. And there's so many misunderstandings between the two groups. I mean, if you just take the word theory and start saying, you know, what a sociologist means by a theory is very different to what a scientist means by a theory. And if you ask what a mathematician what a theory is, well, you know, that's graph theory. And actually, a scientist would say, well, there's no theory there. It's just a collection of mathematical results. And so it's terms like that which there's misunderstandings between everybody and what the objectives of the fields actually are. But I do see in computational social science, these things are coming together. And I have great hope for the whole area. I think it's, you know, as you say, you know, these amazing tools that these people actually have developed, often for other things, are perfect for some of the things that we want to do, as long as we interpret that correctly and we understand them correctly. But it's a tough thing to do, I still think. There's a lot of people that actually are not really listening to what the social scientists actually say, and they should listen. I've done it. You know, I was a mathematician, and you know, a lot of people think I'm a sociologist, which is good. Yeah, I'm sorry.
I'm sorry. Okay.
Hello. Yeah. So yeah, thanks for this great talk. I'm Shubhayan Mukherjee from National University of Singapore. I mean, I agree that, you know, there's a lot of computation social science happening these days, much more than what has happened in the past, and that's largely due to, you know, greater access to data and greater access to computing power. But also there seems to be kind of a problem with data access again, right? Where as more and more, I mean, with Twitter or X and Facebook, you can't just. So, for example, the last study that you mentioned, the large Facebook, there were like 4 or 5 papers out of that. That study couldn't just be done by anyone, right? You needed people in Facebook, you needed connections there in order to get, so I think in the last year, X stopped their API, Reddit stopped their discontinued their API, Facebook had discontinued long ago. So how do you see, how do you square the burgeoning field with the potential limitations of, you know, lesser and lesser access to data?
Yeah, I don't think I can square that. I think, you know, it's a fundamental problem that, I mean, the Twitter example was great. Elon Musk managed to turn that off in the week I was going to demonstrate to my students how to get Twitter data. And I couldn't work out why it wasn't working. It was because he didn't bother to announce that he was going to do it, just turned it off and then announced it afterwards. So, yeah, there's a lot of historical data, of course, though, and we can use a lot of that data that's available. I mean, you know, Reddit has been backed up forever, and it's all actually there. But unless we can build relationships with these organizations, like the example with Meta we've done there, then we're going to be cut off from that data as far as I can see. And, you know, data protection laws in different countries are different as well. That gives us another problem. We also have problems, I don't know what it's like here, but in the UK, to get things through our ethics board, if we want to try and collect certain amounts of data, is nearly impossible. They don't understand what this data is. But the only way is for us to make relations, unless governments start changing the laws, saying, you know, this data's got to be made more freely available, but I cannot see that happening. And so I think we've got an increasing problem, and it's, as you say, it's getting worse. You know, we used to be able to get, you know, when I first started, I could download the network of my Facebook friends. Yeah, that got stopped. Yeah, you know, Twitter data was kind of easy to get. It wasn't quite easy to get because you didn't quite know what the sampling strategy was, but you could at least get something. The fact that now you've got to pay for that, and it's quite expensive. I mean, you can get it, at least we can still get it, but we have to pay for it. Whereas certain have never allowed, I mean, I think Snapchat has never allowed access to anybody, regardless of how much you've got. I don't know what Weibo does, maybe people here know, no, I wish I could come up with a solution, but I don't think there is a solution. It's got to be making contacts with these organizations and making those contacts in the way I think was an example I gave here, where it was very clear that the academics were in control of the research design, and the only objection the organization could make for data collection was that it was in some way was against privacy. It was or it was actually impossible. You know, that was the other thing they said in there. You know, well, we don't have that data, so you can't have it because we didn't collect it. How you go about doing this and getting into these organizations, I don't know. I think the most common way would actually be that the people that we're now training as computational social scientists, they do get employed, and hopefully we keep those contacts with them, so we use our extra contact with them via our students.
Like sleeper agents.
So,
Okay, thank you. I'm told the time is up, but I don't.
This is the final question for the session.
Break. Sorry.
You're going to ask him during the break?
Need a break. Yeah.
Okay. So,
Okay, well, thank you all very much.
okay, thank you. Thank you so much. Now, our second speaker is Professor Yoshimichi Sato. He's one of the leading sociologists in Japan and East Asia who has a very broad and deep knowledge in sociology and has published widely in some mainstream subfields. He has won several awards for his outstanding work and was elected as member of Science Council of Japan. Professor Sato founded the Center for the Study of Social Stratification and Inequality, or CSSI, at Tohoku University. He is now Dean of the Faculty of Humanities at Kyoto University of Advanced Science. One of his latest research efforts is to bring sociology back to computational social science. His speech is The Sociological Foundations of Computational Social Science.
Thank you. May I connect my computer?
Oh, okay.
Oh, I'm sorry.
100.他刚没有，他说他没有。他用他。
I'm sorry about this.
Type C.
Yep.
Okay.
Oh, this works.
Me.
Thank you. Hi, I'm Yoshimichi Sato from Kyoto University of Advanced Science. I've been affiliated with Tohoku University in Sendai, Japan for more than 3 decades, and I moved to Kyoto University of Advanced Science last year. And when I was in Tohoku, I conducted a huge-scale social surveys in Japan, Taiwan, and Korea in 2005. At that time, that was the first time I came to Institute of Sociology, Academia Sinica, and Professor Fu gave us a great help to conduct a survey in Taiwan. So Institute of Sociology is a kind of my third working place, because since then I was invited to the Institute of Sociology many times. So this conference room is a kind of my home ground. So I'm very, very happy to come back here. So today my title of my talk is Sociological Foundations of Computational Social Science. Let me take this opportunity to make advertisement of my book. So I co-edited a book on titled Sociological Foundations of Computational Social Science, and it will be released soon from Springer. So I think it will be published this month. So I contributed 2 chapters to this book. So today my talk is based on the 2 chapters. So I'm a sociologist by education, but I recently got interested in computational social science. However, I feel a gap between sociological tradition and the computational social science. So my motivation of my book and today's talk is how can we bridge the gap between sociology and computational social science. I'm going to the details of this, but before that, let me talk about a little bit about computational social science and sociology. I could skip this because Martin gave a detailed explanation of computational social science. But to my understanding, computational social science has 2 main pillars. One is the agent-based modeling, in which researchers create a lot of agents, people, actors on computer and have them interact with each other and to see the results at the macro level. So agent-based modeling is a good tool to study analyze the micro-macro link, which Martin mentioned. And the second one is, of course, the big data analysis, or borrowing the terminology in computational social science, data trace data analysis. So data is collected from blogs, home pages, SNS, and mobile phones, and so on. And statistical analysis, especially the Bayesian modeling, are used to the analysis of such big data. So Martin mentioned one founding father in sociology, Jimmel. So let me talk about another founding father in sociology, Max Weber. So Max Weber emphasized the importance of meaning and interpretation in sociology. So one basic sociological question is this: how does a person interpret others' behaviors and add meaning to it? So for example, I'm not sure if you know the story about it, but this is a very popular story in Japan. Suppose there are 2 actors, A and B, and A want to kill B. Then A go to a Shinto shrine after midnight with a doll, straw doll, with a sheet of paper on it. I mean, with a sheet of paper with the name of B on it, and put it put the sheet of the paper in the straw doll, and the actor A has a very long nail, and he hit a nail into the straw doll to the wood, expecting A could kill B. So then actor C came into the picture. So actor C happened to watch A nailing down the doll. So in the beginning, actor A doesn't understand what A is doing. However, if actor C knows the internal world of actor A, actor C can understand the meaning and intention of actor A's behavior. So driving a nail into a straw doll, so let me. So within the cognitive scheme of actor A, driving a nail into a straw doll would cause the killing B. So there's a subjective, not objective or scientific causal relation, but in actor A's mind, there's a subjective causal relation between nailing the doll and killing B. So if observers understand such inner world or the cognitive scheme of actor A, then they could understand the meaning and the intention of actor A's behavior. So this is a very important point in sociology, and if you are interested in it, I recommend Berg and Luckman's book on the construction of reality, social construction of reality, which was published many years ago, but still we can learn the importance of meaning and interpretation in sociology. So this is the basic idea behind my talk. So then I'm going to talk about how to fill the gap between agent-based modeling and sociology, and big data analysis and sociology. The strength of agent-based modeling is that, as I said, it creates a virtual society, and in which a lot of actors, which are called agents, interact with each other at the micro level. Then they produce the macro level result. So agent-based modeling makes a clear linkage between micro and macro levels. And researchers can manipulate a macro factor to study its effects on another macro phenomenon. So Michael Macy and I created a model and published a paper in 2002 on the study of the emergence of trust and the market. So we manipulate the mobility rate, so people mobile geographically, and how the mobility rate would create a trust and market. So a certain mobility rate forces some agent to move between neighborhoods and become newcomers. Then neighbors or locals learn to trust newcomers. Then they gradually learn to trust strangers. So they have confidence to enter the market and trust strangers. So adequate level of adequate mobility rate promotes trust and market formation. However, if the mobility rate is very low, nobody moves. So locals don't have opportunity to learn to trust newcomers and strangers. And if mobility rate is very high, there's no stable neighborhood. So there's no school in which locals learn to trust newcomers and strangers. So the effect of the mobility rate on trust and market is a U-shaped pattern. So this, I would say this is a very good model, but there's a gap between agent-based modeling and sociology. So, as I said, sociology focuses on the importance of interpretation and meaning. So, this person, suppose this person observes the face of this person, and she doesn't know the meaning of this facial expression, but somehow she began to understand the meaning of the facial expression and interpret the intention of this guy. On the other hand, agent-based modeling, agents learn from result of interaction, behaviors of himself and other guys. So this agent doesn't interpret the meaning of the behavior of this guy, just observe the behavior of this guy and change the behavior of oneself. So this is the gap between the agent-based modeling and the sociology. Then there's a very nice example to bridge the gap between the two disciplines. So we could assume agents with cognitive capacity. So Goldberg and Stein proposes a very interesting model. So they talks about studies the contagion or diffusion of new items. So this is a simple contagion process. Suppose this person A smokes and B observes A smoke. Then, in a simple contagion process, B began to, so B knows that he can smoke, he or she can smoke, then he smokes. So it's a very simple process. However, in the process B, so B observes A smoke, then B interprets the meaning of smoking and connect it to other behaviors. Then he or she calculates he or she evaluates the meaning of smoking, and he or she decides to smoke at the probability of this one. So this is the basic theoretical scheme Goldberg and Stein proposes. And they constructed agent-based modeling using this cognitive scheme. So they call it associative matrix. So each agent has an associative matrix and change the association probability between two behaviors and change the matrix by observing behaviors of other agents. So this kind of interaction between cognitive schemes would be a fruitful way to advance computational social agent-based modeling in sociology. Okay, let's move on to big data analysis and sociology. I don't need to do that because Martin explained the strengths of big data analysis, but Matt Sargani, who was a grad student of Michael Macy's, published a nice book, Bit by Bit, in 2018. And in the book, he proposed three strong points of big data analysis: big, always on, and non-reactive. So these are good characteristics, but conventional social surveys, such as going to the respondent's home or working place and ask many questions using questionnaires, miss these points. So utilizing these good characteristics of big data would advance the study of social science. However, still there's a gap between big data analysis and sociology. Big data analysis deals only with behavioral data such as mobile data and export. Martin talked about big data analysis deals with tweets, not the behavior, but tweeting is a kind of behavior from my viewpoint. So now, not the tweeting, but the posting on X is a kind of behavior. And if you move around, then the cell phone company can correct your mobility data using the GPS. So, but they don't know the intention why. So suppose the cell phone company in Japan detected I'm here, but they don't know why I'm here. What my intention of being here. So they can only understand the behavior, my behavior, not my intention or the meaning I added to my behavior of being here. So it really focuses on meaning and interpretation. So the gap hinders it from entering the mainstream in sociology. So here again, I found a very nice example of bridging the gap. So a theory of culture carrying capacity by Bell in 2016. So the background of this study is a frame theory in the study of social movement. So social movement organizations try to, of course, all the social movement organizations try to recruit more and more people to their movement. So to do that, social movement organizations try to align their frames with frames of target people. For example, I think you still remember the Fukushima nuclear power plant accident after the great earthquake in Japan. And then a lot of social movement organizations emerged. But it's difficult to persuade people in Tokyo far away from Fukushima to join the movement. If a social movement organization said that, okay, nuclear power plant is dangerous even to Tokyo, then the people in Tokyo would not be mobilized to the movement. However, if the organization says, okay, if the accident occurs in Fukushima, radioactive materials would fly to Tokyo, and your children would be in danger. So then this kind of framing would make a good introduction to the parent who are raising small kids. Well, my kids will be danger if the nuclear power plant accident occurs. Then such parent would join the movement. So this is called frame alignment. So then Bell's research question is how do so he studied organ donation advocacy organization. So his research question is how do organ donation advocacy organization align their frames with those of their target to induce target people to engage with them. Then he made a hypothesis. Diversification of topics in the message has an inverted U-shaped effect on the number of the mobilized people. So if the topic, diversification of topic is very low, so for example, if a mobile organization talks about baseball players, okay, famous baseball players join us and sign up for the donation, then you are not interested in it because you are not the big fan of professional baseball. You are fan of soccer. So, okay, it's not my business, right? I'm interested in sociology. I'm not interested in baseball. So it's not my business. But if the organization talks about baseball players and famous sociologists at the Institute of Sociology, okay, professor who signed up for the donation of his kidneys or something, then grad students at the Institute of Sociology may be interested in it. Well, I should follow Professor Fu or something like that. But if the organization talks a lot of topics of not only baseball, Institute of Sociology, but say foods, music, and so on, then people think this organization is not coherent. So they will not join the organization. So the adequate diversity of topics is important to have more people in the movement. Then Bell created a Facebook application and distributed it to many organizations. And so organizations have a benefit of installing the application because Bell and his colleagues would give advice to the organizations how to increase the mobility, increase the number of people who participate in the movement. In return, the organization, so Bell can collect the Facebook data from all the organizations participating in the research. Then he applied a structured topic modeling to the data, and this is a beautiful result of his analysis. So this is the horizontal axis is a coefficient of discursive variation, which is a measurement of how the topics are diversified. And the vertical axis is the number of engaged Facebook users by day. Then If the variation is low, the number is small. But as you see, this is an inverted U-shaped pattern here, and the diversity is very high. As I said, the number of the participants would become lower. So here again, very clearly introduced the interpretation and meaning to his analysis of the big data collected by Facebook application. So here's my conclusion. So as I said, computational social science is a powerful, innovative tool. However, it needs to incorporate meaning and interpretation in its application to sociological studies. So focusing on meaning and interpretation will realize a win-win relationship between computational social science and sociology. As I said after Martin's talk, some sociologists think computational social scientists are invading their traditional territory, but I would say it's a good opportunity for sociologists to open a new door to the high-level research. So sociologists can attack their main research question. Oh, I'm sorry. I need a power. Maybe I could join the anti-nuclear power plant movement because I need electric power. Okay. So if computational social science is equipped with the study of meaning and interpretation, with the help of computational social science, sociologists can attack the main research question with the powerful tool, computational social science. On the other hand, computational social scientists will have opportunities to open new doors to new research fields inspired by research questions asked by the sociologists. To my knowledge, so far, computational social scientists have not been interested in meaning and the interpretation of the people they study. But if they study the meaning and the interpretation with their strong tools, maybe computational social science itself would open a new door to the wonderful, interesting research fields. And here are differences. So if you are interested in it, in my talk, there are some interesting books and different papers here. Thank you very much.
Thank you very much, Professor Sato. We are open for questions, comments. Jensen first, please. Jensen. Jensen.
Yeah, very insightful reflection. I'm glad that you brought a very important point that bringing interpretation back to the equation. But here my concern is that, in sociology, we have too many interpretations. Because we know that given as a result, 10 sociologists have 11 theories, right? And the difficulty is that it's not easy to validate which one is true, right? For example, you showed that the Bayes result, the U-shaped thing, right? I mean, I'm sure that mathematically you can definitely come up with more than one model to replicate that result.
right.
So I think the key challenge, in my opinion, is that how to. I mean, it's good to bring interpretation back to the discussion, but now I think the next challenge is how can we verify which model is more effective or representative than the other.
Thank you very much for the very good point. And, it's tough to do that because, okay, let's look at the log linear models, which is quite different than this story. But suppose there are two log linear models, then both of them have the same explanatory power of the mobility table. Then we cannot choose. Then there's a fight between the two camps. Okay, our interpretation of the model is better than yours, and so on. So it's a very good point, but I can't give you a clear answer to it now. But let me think about it. Yeah, thank you very much for pointing out a very important point.
Please.
Thank you very much for your sharing. I wanted to argue a little bit about the slides that you showed just right here, the study. Yeah. I think that the study is fine with me. I think that's the interpretation part, that how exactly we know that the interpretation from the model, based on the model, how do we really know that the interpretations is really fit to the purposes? I mean, for example, that when we are preparing for the data, the big data, before we processing the data, we have to clean the data. And when we collect the data or when we replicate the data for the small samples from the medical field, we still need to, understand the data, or we have to know all the details, the attributes of the data, no matter what types of the data we are collecting, the audio or the video or the images. I mean, we probably have to find like 200 or more of the parameters to deal with all of these data. So I mean, we actually know the data, and so we can provide a very clear interpretation of the data when we're processing them. And so when we do this, and then we finally create a model, and then to fit into this kind of maybe fit into somehow of the model that has been mentioned by the sociologists. So I mean, I want to really argue with this, that when we do not have any model, but based on the data, we still can find something similar maybe from our data. I mean, the findings we probably still be able to find, and similar to the model that maybe has been mentioned or has been proposed by the psychologists. The sociologists. Yeah.
Thank you again for pointing out a good question. I would say there are two processes of interpretation in his study. One is the interpretation of the frames. So he assumes that people interpret the frames proposed by social movement organizations. So this is one process, the first process. And the second one is that he interpreted the topic. So, if you use a topic modeling, you get some topic. But in the beginning, it's just mathematically abstracted from the text, right? No computer gives automatically the labels to the topics. So you add meaning to the topic extracted from the data. So you interpret the results of the big data analysis. So here, again, Bayes interpreted the topic popped up from the analysis. So there are two dual process of interpretation. One is proposing the hypothesis or research question, he assumed that the people, the target population of the organization, social movement organization, interpret the messages on their Facebook. Then that's the first one. The second one is that he interpreted the results of the topic model. So anyway, we need interpretation, but as Yen-Shen pointed out, maybe other researchers interpret the topic differently. So getting back to the basic, so if we conduct factor analysis, we can get factors, and we add names to the factors based on our interpretation of the results. So maybe other so suppose I conduct a factor analysis and get the 5 factors and add names to the 5 factors, but you may apply different names to the factors because your interpretation of the result may be different than mine. So then there's a fight between you and me. Could you press longer?
You can use this one.
Excellent talk from Professor Sauter. I'm Hong Juan-Chu from College of Management, National Taiwan University. I'm particularly interested in this kind of bring back meaning and interpretation to the we say the sociological behavior. Okay, to my recollection, when I was a doctoral student, my supervisor asked me to study Nancy Toomer's, Professor Nancy Toomer's The Social Dynamics textbook. That was a perfect, we said, the methodology book for sociological research. Gradually, when in my professional, particularly I'm interested in social network analysis, I found that probably this kind of issue, either the cultural carrying capacity or like institutional carrying capacity, perhaps whether we need to do some longitudinal analysis, and then we can just whether the meaning, just like Professor John said, whether we have so many meanings, okay?
Right.
So actually recently I applied the Bayesian statistics, try to use the Bayesian inferences to justify that sometimes we have just incomplete data, particularly in the social science, just like we say the college entry exam in Taiwan. Actually, lots of the data was not publicly available. But whenever afterward we collect like the governmental verified the data, and then we can use the data to revise our inference from the Bayesian statistical perspective. So my question here is, what's your opinion that actually we apply like the social dynamics, that kind of a quite a quantitative analysis to our sociology-related research? When we would like to make the, we said, interpret the meaning, so what kind of a methodological issue we need to be aware? Thank you.
Thank you very much for asking a very good question. Many years ago, I published a book titled Network Dynamics, so how people change social networks. So Martin talked about the social structure consisting of nodes and ties, right? But sociologists talk about social structure as a structure of roles, relationship of roles. So you have the role of a professor, I have a role of professor, and some of you have a role of graduate students. Then the structure is consisting of power and some other relations. So if you interpret if the interpretation of your behavior is different, so different between my interpretation and the grad student may feel some power from you, but you and I are professors, so I don't feel any power from you. You asked me just a nice question, but if you ask a question to a grad student, maybe they feel some power. Wow, professor is forcing me to answer the question or something like that. But only focusing on nodes and ties would miss such subtle interpretation of the behavior on the network. So, to understand that, it's very important to see the social dynamics over time. Thank you very much.
Thanks.
Thank you so much, Professor Sato. You actually have more to bring in, right? Roles, status, a lot more concepts in sociology.
Very good.
Yeah, right. So very interesting. We should end this session, and we are going to have a break or a photo session, photo shooting session. So where are we going to take it?
Can everyone move forward?
Right here. We are going to take photo here. Okay, please.
Okay.
We are continuing with this session with one paper presented by Professor Siqi Han. Professor Han is Assistant Professor of Sociology and active member of the Computational Social Science Cluster at the Chinese University of Hong Kong. Her recent work mainly focused on knowledge structure in higher education, and she addresses her research questions using both surveys and unstructured textual data with computationally intensive quantitative methods, including ChatGPT-assisted data collection and processing. Her project had appeared in prestigious journals such as PNAS Journal of Marriage and Family, among others. She will share her experiences in studying educational sociology in the era of the big data. Professor Han.
Thank you for your nice introduction. And it's really an honor to be here, and I really appreciate your considerate accommodation for my trip here. The title of my talk today is Sociology of Education in the Era of Big Data. So a little bit about myself. I work mainly in sociology of education and the school-toward transition. Some of the prior topics that I work with, including STEM education, non-cognitive skills, and income inequality. As you can see, these are all very conventional stratification topics. And they mostly use conventional data as well, surveys. So how did I come to the area of CSS? It's at the end of my graduate training that I start to notice that there are limitations imposed on the kind of research questions I could ask with this survey data, traditional data sets. So what are some conventional research questions in sociology of education? So I listed two here. Do lower class students have a lower probability of entering top universities than higher class peers? Are black students evaluated as less well behaved by teachers than white students, and so on? So these are typically educational inequality kind of research questions. The issue with these research questions are that they always focus on inequalities, either in the access of education or in the attainment of education, but not the things that happen in between. What happened in between is overlooked in most prior research in sociology of education for good reasons. One reason is that most quantitative education scholars believe it should be this kind of experience, or what happens in between question, should be left with their qualitative colleagues to do field work, ethnography, or. But more importantly, there are no suitable data or methodologies at the time to ask such questions by quantitative scholars. So now, since we are in the era of CSS and big data, can qualitative researchers quantitative research has actually opened the process and experiences black box? And I believe the answer is yes. And today I'm going to show one piece of my research analyzing a mass amount of course contents across institutions in the US, building a quantitative measure of the so-called interdisciplinary education, which is a sort of difficult, complex student experience that can hardly be asked or captured in a survey. So imagine you ask a student, do you think you experienced interdisciplinary education in your 4 years in your college? They could answer yes or no. They could also answer 1 through 5. That's the typical way, a scale that you can gather information from the survey. But we tend not to believe that given a score of 1 through 5 would really capture this so-called interdisciplinary educational experience, because it's difficult to measure directly in survey data. So then what can we do? I will propose we can analyze the course contents as a type of unstructured textual data, big data, that can help us capture this process and experience kind of variable. So the unstructured textual data, I don't think I need a lot of introduction here because many of the audience here are experts. So they are made of text, not numbers. There is no predetermined variable structure or given variables such as gender, race, and class that are most typical in stratification research. So they are called unstructured. We have to use natural language processing techniques to gather or extract these variables out of the text. And lastly, they are large in scale, big data, usually are online and need us to scrape it. The benefit of using it, as I have already discussed, is that it gives us breadth of application. And I will show that more in a little bit. And because such kind of big data, computational social science analysis can apply to both structured and unstructured data, they can lead us to surprises and new theory building. Hopefully, I will show that in my talk today. So the research questions in this paper about interdisciplinary education. First is, what is an interdisciplinary education? Can we measure it quantitatively? So in prior research, there are indeed some quantitative indicator of the so-called interdisciplinarity, but they are mostly restricted to organizational analysis. So the indicators can include how many interdisciplinary research centers do a university have, or what is the proportion of faculty members who hold joint contract across different departments. So these are indeed reflection of interdisciplinarity of an institution, but they do not really speak to student experience. So what can speak to student experiences then? I think the building block of learning, that is, the courses that students take, the course materials that students are exposed to, should be better than organizational features to capture this idea of interdisciplinarity. And secondly, if we can quantitatively capture interdisciplinarity, then we can speak to a heated political debate about whether we continue funding the liberal arts components in higher education. So in the US and in many other parts of the world, there is a decline of funding support to the liberal arts components or liberal arts colleges because people who hold a liberal arts degree do not get enough economic returns to it. Unlike if you major in engineering, then likely you have a very vocational path to follow and you have a job immediately after you graduate. So is there really no economic value attached to a liberal arts degree that focuses on this more general interdisciplinary education? And I would like to challenge that with my analysis today. So the so-called new type of data, course materials, there were research before that also examined it, called curriculum study. That's a subfield in education. But mainly that was done by human reading and hand coding on a small sample of textbooks or exam question papers. So the scale of it, the breadth of it is really limited. Unlike if we collect a massive amount of course materials across institutions, across disciplines, then we will be able to analyze really huge amount of it. And it will become more generalizable than studying a small limited sample of hand-picked textbooks. So we collected 2 types of data here. One is course catalogs, the other is course syllabi. In both kinds of textual materials here, there usually is a paragraph. Well, many of you have written a syllabus. So, on top of it, there's usually a few paragraphs called course description, and we want to take that out. And it's the same for course catalogs, which I will show in a screenshot later. So this is how we conceive the measuring the liberal arts project at Columbia University. So we use 2 ways to scrape all these course materials. Web pages, one is Beautiful Soup, the other is Selenium. Both are Python packages, which I don't need to introduce more. And here are the steps that we can do the web scraping. We go to a course catalog web page. We find the paragraph that we need, and then we find the HTML element that it is under, and then we save it to a CSV file. So this is an example. This is a course I teach at CUHK called Sociology of Science. So when you scroll down the web page, you can see there is a section called description. And we want the text under description, right? So many of you are more experienced than me, you right-click it and inspect the HTML element as shown below. You can see where it is saved, and then we use either package to scrape it and save it into a structure like this. Every row is a course. Every column is a variable of that course. The variable can be either the description or how many credits, or is it undergraduate or graduate level courses, which year is it offered, the department, the school of it, and so on. So you can see we turned the unstructured textual data into a structured one like this. This is a square data that we see how the survey data is also saved this way. Only that the survey data are about individuals. Every row of the survey is an individual. Now here, every row of this data set is a course. And the variables are the columns. Of course, this is a very short introduction of a lot of data collection work that involve a lot of people in our team for like 2 years. But once we have this data, we pre-process it to remove like stop words, blah, blah, blah from the text. And we have a way, we developed a way to construct a numeric index for the level of interdisciplinarity of the courses in each department/school. How do we do that? Here is the intuition. But before that, I'm going to call interdisciplinarity this long, tedious word inter-D from here on. So I don't have to pronounce it again and again. So this inter-D index, the intuition of it is that we compare the content of a course to disciplinary corpus. So all the courses belong to the same discipline. We combine them together into a big text. We believe that represent the content of that discipline, and we do it for every discipline. And then we compare every course to the disciplinary corpus. For a more inter-D course, it would show a higher semantic similarity to a more dissimilar set of disciplines, while for a more disciplinary course, it will show more semantic similarity to a more similar set of disciplines. So what does that even mean? Here is an example. So we have taken out 2 courses in anthropology, course A and course B. And we compare its course content to all this 20-ish disciplinary corpus. And we get a cosine similarity score out of it. Every between course A, course B to every discipline. And you can see the values here. For course A, we immediately notice that it has the highest similarity to anthropology, which is its own discipline. And then it has pretty low cosine similarity scores to all other disciplines. So we can tell from the values here that course A is very typically an anthropology course. But course B is different. As you can see, the values are high moderately high in many disciplines. So first of all, to anthropology, it's 0.13. But if you look at the bottom, it is also similar to sociology, 0.22. And some other disciplines too, like economics and political science. So if we believe that, for example, business, 0.07, and anthropology, 0.13, are relatively dissimilar disciplines, then we capture in course B this definition of a inter-D course that is semantically similar to a more dissimilar set of disciplines, unlike course 1, which is just similar to its own discipline, anthropology. So this is the intuition of how we construct the numeric index for interdisciplinarity. And we can calculate that in a formula like this. So this is first to calculate all these separate values you see, and then weigh it by the distances between the disciplines that it is similar to. So I'm not gonna really calculate it in any way, but just to show you. So if we have this index, why does it matter? How does it matter for social stratification? We can merge the index to traditional variables that stratification scholars are interested in, such as the school's ranking, such as the student earnings after they graduate, all these economic outcomes. Especially as I introduced, does liberal arts education only have cognitive benefits, or does it have any kind of economic benefit too, now that we measure it differently here? So we found that, we studied it across different disciplines, and we found that in science majors, but not in social science or humanity majors, schools with higher level of curriculum interdisciplinarity measured in our way can help their students gain higher economic returns after graduation. Only for science majors, not for social science and humanities. Why is that? We have some guesses. We believe that many of the employers today in the labor market have this stereotype that many science majors are just applied, very specialized talents. They only know applied knowledge. They are not exposed to a lot of interdisciplinarity or liberal arts. So if a science major go to the labor market and show that he or she has exposed to quite a lot of interdisciplinarity, then maybe it will help him or her stand out among other science majors, because others maybe are not so interdisciplinary as this specific student. But as we do not have observations during the interview process, we hardly know if this guess is true, but, well, just intuition. Well, there is a story twist. Although we find this pattern, we submit to a journal and we have reviews in, and the reviewers are not satisfied yet with the inter-D index. Why? Because in our case, we aggregate for every discipline school the mean value of inter-D across all courses that it offers. The reviewers, however, believe that this department/school level inter-D index cannot capture all individual variations within that department school. That is, even if two students come from the same department school, they still take different courses. There's no, well, they have to take similar required courses, but there's still other electives that are different. So if we use this aggregated mean value for each department school, that doesn't really capture the variability of individual course taking variability. So this is what they dislike about our analysis, but it is a very difficult shortcoming to overcome. Although very sharp comments, but we cannot, well, theoretically, if we are to adjust this comment, we will have to get all the transcript of individual students to see their course-taking trajectory. And we have to do this for all the disciplines and schools that we collect, that is 1,600 departments across schools, which is practically impossible. So what can we do that? We decide to simulate student-level course-taking trajectories based on their required course-taking. So how do we know? We first go to each department school website and find out the course-taking requirements. And then we discovered that there are 4 major types of courses that they have to take. One is the in-major required courses. One is the in-major elective courses. One is the general education courses, and lastly, 3 elective courses. So across all disciplines and schools, usually they require these 4 components of courses to be taken. And then we simulate student course taking trajectories so that it satisfies all these credit requirements, but are attached to a randomized set of course contents that we draw from our course content materials already collected. So different students for the same department, they all have to take, let's say, 40 credits in major, but the courses that we attach to their trajectories are randomized, so that not all students in the same departments are taking the exact same courses. Well, this sounds not perfect, but maybe fine. But the start point is, how can we get so many course requirement data? Do we want to go to the 1,600 web pages and hand code it? No, we do not have time, because the turnaround time for that R&R was like 2 months only, and we don't have so many people. I have already finished my postdoc at that time at Columbia, so I moved to CHK, and I'm not in person to guide all the RAs there, so it's really, really difficult. So we turned to ChatGPT for help. We used a GPT API to achieve this goal. The GPT can help us go to the web page, find the required information, and then save it into a JSON database, only if we provide a good and complicated prompt like this. So the greenish text here are the prompt base. Provide the requirement for a major at a certain school. Provide any only requirements for major itself, not the entire bachelor's degrees. And down there, like N is the total number of courses, and in is the in-major courses, and out is the required courses. So I don't have to read all of the prompt. So it's a tedious long prompt, and it loops through the major and school in the bracket. Eventually, the reviewers accepted this GPT solution and let us pass MPNS, but I have to point out that I personally still find that there are a lot of shortcomings in the approach here. We did a lot of work, but shortcomings. First is that people always question which schools you choose and which disciplines you choose. So we chose 80 schools in a 2x2 classification. University or liberal arts colleges, high ranking or low ranking. So we have 4 subgroups, and we put 20 into each subgroup. This is kind of arbitrary. So people would ask, why not 100 schools, 200 schools, right? And the disciplines that we chose, 20 of them, we find them most common across institutions. So there are a lot of unique programs that schools offer today that are unique to itself, but not widespread in other kinds of institutions. So the majors, as you see in the course A, course B comparison, are the most common traditional majors that we can identify in all institutions that we study. But still, people would ask, okay, why 20 disciplines, not 30 disciplines? And so eventually, this is a shortcoming of limited time, money, and personnel. If we have a lot of RAs, a lot of time, we could collect 100 schools, 30 disciplines, but that's about what we can do for the time being. And the second shortcoming is the GPT correctness. So despite we provide a very long prompt, as detailed as we could, it sometimes gives us empty answer and sometimes gives us fabricated answer. How can we rule that problem out? We cannot. So what we did is, after it collected all the data for us, the course taken requirement, we randomly sample a smaller set of data, and then we ask RAs to, hand check it to see what is the level of accordance between the GPT-generated data and the human-coded data. It's not perfect, but acceptable. I can't remember the percentage of correctness, but it's acceptable. But you can see this is not a very difficult task just to look at the web page. If for some other research designs we needed to do more complex tasks or data extraction, I believe the error rate would be high. And lastly, as I said, because we don't have their transcript, we simulated their course taking. So it's not real data. Nowadays, we have acquired a few schools' real transcript data in collaboration with UMichigan. So we're looking forward to actually replace that part with real student course taking trajectory. But more generally, the shortcoming of this kind of research is that when you have a large, big data set like this, the size of it usually give you a lot of predictive power that you can, maybe you can have really good p-values and so on. But these predictive features do not necessarily correspond to causal factors. So if you have feature A that is super predictive of your outcome, does it mean that it is a causal explanation for your outcome? That's a question mark. I know that cutting-edge scholars are doing causal trees and so on to merge the causal rationale in traditional research with the big data machine learning thing, but it's in development. So we are looking forward to see if these shortcomings can be overcome. And lastly, I have, I think, a few minutes to introduce a few upcoming projects related to this measuring liberal arts project. So highlighted 1 and 2 are most directly related. One is called recombinational concept network, because a lot of you I know here are interested in network. So I'm gonna slightly show results. And the second is gender representation in course readings across disciplines. So this is a so-called recombinational concept network from our course materials. In management theory, there is this so-called recombinant innovation theory, saying that if a team or a scientist are able to combine two seemingly distant bodies of knowledge in their work, it is more likely that they produce innovation. And we want to see if that's the case for course materials and how does that vary across institution types. So as you can see, this is a 2x2 institution types, liberal arts universities and high or low statuses. And we pick two similarly unrelated concepts, one called embodiment, the other called organization. These are completely random. And we find the most similar 50 words associated with embodiment and 50 similar words associated with organization. And we plot the network structure in the 4 different subcorpora here we can see. And to show whether the curriculum is recombinant or not, take the lower right subfigure, which is low status universities. You can clearly see on the lower right one, there are 2 components. One is the cluster of concepts associated with embodiment. The other is associated with organization. They are in no way strongly connected. They are 2 separate components. However, in upper left figure, liberal arts colleges with high status, you can see these 2 clusters of concepts are merged together in one large component. Well, I can explain how this is done, but the idea here is that it shows certain type of institutions are more recombinational in terms of the concepts in their curriculum than other types of institutions. And we actually did bootstrapping of such process of choosing different concepts that are unrelated and plot the network structure and count how many components are there and so on. So that's one application of this data set to another different research question. And we can also use the syllabi data to extract the course readings assigned in each course. So in Python, as many of you must know, there is this so-called function generalizer. If we put the names into the generalizer, it can give us with certain confidence whether it's a man or a woman. So we can do that for the authors of the course readings. We can also do that for the instructor of the course. Is there any relationship between that? As you can see in our room here, the majority are gentlemen. The minority are ladies, which is already gender segregation in the CSS field, if you must conclude, right? And is there any such pattern in college education? We already know in STEM majors, the natural science, engineering, math, and so on, there are limited female representation than men who dominate these fields. And is there any reflected patterns in the course design too? You can see the x-axis here is the percentage of male authors in the discipline as a whole. And the y-axis is the predicted proportion of male authored reading assignment in the course. Of course, you can expect this is a positive correlation. The more male authored papers there are available in the field, the more likely it will be assigned in every course. But there's a further difference in terms of instructors' gender. The dashed line here are male instructors. The solid line here are female instructors. As you can see, there will always be more predictive proportion of male authored assignment, reading assignment for male instructors than female instructors, given every level of the disciplinaries overall percent of male authors, which we find interesting. And we start to run different models on top of this descriptive pattern. So, because my time is running out, I'm going to stop here and thank you for your attention, and I welcome questions.
Thank you very much. So interesting. Any question, comment? Please.
Thank you for the nice talk. I'm interested in the correlation between interdisciplinarity and economic earning. So could you show me the slide again? And I have a quick question about it. So the horizontal axis is measure. So using the index you created for the interdisciplinarity of the courses. And then how could you measure the vertical axis, earnings, returns? So this is the students.
No, this is, thank you for raising it. I forgot to mention it. These are not student level earnings. So in the US, there is this so-called NCES department, the National Center for Education Statistics, which collect regularly the department/school level earnings. Because, as I said, we don't have the transcript of the students. So this analysis cannot be settled at the student level. Otherwise, it would be different level, a mixture, right? So we want to keep it at the discipline/school level. Therefore, we have to look for earnings at the discipline school level. So these earnings are for every program.
I see. Okay, one more quick question about it. Do you have any idea how to explain the positive correlation between the two variables?
What validation?
So there's a positive correlation between the two variables, right?
Positive correlation.
So do you have any idea to explain the
Yes.
positive correlationship?
Yes. So in the front end of that paper, we are saying that why would interdisciplinarity benefit earnings? There are two different mechanisms. One is through improving student cognitive skills because they are exposed to a more diverse set of materials. And the second is that it improves their social skills too. Because
social what?
Social skills.
Uh-huh.
So in a number of literature that support interdisciplinarity, they are saying that, okay, interdisciplinary education can help students become better citizens. They will become more engaged with their community. They will be better at communicating with different people who have different opinions from them, and so on. So we believe that can help them perform in the labor market as well, in addition to the cognitive improvement.
Is there any possibility to think about the reverse causality? I mean, self-selection bias. I mean, the students with higher level of cognitive skills are more likely to choose the interdisciplinary program.
That's possible. Well, in this model specifically, we control for the SAT admission score for the departments. So it's indirectly correcting that. But still, this is program level, not individual SAT. So we don't know that. But we hope to, as we acquire some new data, we hope to test the individual.
Okay, thank you.
Yes.
Okay, thank you for this very inspiring study. That's actually from my perspective of a business school. Actually, first to your first project, I think that this is a quite right intuition. Because when we see a science major, if it's the course, particular required course taken, is designed as an interdisciplinary subject. And actually, they have a much more opportunity to get a higher paid job. So this intuition, actually, I endorse. For example, actually, recently I checked like at University of Michigan, University of Washington, for their computer science major. And actually, if they are not the top, just like Stanford or Berkeley, they actually have quite a good strength in like a bio computing. So I think this is a new interdisciplinary area, and then they get a very quite good ranking. Actually, this is related to their strength of a medical school in UW and also in the U of Michigan and Ann Arbor. So I think that in your first project, yeah, it seems to me this is a one-way route. That is, if you have a science major, and actually you probably, if you take the interdisciplinary curriculum, you probably have a good chance to get a higher economic return. So I think that there's nothing wrong with, for your study of using the department level data instead of in student. Why? I think it's a matter of, we say the unit of analysis. Whether we are studying the micro level, macro level, or meso level, even the meta level. Okay, it's a matter of the data specificities. Actually, in Taiwan, there are 3 universities studied the diverse college entrance exam background, whether they had their their college entrance alternative is different, will affect their GPA in their college study. And actually, these 3 studies, one from the National Taiwan University, and the other from Chengchi University, the third one from the, Zhongshan University. Actually, when they present their data, for researcher like me, actually I think that there are lots of contingency, or we said contingency to control. For example, if you want to get the good paid job, whether the score with the GPA is unbiased statistic for your chance to the student chance to get a high job. So actually, my feedback to your first project, I think that's a very interesting, and you point out that this is a one-way route for the science major, but may not be for the social science major. Because if like the big school, the major, if they want to have the double E major, electronic engineering, it probably is not impossible. And secondly, I think the department level data has nothing wrong, in my opinion. Thank you.
Thanks for your comments.
So a fantastic talk. I think it incorporates a lot of innovative methods to inquire this very important educational question. I guess the multi-million question is what schools now should do with their curriculum, right? Should they diversify and make the curriculum more interdisciplinary? Or should they maintain their current curriculum? I'm kind of thinking if there's a way to utilize the longitudinal measure of your data to answer that question, because currently the analyses, if I understand it correctly, it seems cross-sectional, right? So you pull all the syllabi together and you pull all the earnings together. But I'm wondering if it's possible from your data to analyze it at the department level. So let's say we have a department that started, let's say, focusing on sociology, or actually I wish I should use a science major. Let's say we started a chemistry. So it's very, very chemistry focused syllabus. Then it became more interdisciplinary, like including biocomputing and other things. For that longitudinal variation, can we estimate something like a fixed effects model or some kind of growth curve model to understand whether this change at a department level, interdisciplinarity of the syllabi leads to the increase in earnings? Because you do have the 1 year earning every year. You also have the, when the course is taught. I'm just curious about your thoughts on that.
Yeah, I mean, that's a very good idea. I think the slight concern that I have is once you look at this syllabi data, the problem is that the earlier the year, the fewer they are because of the who want to post that and how widespread is the practice of posting their syllabi on the web. In early years, maybe there's not a huge collection of online syllabus or course catalogs. And in recent years, there are more and more. So I think it will somewhat affect the earlier estimates, but I think that's doable.
Yeah, I think for the recent years it's doable. I mean, if it goes back to the 90s, it's probably impossible. But
unfortunately, it goes back to 2010.
Yeah, so it's like 2020, 2021, 2022, and 2023, you have 4 years of data. And then you can get rid of all these concerns about like whether it's like differences in the prestige of the school or whether it's the student-teacher ratio and all that because it's
data control.
Yeah, I mean, you control for it, but there are also other unobserved controls that you can't deal with it. But with the fixed effects model, you can absolutely deal with all those concerns. I mean, just a thought on that.
Yeah, great idea.
Yeah.
Very impressive. Just out of curiosity, I'm very interested in ChatGPT. How many prompts have you ever tried to get to the satisfactory answer?
Well, for that specific prompt, it was done by the second author. So I don't know how many times he tried, but this was not, you can see this is actually the Bing GPT, not the OpenAI GPT. At the time, there is this reverse engineering. There's this reverse engineered GitHub repo that he didn't pay any money to do this. So he tried as many times as he wanted. But then this was taken down by Bing. So we actually just got lucky to just do it for free many times. Yeah.
Just a quick follow-up. Just a quick follow-up about ChatGPT.
Yeah.
When you send back the replies to the journal, you did say that you use ChatGPT for help, right?
We said it in the paper.
In the paper?
Yeah, this
okay.
is ChatGPT.
So did the editor and the reviewer say anything about that?
Well, because they asked us to get the student level data we don't have, so then this is possibly the only way that we could. So actually, because this was early last year, when there are not so many researchers who are using ChatGPT to do things, so they found it novel, rather than they found it problematic. So I imagine if we submit it now, they have more experiences of judging it. They would dislike it, maybe. I cannot imagine. Yeah. Thank you.
Thank you very much. Thank you very much. For lunch?
Yeah. So lunches are now available, so we can continue our conversation on whatever topic you are interested in. Yeah.
Good afternoon, everyone. My name is Shenwei Wing Li, and I'm a assistant research fellow in the Institute of Sociology, Academia Sinica. So I will be the moderator of this session in the afternoon. So we will have 4 presentations this afternoon, and all of the presenters are from Academia Sinica. So it's about computational social science. So the first part, we'll have like 2 of my colleagues. The first one is Professor Yang-Zhi Fu. So Professor Yang-Zhi Fu is a distinguished research fellow in our institute, and he gets his PhD in sociology in the University of Chicago. And his research interest is social networks, information and sociology, urban sociology. So in recent years, he has been leading many multiple like interdisciplinary big projects among Academia Sinica. Like most of the research are containing like statistics and like health and sociology. So I believe like today he's going to share about his work like in like many decades, I believe. It's about contact networks. So let's welcome Professor Fu.
Thank you. I would like to focus on contact networks, a special kind of networks, using a diary approach. Sorry that I changed the subtitle a little bit. I put social interactions back in, following Professor Sato's advice, which is a key sociological concept. Let's start with some concepts and definition. I think everybody agrees that what a network is. A network is a set of nodes connected by edges. Or more precisely, networks consist of nodes and edges. We need both nodes and edges. But it's more complicated about how to define a social network. Because at least social network deal with both a whole network, complete network, and personal networks. Today, I would only focus on personal networks. And within personal network, it's clear that nodes are individual person, but it's not very clear about what makes an edge in personal network. An edge could be relationship or contact. So those dots are nodes. The disagreement is about those links. What makes those links? I would like to quote two recent definition about social network. So first, in a social network, the nodes are the individuals and the links correspond to relationship. Who is talking to whom? Who is communicating with whom on a regular basis? And the second definition, a network is a group of people connected by some type of relationship. Friendship, collaboration, romance, or mere acquaintance are all examples of social relations that connect pairs of people. When we talk about a social network, we typically think of a particular type of relationship. A second type of criteria is interaction of contact. It's not common in the literature, so it's very difficult to find definitions, so I just made a couple up here. So a contact network is a set of ties among individuals who interact with one another. Or, put it differently, personal contact networks consist of individuals and their connections as defined or measured by interactions. So there are three components here: individuals, connection, and interaction. For contact networks in epidemiological studies, it's easier to define, to use each edge to symbolize that two people came into physical contact. So when they are sufficiently close enough for contagion to occur. Relationship networks have been far more conventional and widely used. For example, Purdue used the following sentence to define social capital. Social capital is the aggregate of the actual or potential resources which are linked to position of a durable network of more or less institutionalized relationships of mutual acquaintance and recognition. So both relationships and acquaintances are essential here. And even in epidemiological studies about how infectious diseases transmit from person to person, relationship networks outnumber contact networks as the main approach to model different infection patterns. In an ethnographic study, we can feel that conventional approaches may be inadequate to capture fleeting interaction and contingent network structures in emergent social phenomena. For example, one of the respondents or informants in this particular study mentioned all the person or the personal members who are important to her. And all the people on the left here have a name. These are the initial of the names. And these people do not have a name because the focal person simply does not know their name. She cannot recognize, she cannot identify who these people are. So not only did she find it impossible to identify individuals she connected to via Facebook and Twitter, indicated by labeling them just as X, Y, and Z. But it also was challenging to identify how and why digitally mediated social ties were important in terms of her career. But she claimed that context on social media played a crucial role in her day-to-day work practice, even though she does not know their name. But more critically, sociologists have long focused on how social interactions should be the fundamental unit of analysis. Let us quote some sociologists. We have one more founding father of sociology here. Durkheim says society resembles a living organism in which members interact with one another constantly. So you need to interact with each other for the organism to function. And Zimmer said members of a society interact socially. Sociability abounds as a more impulse in men. And John Laughlin, who is a qualitative sociologist in the 1970s, said contexts are like encounters that compose the smallest, tightest unit of social situations that breed social relationship and action. So beneath relationship, there's one more element, one key element, which is interaction. And for Jonas Turner, social interaction is the most elementary unit of sociological analysis, whereas sociology studies the organization of individuals, which can only begin with social interaction. Without such encounters of context among actors, information would not flow freely, nor could influence possibly take place. So those are the two important I's for a social network to function well. So a context perspective is a way to build, is a way to look at how people build and maintain social connections. The actors simply need to keep in touch with one another in various ways and to refresh old connections and construct new ones. Context is an essential building block of personal networks on important occasions and in everyday life. There are different approaches to studying content networks. For example, it's common to use sensors like RFID or mobile phones for epidemiologists to study physical and or in-person contact. And for social media study, is common to use email or contact records. But a more comprehensive way to use diaries. There are different ways of diaries. One is contact archives. If you can get access to the contact records or contact book of Prime Minister, in this study is the contact records of the British Prime Minister. That would be great. You can do a lot of dynamic analysis of the network. But a more common way is to use self-reported diaries, is to go out to collect data of your own. So to sum up the strengths of a diary approach, the first one is can explore the level underneath a tie, and it's common in many disciplines. For health, researcher, for sleep, shopping, travel, time use, different kind of studies, a diary approach could be really helpful. And we only focus on in-depth contact diaries. There aren't too many cases, too many examples that use contact diaries in their studies. we can go back as far as to 1961 in the US for a dissertation study at the MIT. And one more scholars did it in Russia, and we follow that tradition to collect many waves of contact diaries. And in 2011, the scholars in Hungary also did contact diaries. This is one sample sheet of the diary log in Chinese, and this is the answer from one single participant. So each contact is one row in this sheet. On this particular day, the informant interact with 6 persons. And for each contact, we ask the person to record the author's basic information, the characteristics about the ties, and all circumstantial situation, all those factors about the content itself. And we also collect the information about author ties. These are they're filled in a big sheet. So number 3 means author 1 and author 3 do not know each other. And number 1 means they know each other and they know each other very well. So we use this type of information to reconstruct network structure for each personal network. And this is sample from the Hungarian contact diary. We use different app and online platform. And the top designer is here, Professor Daqian Zhan. He's the co-author of many papers here and the top designer of this app, as well as of this online platform. So a typical structure of contact diary is somewhat different from other network data. In conventional sociological study, we use individual as the basic level, as the lowest level in our multi-level analysis. And here, each individual is at level 3, at the highest level. And below that level, below the individual level, we have authors level or ego-author ties level. Those are two. Level 2 are the same. They are at the same level. One is individual's level. This individual is author, the contact person's characteristics. The other type of level 2 is the tie characteristics. And the lowest level is the contact situation. How long does the contact last, and what kind of purpose, and who initiated the contact, etc. This is one example of the regression of the multi-level logistic model of mask wearing. So the dependent variable is whether the respondent, whether the diary keeper put on a mask during a specific contact with a particular author. So we can get a lot of information from this kind of multi-level analysis, not only from ego's level, but from tie level and the contact level. I wrote up two introductory notes about contact diaries in 2005 and 2007. I said a contact diary could be a way to measure personal network, and it could help build archives of actual and comprehensive personal networks. We have applied the contact diaries data in some core sociological issues, such as the social exchange, social hierarchy, and societal forces. For example, we recall that Granovetter said that weak ties can be beneficial to an individual sometimes. And when we break down each tie into different contact, into different interaction, we can actually differentiate the effects contact by contact. So the main finding here is that when one initiates a contact, weak ties indeed tend to be more beneficial. But when contacts are initiated by the other party, by the author, strong ties are more beneficial. That means when a strong tie contact you, they will do more good to you. But when you contact weak ties, that would benefit you, the person who initiated the contact. We also use that to analyze how context upward in everyday life could benefit an individual. So if you reach hierarchical relations, that kind of social interaction would tend to be more beneficial. And in another study, about 14 Buddhist masters kept diaries for about 28 months. So these are years-long diaries. And we use this diary data to reconstruct the network structure among these masters. We compare the context between these Buddhist masters and found that if they contact with the other masters who are higher in the Dharma title hierarchy, that kind of contact would benefit them more. But the perceived status, which is not related to the Dharma title hierarchy, would not matter that much. We also compared the contact diary data across country. Since the Hungarian sociologists also collected contact diaries for just 1 week, we compared these contact diaries and compared two democracies with a similar authoritarian past. These two cases are interesting because Taiwan is in East Asia, Hungary was in Eastern Europe. They both had authoritarian past. One is anti-communist, the other was communist, and they both turned into new democracies about 2 or 3 decades ago. And the major finding is that the macro level forces of daily contact seem to endure, especially in Hungary, because in Hungary, during the communist regime, the strength weak ties is not actually functioning. Actually, weak ties can be a liability. I would like to thank Professor Xiong for making that great suggestions, because in authoritarian societies, weak ties can be dangerous, can be a dangerous source if you don't want to talk too much about what you think about the government to a weak tie, because the weak tie could be a secret police and leak that information to the authority. And in addition to the macro level forces enduring, we also found that the extended family in Taiwan maintained stronger ties than close friends. We also used analogies and metaphors from other fields. For example, for zoologists, to count bears in a new area is not easy, even though it's very important. So they set up trap, and they can set up trap to capture a bear, either a bear or a mouse. And they use a method called the capture, mark, release, recapture. So for example, on day 1, they capture a group of mice and mark them, and release them, then recapture them the second day. And on the second day, these 2 mice got caught again. And so they could use that information to estimate, to calculate the population of the animal. So we use that kind of analogy to predict personal network size from contact diaries. In other words, like wildlife species in an ecological system, orders in an egocentric network are often hard to count. But if we see order as species, we can use the similar method, the species accumulation curves, to estimate the number of orders in a specific personal network. So this is a common network diagram, but somehow we diary data we can build, we can design a network visualization beyond nodes and edges. Computer scientists at UC Davis came up with the idea of contact trees. So a contact tree, each contact tree is one personal network, and each small branch is one author, one person. And each leaf is one interaction, a contact. So you can decide each leaf based on their characteristics, how long the contact lasts, and whether the contact was feels good, and who initiated that contact, etc. And put these leaves along each small branch. And using the diary data, longitudinal diary data, we can compare to personal networks just by looking at these trees. So the person on the left was a female respondent in her 30s, and in 2004, her contact trees are somewhat balanced between males on the left and females on the right. And we mimic, by the way, we mimic the contact tree based on what we know about the population pyramid. We put males on the left, females on the right, and those youngest cohort on the very bottom, and the oldest cohort on the top. So 4 years later, when you compare the same person, we found that some dramatic increase in the orders along this main branch. These are the male children in their children under 10. So this particular small branches has a lot of leaves. This is the lady's son, and 4 years later, her son started attending elementary school. So the lady has a lot more contact with his son's classmates, either boys or girls, and the parents, more specifically, the mothers of these classmates. And just by looking at these 2 contact trees, we can tell how personal network had changed over time. We also try to use the analogies of disease transmission. We use contact tracing from interlocking diaries to map move contagion along network chains. So instead of studying disease, virus transmission, we study move contagion. And this is what we mean by interlocking diaries. All these red dots represent eagles, or the diary keepers who participated in our study. These are all connected because they know each other, because we encourage our participants to recruit people they know to join our study. So these diaries are interlocking. And we model and try to study how both negative moves and positive moves transmit through a different chain, a chain of interaction. And there could be some other kind of metaphors. For example, in 1977, NASA launched a pair of spacecraft, Voyager 1 and Voyager 2, to explore the outer space, the outer layer of the solar system. And 40-some years later, Voyager 1 and Voyager 2 made a headline in both science and news media. For example, one article in Science said, it's official, Voyager has left the solar system. And on the BBC, it said NASA's Voyager 2 probe leaves the solar system. So Voyager 2 reached interstellar space. But the claim actually revokes some thick debate about where the solar system really ends. And it could all depend on the criteria people use to determine where the solar system ends. You could say that the solar system in general extends as far as the influence of the sun. But the question is, how do you define influence? How do you measure influence? If you measure influence by the light, by the planets, it could be Neptune and the Kuiper belt, about here. But if you measure the influence by magnetic fields, it could be heliosphere, which is around here. And if you measure the influence by ground gravitational influence, it could be the Oort cloud, even farther away. And those are huge differences. So it could give us a lesson about what kind of measurement we use to define, to delineate personal network, the boundary of the personal network. And content networks could be one perspective to look at our personal network differently than the relationship network. And content diaries could be one approach to help us to achieve that kind of perspective. And there could be other kind of or analogies which might be also helpful. And if you happen to think of any kind of metaphors, analysis would be very appreciative. Thank you very much.
Yeah, thank you for Professor Fu. And I think if we can give the participants to see their contact trees like growing on their apps, they can like spend more time or more investment in their personal contacts, and it'll be a wonderful thing.
Sure.
Okay, so we have roughly 10 minutes for a question or remarks. Anyone want to ask questions? Yeah, Professor Sato.
Thank you very much for the very interesting talk. And my old knowledge on social network analysis is that if you add one node or leave one node, take one node away, the structure radically changes. So, so my question is that is the result of the contact diary robust or not? So if you add more cooperator to your project, then his or her diary will change the structure of the network. So I'm quite interested in such changes.
In a company network, one particular road, one node could be critical if that road plays a lot of important function. But in personal network, it's not as clear. In a personal network, the number of authors could be hundreds or even thousands. And of course, if one's spouse is removed from this tree, that would be very different. The tree would look very differently. And here, if, a family member would count, any family member. Suppose this child is so decisive. This child brings in so many other contexts, other authors into this content tree. Without this child, the tree would look very different. So that kind of node removing would be, I think, most relevant in terms of core member in personal networks.
Okay,
Yes, that's
thank you.
true. Thank you.
Professor Cho.
Hi, Professor Fu. That's really amazing for your contact tree framework and also the result that you show to us. Then actually, my research team we take a different angle from the quantum mechanics. We just try to rationalize. For example, that offshore planned investment of a TSMC, for example. Actually, we are talking about whether there's a so-called solar system that will affect maybe with the collaborator relations, or even we say that might form a contact tree. For example, there is a supply chain, global supply chain, right? Okay. But we have doing in this line of research, we are thinking about the so-called 3 elements of a solar system, including gravity, the mass of the planet, and also the angle momentum, 角动量. Actually, that's more like the 3-dimensional or higher dimensional issues. So I think that you really inspire me that actually I can lend this kind of a research idea to the social science. So my questions for you is, what's your status of code in knowledge in this regard when you try to map in the solar system to your contact tree research? Because so far we are thinking about the black hole phenomenon. Whether sometimes for this kind of a contact tree, we will see a firm like a TSMC, they will perhaps serve the black hole that it can attract all the light or all kind of a content relationship. I'm talking about from the firm level or business level. So I'm not quite sure whether I asked the right question, but it's really amazing to me that the solar system analogy to your contact tree that I research. Okay, thank you.
Thank you very much. Thank you. I know business network should be pretty different from personal networks, but some rules might apply too. You're true. And these ideas from other fields just could be sometimes very so appealing, so inspiring too. Thank you. Okay.
Yeah. Other question? Oh, please.
Yeah, I'm just wondering how long did it take you to collect the data for the diary? And first time I think that diary is like the textual document, but I see a lot of numbers and with the form. So how did you create that structural form for the participant to fill in those as a diary? Yeah. So the time and also how did you create that form?
Right, an app would be a lot easier. This is the first stage of data collection. We use paper, pencil, and by the time we want to ask them about the auto test, they use, well, some of them literally and some others use Excel. And for the app, for an app or online platform, the design helps a lot. Right? You can just click, that's why we call it a click diary. You just click your mouse, click. Right? It's a lot more convenient. And some, a typical diary, well, a typical for us is about months, at least 1 month or 3 months. Here, the first wave of the diary collection is 3 months from 54 Eagles. And 4 years later, 10 of them attended and complete a year-long extended diary. And four more years later, 24 of them did it again. And in another wave, we asked 20 of them to finish 90 days each of the diary, and 12 of them 100 days. And web-based Click Diary, more people attended, and they finished somewhere between 1 month and 2 years, more than 2 years. But for this particular study, you don't need to, the participant did not need to fill in a diary every day. We asked them for a minimum of 3 days a week. But for the first wave, they did it every day. And sometimes a participant was so tired. A lady kept a diary every day for at least 30 minutes because the average number of contests was more than 80 contests. And if you recall, one contest is 1 row of data, which contains about 30 variables. So it's 30 variables by 80 rows. It took a lot of time. And the week-long diaries do not actually help because you cannot get enough information about either context or the author or the person. So you cannot reconstruct network structure from week-long diaries. You probably need at least 3 months. It's a lot of work, you know. Yeah.
The app that you show there, so you have to create an app for the participant to click and keep tracking for the diary, or there's a market-ready diary for you to collect data? Because I see that the questions you ask the participants seems different from the app they provided, right?
No, I know there was some commercial apps, right?
Right. Are the what app you're showing here are commercial ones?
No.
So you have to.
The gentleman designed it.
Oh.
Professor.
So you have to create. Oh, I see.
He designed it.
I see. So those questions are specifically for collecting their social network.
Yes.
I see.
Academic.
Thank you.
Yes,
Wow.
Yes.
Yeah. One question, Professor Everett.
Actually, not a question, just a statement about on that. There is a software tool called Network Canvas. I don't know how people know about that, which will do all of this, and it's free, and it's very well organized, and I would highly recommend it for this kind of work. It was not available when you were doing this.
Right.
And different languages, because you have different participants from different countries.
Right. This is Chinese. We are actually Professor Zhang has designed bilingual, trilingual. Okay. You want to say something, please?
Currently, we have some international partners. So we try to. We currently have some preliminary platform, so can adapt into multilingual platform currently. Yeah. So because sometimes you have same questionnaires and you want to recruit multiple participants from different countries. So it might be feasible currently. Yeah.
Right. One researcher from Belgium has shown interest, and some others from Hungary again are showing interest. So we are working on that. Thank you. Thank you.
Okay, if there's no further question, let's thank Professor Fu's presentation. Thank you.
Thank you very much. Thank you. Thank you. It's already on. Okay.
Where is it?
Okay, so our next speaker will be Professor Yansheng Zhang, the organizer of this workshop. So Professor Yansheng Zhang is a research fellow in this Institute of Sociology, Academia Sinica, and he got his PhD in sociology in University of Washington. So his research fields are social networks, social psychology, computational modeling, behavioral experiments. So he is a winner of some multiple awards, like winner of the Best Paper Award in American Sociological Association like 3 years ago. And he's also a winner of Outstanding Research Award twice in the Ministry of Science and Technology in Taiwan. So let's warmly welcome Professor Yansheng Zhang.
Thank you very much. I know the afternoon sessions are always very challenging because I feel a little bit dozy. Okay, so I try my best to keep everyone awake. The topic is on cooperation and coordination in adaptive network. Actually, this is a topic I have been quite interested in since my PhD dissertation. So although from then on I sort of shift my direction to my research to the other direction, but it's good that I finally got a chance to pick up recently that. But let me start with the history, okay? My first argument is that network experiment is actually a sociological tradition, because every time people are asking, are you doing sociological work? I say yes, because way back in the 1970s or even or 80s, you already seen this kind of works being published in top journals in sociology. Important figures include Karen Cook, Emerson, and Toshio Yamagishi, and later on Markovsky, and then Noah Frighten, and John Scrobbers, and David Wheeler, and finally Peter Burke. Those are very important mathematical sociology working on network exchange things, okay? And if you look at the first study, at the very beginning, 1983, the piece by Cook, they wrote an article, something like this one. A newly developed computerized laboratory consists of a system of 8 isolation booths containing CRT computer terminals linked together through prime 300 mini computers. Back then, 1977, I was only 3 years old. I would say this is arguably the first computational sociological work ever, right? And let me share another interesting story with you is that I was a graduate student in the building, our department at University of Washington. One time I was sitting in a conference room, I look at that door. The door said that there's a sign on stickers saying that we have a social change lab. Okay, I said, that's cool. Sociology can have a lab. That's something news to me, right? And I said, when I was about to ask someone, oh, do you have a lab in the department? I said, oh, you know what? It's not social change. It's exchange. The 2 letters just rip off. This is the tradition, right? And you can realize that when I got to University of Washington, everything is different, right? And then that's how I got started start to do this experiment pretty much from scratch. But if we look at a history, social exchange theory has a long time of journey back to 1980s. And the basic argument is that given a network, something like this one, and people are trying to figure out behavior from, for example, power, trust, commitment, coordination can emerge in this kind of structure. And of course, you see that it's a very simple structure, but of course, that realize, for example, the top and the second one are different because people are taking different position and they were given different power. Not by given, but because by the negotiation and then realize that, okay, some are more powerful than others. So this is the earlier development in the study. But interesting, this kind of study always start with assumption. I give you a network and you tell me what kind of behavior is going to emerge. Later on, you see that the progress going to more dynamic, or what I call network evolution, represented by some, for example, I would call them mathematical sociology based in Pittsburgh, important figures including Catherine Carty, Patrick Doran, and they wrote a book called Evolution of Social Networks. And early on, they used simple computer simulation to understand the network dynamic. For example, Patrick Doran used to study the dynamics of balanced states, because network balance is a very important subject back then. But it's not easy to understand. Okay, you try to make a balance, I try to make a balance, and then we end up have a conflict, right? So people are trying to understand how the conflicts arise and emerge. And moving to 2000, and probably a lot of you have quite been familiar with the statistical approach to the co-evolution of network behavior. And now we are not just focusing on network itself, but also we're looking at how behavior itself is going to change. And although this kind of thing is more like database and statistical driven, but they come up with very good methodology and also implement it in R. A lot of people know this is called R-Sienna, okay? Okay, and if we look at other disciplines, economics and management science, and represented figures including Matthew Jackson, very famous scholar at Stanford. And back then, they wrote an article in Journal of Economic Theory about how networks emerge. Although I would say that it's not really dynamic per se, but the idea, stability they use is still concerning to the network evolution things, okay? Now, if we look at other discipline, physics and evolutionary biology, a whole bunch of them, and all published in the top journals. Actually, my colleague, Shen Wei, is also doing that kind of stuff too, addressing the evolution of the networks. And these are all interested in how, for example, cooperation and other kind of behavior, sometimes even negative one, for example, spy, will emerge in social network. And the very important thing is that these networks are not fixed. They will adapt over time. So it is this foundation on which I start the following study. So my first study is on cooperation. It's also a topic I've been quite interested in for quite a while. Here, I built a work based on the previous finding, and we already know that adaptive network is beneficial for the development of cooperation. But to me, there's one outstanding question, is that to adapt the network, there are at least two ways you can do that. First, you can delete a link. Second, you can form a link. And this seems very natural to a model, because I mean for people who are doing modeling on cooperation, they know that people love cooperate. People don't like defectors. So the key for cooperation to survive is that you just keep away from defectors and try to get connected to cooperator. But the question is that how are you going to do that? Because you can get connected to cooperator. You can also kick out a defector. So it seems to me that in the beginning, it seems to me, oh, these two mechanisms are symmetrical, right? Because it's one way or the other. But then I asked myself, could there be any difference between the two? Okay, so then where are the differences? Mechanically, if you think deeply, I would say there actually is a difference. Because if for link dissolution, if you realize that the guy is a defector, you don't like him, you always have the chance to kick him out. There's no way back. But if you like a cooperator, you can add or her into your circle. But what if this guy betrays, right? I mean, he or she becomes a defector, and then there's no way to keep him or her out. So to me, that these two mechanisms are not real. I mean, although at one shot they seem symmetrical, but actually dynamically they could lead to dramatically different results. And then if you look at the psychological effects, they are also different. I mean, speaking of link formation, I mean, people always think about more positive things, right? I mean, I love you, I can try to get connected to you, I've thrown a tie with you. It's always rewarding and very encouraging, right? And speaking of link dissolution, is a more negative thing, right? I mean, it's about punishment, warning, or renouncing. So, and then people will say, oh, this is, again, two sides of the same token. But if you look into the literature, for example, Annual Review of Sociology published a paper talking about negative social tie. And they showed that, no, negative and positive are not symmetrical. Actually, negativity is sometimes stronger than positivity in some functionality. So to me, mechanical speaking, for mechanical reason, as well as for psychological reason, I see, okay, maybe there's a difference between the two ways of update a network. So I try, because today I'm going to, this session is more about data collection. So in what follows, I'm trying to present experiment setting to address the question. So the basic setting is trying to investigate a very standardized Prisoner dilemma again. It's again which that people will be given a resource, a word C, and then you can give it to a neighbor, word B. B is greater than C. This is a very fundamental nature of a cooperation dilemma. Okay, then I implement two network mechanisms. The first one, again, is just a link dissolution. From a fully connected network, people can gradually delete it. If they don't like the tie, they can just cut it off. For link formation from the full new state, no one is connected to each one. People gradually link to others. So again, there's no way out. So I'm trying to figure out, okay, if I run an experiment with human participants, could I find a difference between the two in terms of how they influence cooperation? And I'm going to show you some interfaces because that's also a very important thing. Okay, let me show you my metric pointer here. Aha. So for those of you who present later, you can use this one. Okay, but only on this computer. If you use it on computer, there's no way. Okay. For game decision, it's very important to provide information for participants such that they know what kind of information they're going to receive when they make the decision. So, for example, here, people are trying to make a decision whether to give, which is cooperating, or to keep, which is defecting. I let subjects know, okay, how many of them, those neighbors who chose to give, those, or I just call cooperators, are neighbors. And these are just defector neighbors. And also to show them how many of them are connected, how many of others are connected to them. So this is more about their sociality. Are they very popular neighbors or they're not unpopular neighbors? And also, of course, I show the average points we receive. That's very important because people always learn from the so-called economically successful. If you earn more points, and I try to mimic your behavior. So it's very important we provide the economic incentives to participants such that we know whether they use the information for social learning. And of course, we provide information about their history for participants. They know that they'll be reminded that what they do, what they did the last time. This is the last time decision. So this is the interface for game decision. And next one is also very important. This is about how people update their neighbors. As I mentioned, that it's very important to know that if I want to update my neighbor, are they cooperative? Are they the good people that such I can trust? So we provide the information about number of rounds choosing to give and divided by number of rounds of playing. So that the number will tell that how cooperated a player is. And then we have, for example, here 4 candidates, and you can check, okay, this is for link formation. So you can check whether I would like to link to him or link to him. You can check by that. So this is the interface. Now I would like to show you the result. Oh, I'm sorry, I forgot to mention that there are some procedures. We recruited 611 college students to participate in the experiment. And for link formation, the average network is about 18 nodes. And for link solution is about, the average size is about 16, the other is about 15. So they are roughly the same. We try not to change the network size. And also very important to look at the protocol. First of all, no deception. This is the standard of experimental economics. Second thing is very important that people really realize what they are doing in the experiment. So we provide a comprehension test. They participate in the experiment only when they pass the test. And the third requirement is real time. So they are playing in the laboratory or online and with people in real time. And finally, it's also important that it's incentive type in the sense that the payoffs they receive will be related to their performance. Okay, that's the requirement for the experiment. Now, let's look at the result. Now, if we check the curves, and the blue represent dissolution, which is a negative thing, and the red represent the formation, which is more positive thing. But you can quickly realize that actually just after the gain or experiment began, that cooperation was higher in dissolution than formation, and both get stabilized toward the end of the experiment. And I would say this is actually consistent with the model. This morning, for example, Professor Martin Everett mentioned that it's very important that before we design any or do data collection, we have to know that what we are asking, what kind of question we are asking. So I would say that I will actually run the model to predict what kind of treatments are more friendly for cooperation to emerge. But here I don't report the model, but only show you that this is consistent with our prediction. Okay, and also as I mentioned, it's very important to see how, to what extent cooperating as a player influence people's choice of neighbors. So here I can just check the effects of cooperating on neighbor selection. This is the regression coefficient. As long as they are positive, that just means that the more cooperative I am, the more likely I'll be chosen as a neighbor in link formation. On the other hand, reversely, the less cooperative I am, the more likely I'll be kicked out, okay, in link dissolution. So here's the symmetrical. We compare the effect size of these two treatments, and it's quite obvious that the blue, which is a link dissolution, is stronger than the red one. So I would say that it is true that cooperative players are more likely to be chosen or retained as a neighbor, but actually the effect is stronger in link dissolution than link formation. I think that also can explain in part why we observe this kind of situation, why cooperation turns out to be higher in dissolution than formation. Okay, so this is my first study. Moving on to the other study also related to adaptive network. Oh, forgot to mention that. I found this article very exciting, also related to our theme in the workshop. Last year, Nature Human Behavior published a very astonishing paper done by Google DeepMind. You probably know DeepMind, right? They are very famous at creating AI that can beat real players in video games. And they created AI work that can, here in my previous study, I am allowing people to change their network neighbor. But here in the study, they train the AI, telling people what kind of neighbor you gotta choose. And they compare their model against human peers, and they show that AI is smarter because the AI can create a better society. Okay, that's very astonishing. Whether you buy it or not, we can leave it to the discussion. Okay. Now, moving on, coordination is another related topic. But sometimes when we speak of coordination, we have to be careful what we do mean by that. A lot of times that coordination is equated to synchronization. For example, participation in social movement is one example. If you go, then I go. If you don't, then I don't, because that's for the reason of the reduction of the risk. But sometimes we coordinate it to be different. For example, people are trying to pursue diversity. If you choose that color or that eyeglasses, I try not to wear the same as you, right? In Chinese, we call 撞山. That's a typical example. And of course, that in public space, we try not to collide with each other. So if we go that way, I try to go the other way. This is another example that people are trying to coordinate on different things. And how can we characterize such a kind of coordination of heterogeneity? And there's a very classical or very elegant game called graph coloring game, which is popular in computer science. The coloring game is something like this one. In a central node, represent yourself. You choose a color, say blue, and your neighbors could choose, for example, green color, yellow color, or other colors. And easy to see, for example, on your left-hand side, I would say this high score just means that you are quite different from your neighbor. On the other hand, if you choose blue, but also you have two other neighbors also choose blue, and you receive a low score. So this is a very simple way to model coordination of heterogeneity. I'm not the first guy to apply this kind of game to sociological research. Actually, earlier, Erickson and Sherrado published an article in ASR. They are also modeling this kind of stuff to replicate different kinds of early idea about division of labor. So that's a very useful framework. Okay. Similarly, we recruit college students. Again, only convenient sample. And the average session is about 20, and standard deviation is about 3.65. Protocols are also similar. We start an experiment with introduction and also a comprehension test. And here we are trying to compare the difference between static and dynamic treatments, okay? And then similarly, participant behaviors are incentivized, and we use the O-tree to program the software, okay? As I mentioned that, let me show you the demo of an interface, okay? So here, for example, this is the interface that people will choose. Okay, you have three options to choose from. You can change your color, you can change your neighbor, or you can do nothing, okay? And this is the state of the focal player. So they realize that, oh, I'm linked to four other guys. Okay, one of them has the same color as I do. And the rest players at the top are players who have not been linked to me. So this is the interface. And then to choose a neighbor, okay, and you can just, first you have to delete an extended neighbor. For example, because I choose a color black, so this guy has the same color as I do. So I delete this guy, and then I can just propose to a new neighbor. So that's the basic idea. Okay, so let's take a look at the findings. Now we have three curves right here. At the top, the blue color are dynamic network, and I would say the gray color right here, okay, are the static network. Apparently, that dynamic network works better than static network in promoting coordination of the coloring here. But keep in mind that I also implement this. The curve right here. This is actually represent random simulation. What does that mean? It just means that every time I just let the player randomly choose a new neighbor. So on purposely, it's not based on the color they have. So where I'm testing, is it because that I can have the same effect of a coloring game just by randomly updating my network? So here's the idea. But turns out it's not the case. So you see that actually the random network is actually performs worse than purposefully rewinding the network. Okay. I also checked the network topology of the evolved network. So here I'm using the two network measure, closeness and clustering. So closeness actually means distance. So if you look at the trajectory, you realize that closeness actually increases, or I say network distance decreases. And then clustering decreases as well. If you're familiar with Watts and Schwarzkopf's model, you probably notice that, oh, this is actually very like a small world model. Okay, then you might wonder, okay, how do people coordinate, or what kind of strategy they're going to use to achieve high scores? So I plot the distribution of their strategy against the score. So the color actually here represent how high the score they achieve. Okay, so I would say that high scoring players actually switch between change neighbor and stay put. That's exactly how you see this the solid color represent here. So what does that mean? It means that players actually have three options. They can choose color, they can change color, they can change the neighbor, they can do nothing. But in the treatment, they only choose two: change neighbor or do nothing. They actually use very little the strategy of changing color. Okay, all in all, I would like to use the remaining like 5 minutes to talk about, to give a summary about online experiments, okay? And what does it do, okay? As I mentioned that this is way traced back to when I did my PhD dissertation. But still, I'm still very, very interested in keeping it in my toolbox. I would say that very important functionality of that, it helps to identify causality and tease out confounding factors. I mean, we know that experimentation, although lack of external validity, still remains to be the strongest tool to test causality. For example, those of you who are interested in social media things, Duncan Watts, who is the founder of modern computational social science, is a person I admire quite a lot. And he and his colleague published an article just a few months ago, and they using experiment to causally estimate the effect of YouTube's recommendation system. So we know that social media is a complicated thing. We have algorithms, we have users' biases, just like Professor Avery mentioned this morning. But in order to clarify which mechanism is at work, I think experimentation remains a useful tool. So for those of you who are interested in this article, I highly recommend it. A second thing is that we know that as a sociology, one of our big mission is to understand the so-called micro to macro link. Like tracing back to James Coleman and also Essen, Baskin, and Robb. And here's a very representative diagram we are quite familiar with. From macro down to micro, micro to micro, and then up to macro. I would say that this part is actually the most difficult, right? And this is the part I believe that experimentation, online experimentation, as well as modeling still plays a very important role to understand how, as a collective team, we emerge from individual actions. Finally, online experiment, who knows, can be commercial. Okay, I want to share with you a very interesting example. Coulthard and others published an article in Nature 2 years ago, and this is the game they use. They call Sea Hero game. They actually first used for treating and testing Alzheimer's disease, okay, only for academic purpose. But then real people realize that it's fun, okay, and then some commercial company just take it over and promote it to be part of a video game. So I'm just encouraging myself, who knows, I mean, I always design game. One day it can be some commercial product, but I don't know, okay? But thank you for listening.
Okay, thank you for your fascinating talk. I just come up with one thing I think is fun. The title you use, Cooperation and Coordination in Adaptive Networks. I think I give one very similar talk in physics department or applied math department, but you showcase a very different point of view from sociology and social science. I believe this is a very interdisciplinary subject, and maybe you can give talk to other fields for other people. And they will be very fascinated about this research topic.
Okay, cool.
As well. Okay, so we have about 10 minutes for question and remarks. Professor Xiao.
Well, fantastic talk, and Dr. Chang, you know, I'm very interested in this type of work. First, I would like to comment, like as a PhD also from UW Sociology, none of those words are there anymore. Not even the word social. So, but back to my question. So, I would like to pose a question about dynamic networks, by which networks evolve over time. And this is an area that I have not dared to tread in, despite doing quite a few network analysis articles, because how do we specify the change of ties? And I think this is a question that has kind of scared me off in this arena. Most of my work deals with static networks and what follows. So the reason I'm posing this question is, for example, in the experiment, how do we decide what is the potential set of nodes that an individual node can potentially link to? So for example, is it everybody within the whole network population, which is probably impossible when we scale it up to like 50 or 60 people. Like, how am I going to decide when I'm going to choose A, B, C, D, E, all the way to person 60? So perhaps then there's an alternative mechanism where I'm only potentially able to connect with nodes that are already connected to me in a second degree. So kind of like friends of friends. But then are these choices also feasible? I mean, realistic in terms of what happens in real life? Or should we do something more on homophily, for example, going back to the earlier lectures in the morning? So what is your take on this? So how do we specify, for example, an experiment, what's the choice set for a person to change their network ties over time?
Yeah, that's a very,
thank you.
Very good comment. I would say, yes, of course, that first of all, the advantage or the leverage of doing experiment is that you control everything. Like you are God, right? So you can provide as much information as possible. So it really depends on if you want to test homophily, and you can, I mean, of course, from empirical network, we know that, okay, network is driven by pursuit of homophily. Okay, so in experiment, you can test that. For example, you only provide information about neighbors similar to the focal plane. But on the other hand, you can, well, one thing good about experiment is that you can test it by comparison to the counterpart. What if they provide different, attributes? Would they behave the same? So that's the way you can do. But on the other hand, I totally agree that sometimes when I design an experiment, my colleagues always challenge that you provide too much. There's too much to absorb, right? Too much to digest. And to that, I have a defense is that it's up to them what kind of information they want to digest. Actually, psychology or way some kind of eye tracker. They can track, okay, what kind of information I'm looking at. Even though you give them a whole bunch of information, they still selectively choose what they want to do. So the way we do is provide as complete set as possible, such that we can know from which they choose. But again, I love experimentation is that it's quite flexible. It depends on what kind of question you would like to set, and the experimentation will come with you. So let me emphasize again, experimentation is not trying to answer empirical question. It's a companion to a theory. That's always the remark I have to say. Otherwise, people are confused. How can you explain everything in the world? I say this is not my ultimate purpose.
Yeah, I think it's still better than simulation, I guess. Professor Cho and then Professor Everett. Oh, Professor Everett first. No, I see you both raise your hands at the same time.
The thing always about these experiments, it seems to me, is that you know everything there is to know about university students.
Right.
And there are other people in the population. To what extent do you think it makes a difference that psychology has been the same. Nearly every psychology experiment I ever read, it's been on students. Right. And I just wonder to what extent there would be a difference if you had a different population, particularly people who are a lot older.
For that part, actually, I'm not worried about, because we sociologists are known for going to the field work. Actually, I try to work with Professor Fu. We are trying to recruit particular people who have high contact. Remember that. There are particular occupations, not just in Taiwan, but elsewhere, who are known for have high contact. We are trying to recruit those kind of people to the experiment. We tried, but finally we didn't have a chance to do that. I'm not worried about that as a sociologist, because that's our expertise, not mine, but we have a lot of people always go to the field, and I believe that they can contact the right people for us. For me, sometimes even more struggling is that even I use college students and try to publish the article in the West, people criticize. This is from East Asia, not representative of the US. I said, how come here now we have a cultural difference, right? I mean, when we use college student, we assume there's no cultural difference. But then, I mean, this is always the struggle. But I totally agree with you. One time I published submitted an article to a more psychological thing. And I think this kind of reflection is more pronounced now in psychology than probably I don't know elsewhere. Because psychology, we realize that they are thinking maybe they are rely too much on so-called weird people, Western, industrialized, educated, and rich people. Yeah, yeah. They have a good reflection on that. I hope that will also change society too. Yeah.
Thank you very much for this very inspiring network experiment studies, two studies, okay? Your findings also give me lots of insights regarding the Professor Thomas Schelling, the Nobel Prize winner in strategy of conflicts, okay? And they actually had a similar experiment as yours, such as the finding neighbor, okay? I think I would like to first to solicit Professor Zhang's comments on these two effects in this kind of experiment. First is so-called network externality. For example, whether after you choosing the neighbors will enlarge or contract your contact relationship, for example, because you probably more willing to contact with a good neighbor, okay? So this kind of network effect I did not see very clear from your presentation first. Second thing, that is the effect from Professor Thomas Schelling's experiment. He's talking about the so-called chain effect, okay? Whether a neighbor's decision will affect the other and then form a chain, okay? And in my research team, actually, I applied Thomas Schelling's work in two directions. First, we are not doing the prison dilemmas game because after we have a repeated prison dilemma, and there's an automated self-reinforcing mechanism to foster the so-called collaborative behavior or relationship. So actually, we use the dove and hawk game, that is evolutionary game. So actually, they will change the population, two subpopulation. One is hawk, another is dove. And then the outcome will quite depend on the so-called mutation of each population. And then one population may get larger because of the more dove or more hawk joined. So this kind of chain effect, they might quite depend on the game structure you are talking about. And actually, you're talking about a business implication. Also from the UW and from the business school perspective. Actually, we use the similar ideas to examine the TSMC's global investment. Particularly, we are quite interested about the site choose decision. And there's sometimes there's a matter of a geopolitical risk change. So this is a little bit with a business implication. My research team actually take the first step and then just feedback to you. And I have two questions to solicit your comment. The first is about the network externality. Second is about the chain effect. Thank you.
I can answer the second question first. Is the chain effect actually in the experiment we do provide information here, here. Actually, people will have a view on, for example, the average payoff to receive. So this is actually, okay, I know you are successful, then I may learn from you. So keep in mind, this is the phase when people make the decision. So they usually refer to how much people get previously and before they choose their partner. So actually we implement two processes at the same time. Yeah. And for you, the
network externality, whether they will
yeah.
kind of the more the better, and the more neighbors, good neighbors will move in.
Yeah, that's actually also part of the phenomena because the basic idea about the how cooperation emerge in networks that actually finally cooperates cluster together. So this I would say a network externality is that you're linked to a cooperator and you two get quite well. Then I'm trying to join you. Everyone is happy. Everyone is cooperating. So I would say that also reflects. Yeah.
Thank you very much.
Oh.
One last question.
Oh, is it back?
Yeah,
It's okay.
Okay, yeah. So I mean, just curious. You spoke about experiments, and I'm wondering. This is quite popular in economics and slowly getting popular in communication. But is there a tradition of field experiments in sociology, in that where you try to you can kind of circumvent those questions about student populations and all that by just doing experiments in the field?
Can I say Stanley Milgram's experiment, the field experiment, the small world experiment?
But that was more. I mean,
That was a big experiment.
Yeah, the biggest. I mean, it's field experiment.
It's like half of the U.S.
Yeah.
Yeah.
Nebraska to Boston.
Yeah.
Yeah, but it's not like a clear control group and a treatment group kind of experiment, right?
Yeah.
So, I mean, you see this in social media, right? Where you change people's, like Facebook famously did an experiment 2011 where they increase the number of emotionally loaded terms on some people's feeds, not on other people's feeds, stuff like that.
I remember that. I know how to respond. Actually, probably Professor Martin Everett, know that there's some study called network intervention.
Mm-hmm. Yeah.
Okay, network intervention. I remember there was one study, cannot remember, by psychology at Princeton. They select a total of 56 schools at a high school, and then they first recruit people, identify who are the position opinion leaders, and then give them some education. Right? For example, not to learn how to smoke and those kind of moral education things, and then release them back to the network. Observe them in 3 months to see how they affect.
That's called ASSIST.
Okay.
ASSIST. Assist.
Yeah.
That method is called this?
Yeah, it's a network intervention.
Okay.
I think that's field experiment, right?
Okay.
Yes, it is.
And very rare opportunity. No one, I mean, not people can do that. That's IRB could be quite an issue.
Yeah.
But
Thanks.
Okay, due to the limitation of time, let's thank Professor Zhang's presentation again. Okay, according to the schedule, we have roughly 16 minutes for break. So we will be back at 3:10. Okay, I think due to our tight schedule, we just slowly start. Okay, so now we have Professor Zhanda Qian. He is a research fellow in Research Center for Humanities and Social Sciences in Academia Sinica. And his PhD is very special in Institute of Epidemiology in National Taiwan Universities. So his research fields are health informatics, geographic information system, infectious disease in epidemiology, spatial temporal analysis, etc. So Professor Zhang is the only epidemiologist I know who works in humanities and social sciences. I think the only one in Taiwan at least. And his nickname is Zhan P, P for professor. So it's my great honor to welcome Professor Daqian Zhan. Thanks.
Okay. Good afternoon. Thank you for Professor Lee's introductions. During my presentation, I think my topic will be a little different from previous presenters. I'm talking about human and environmental interactions. So, because the personal-to-personal interactions, as the Professor Fu already mentioned, like counter diaries. Okay, so we will also borrow in the concept from the counter diaries. How we borrow the concept and the design from the counter diary. I mentioned that, and also we're using the social media as a platform to make the survey, and using AI technology to make our objective observation from the environment, because if you want to quantify the environmental observation, if you let the people to record, sometimes it's very hard and is also maybe inaccurate. But with using the AI, can help us to make it more feasible. I will talking more about that later. And also we want to know to quantify the sound perception. This is soundscape perception from the human side. And also we record the spatial temporal information, and also the personal traits are also very important to affect, like acoustic comfort, and also the affect quality of life. Okay. So first of all, I will introduce the ideas from the Click Diary platform. So as Professor Fu already mentioned about that, so the two very important features from the Click Diary is the daily-based data collection. So we can reduce the so-called recall bias. So this is very important for recording the data. Okay, and the second one is the so-called participatory cohort follow-up, because we have a repeated sample, so we can verify some in relationship again and again. Okay, so and the second one I will want to introduce the concept of ecological momentary assessment, because we're using this concept for building up our sun map application, building up in Line social media. Okay, so in that application, or so-called chatbot, Line chatbot, in Taiwan we have more than 22 millions of people using, maybe a count of the Line chatbot in Taiwan. So you can see how popular with this social media. So we take advantage of this social media to conduct our survey. Okay, so and also we push out some information to conduct the event-based questionnaires and also structured questionnaires, and collect a subjective perception, objective observation, and also collect spatial temporal information. Later on, I will introduce more detail. And I will highlight the research questions we want to address, and finally interpret our findings, and we also make it possible to translate to citizen science, and we engage with the citizens to promote our concept of the soundscape in the communities. So ideas from a Click Diary platform, you can see originally we want to trace the mood contagions and the flu transmission from the social network, and also we want to explore the correlation between health behaviors and the change of a mood. So you can see the nature of this kind of information that will change every day, and the mood, even the mood, that will change every time when you encounter with the people, right? So before and after, when you encounter the people, the mood may be changed. So we, in our Click Diary platform, we try to capture this kind of dynamic change of the mood, and also the network change, okay? And the third one is to explore the quality of life and the social network structure. Okay, so we try to capture this kind of, all this kind of dynamic information by our diary approach, and to record, to avoid the recall bias, and also typing. Oh no, you know, everyone don't like to type anymore, right? So click the icons or click the items on the screen is much more easier for everyone. Maybe Dr. Zhuo, the last presenter, maybe they will talking about more on the screen capture technology later on. Okay, so using Click Diary approach for tracing the contagion effect and health behavior in our past work, you can see, although the small number of participants engage in our project, but with very finer contact level information, or from multi-level, from contact, from alter level, right? So you can use in this way to make more inference about the relationship and also the contagion effect. So this is our first prototype of a Click Diary version 1. Okay, so at the beginning in 2014, we're using like web-based platform to let our participants to record the contact diary and the health diary at that time, and so also the apps for the iOS and Android platform to collect the data. Okay, so the originator from this project is from one project from sponsored from the Academia Sinica. So the major idea is that we want to collect information from health behavior and the social network, and also the outcome is like a mood or influenza or like illness. Okay, so so diary-based data collection is very important, and the contact diary is a very big challenge, as you know, like Professor Fu also already mentioned it, and also periodic structural questionnaire is also very important to give us our some more detailed information about that. Okay, so this is just a brief outline of our information, what we collect, including the basic information at the baseline and the health behaviors every day, social network labels data, number of contests for each type of contest, a type of contest and the content intensity, purpose of contest and content emotions, and also the for the flu contactions we record the IRI symptoms from the otters and eagles. Okay, so this is just the brief introduction from ideas of the content diary or click diary. So the other concept is from the ecological momentary assessment. Okay, what is EMA stands for? So EMA says repeat sampling of subjects' current behaviors experienced in real time in subjects' natural environments, which means we want to record the information at the right time, at that time, your subjective feelings and the objective measurements from the environment. So it's really hard, but you want to capture these two information at the same time. Because sometimes we have a one-shot survey, but maybe after the period. So you may have some memory loss, right? And also have some recall bias, okay? And also the environmental exposure maybe not correct because you have so accurate exposure information there. So EMA studies often using the random time samplings to push out some information to make it feasible, such as like using the written diaries and the telephones to electronic diaries and some physiological sensors. So like in our studies, we use in Line, or this is social media platform. So we're using like a random message push out. Okay, in the morning, afternoon, and night in the random time. Okay, and using a cell phone to record the sounds with a microphone, so we can real time to using AI technology to differentiate what kinds of sounds they record, and accuracy can reach up about 80%. Okay, and also collecting the moment feeling at the time. Okay, and also recording the spatial temporal information because every cell phone they have a GPS. Or AGPS information. So like in our institutes right here, so if you open your Apple Map or Android Map, you know where you are. So you have a GPS coordinates, we can know where you are, okay? So these all be helpful for our further analyzing, like we link to the land use information. We know where land use they located in. Okay, so this is like a project's website. Okay, sorry for it's a Chinese one. Okay, so this is a soundscape recordings. Okay, so as you know, like Professor Fu, when during his presentation, you might hear about the mechanical noise outdoors. Yeah, so maybe your heart rate is speak up and you feel uncomfortable, right? So noise is very, big issues in everywhere in the world, okay? So even in Taiwan, this is Taiwan EPA's statistics, you can see the complaints among the public nuisance. The number one is noise, okay? So why we want to dig out the mechanism and the subject feelings of the noise, okay? Okay, also in the European countries, noise exposure is also one of the important indicators for SDG. So how they conduct a survey. So for the European countries, they have some routine survey for the subjective survey. So they are measuring like people living in household considering they suffer from noise. So every year you can see different countries, they have like this subjective survey. Okay, so like in left figures, you can see Malta, Romania, and Germany, the first three, and the 2020 is in the other three countries. Okay. Okay, and also the other question is that some noise, WHO and also many other empirical studies demonstrate that health effects from noise, like cardiovascular, endocrine, headache, poor sleep quality. Okay, so I still have some studies related to that. But in today's talk, I will talking about before developing a disease, maybe the quality of life indicators and acoustic comforts are our concerns before you developing a disease. Because when you hear about noise, you will feel very uncomfortable, and you will decrease your sleep quality and the quality of life and some acoustic comfort. Okay. So the aims of this survey, we try to understand the cause of noise annoyance. Okay, and we're using the we're using the survey we designed to record the multi-level factors such as like acoustic comfort and the perceived health effects of sound exposure. This is from like a subjective one, and also we have using the line chatbot to record like a sound characteristic and the spatial temporal features of the surrounding environment. So this including the objective one and the subjective one together, okay? And the second part, we want to understand how the noise exposure affects on their quality of life. So this including like the structural questionnaires such as noise sensitivity, burnout status, and also the sleep quality. Okay, so this is like structural questionnaires because they have already standardized and approved by many scholars. Okay, so we're using this one as like our golden standards, and because in our daily collections we already have 3 times personal exposures collection by our participants. So we integrated the personal levels factors with these like structural questionnaires data together, or to make an inference about how noise exposure affects our quality of life. Okay, so this is like these 2 papers we already published. So this covers what we talked today. Okay, so I just in brief introduction of our invitation table or our study settings. So our study period is like 2 months or in 2022, and our target is like age or adult age peoples with line chatbot to participate in our platform, and always use snowball strategy and open recruitment, and they need to complete 2 tasks. First one is recording, okay? So after they recorded around 10 seconds sounds, we will follow up some short questions after the recording, okay? So they need to have finished at least 15 days, including at least 4 days weekend, Saturday or Sunday. And the second part is the questionnaires. So during the follow-up periods, we will push out standardized questionnaires, okay, to collect more structured outcomes. And of course, they need to have some incentives, like early birds and the lottery schemes to enhance their participation. So this is our interface. So line, maybe everyone is familiar with this one. Okay, this is like a chatbot here. So first of all, they will have some welcome message, and for each record, they will record 10 seconds of sounds, and at the moment, they will just return some pressure for you, and AI will tell you what kinds of sounds there. Okay, if you feel the AI make the wrong recognition, you can report. Okay, and also the subjective feeling of the sound, we have 5 scale here, and also health impact from the sound, also 5 scale. Okay, and where you expose these sounds, like indoors, outdoors, and transmutation mode. Also, we're using a click diary. The concept of click diary is all you enter is by the click. Okay, so you don't need to typing. So this is very easy way for our participant to record. So for we track for each of the record is around 1 minute can finish this text. Okay, so which means every day you can have to spend 3 minutes to finish our survey. Okay, and the types of location and also AGPS location by line. So you can using transmit your location. We can get the precise SY coordinates of these participants for where you record. Okay, so and also we have a count of recordings and days because it is for the incentives one. Okay, so for the systems we send an automatic notification to record the sound 3 times per day for different times. Okay, for random times. So we will try to make our sampling scheme more diverse as well as best as I can. Yeah. And the 5 words of questionnaires, every 5 days, the systems will automatically send a notification to our participants for filling out the structural questionnaires, including like a demographic questions and the tone noise annoyance in the household, quality of life and self-reported health status, and the quality of sleep and the mental health, and the personality, sensitivity of noise, and the fatigue. So during our follow-up, we will let our participants to fill out all these structural questionnaires there. Okay, so this is just a screenshot for you. So you can see like this is a notification, and you want to just shortcut for filling the questionnaire here, or you can just quickly shortcut start the questionnaires. And begin to fill the questionnaire, you can hear. And we're using the Google spreadsheet, or maybe you're already familiar with Google spreadsheet. We can embed this Google spreadsheet into our Lightship bot, okay? So you can link which one is this line users to this questionnaire. Okay, so it's very important. And you let your users not feel you go to outside the survey, the screen. Okay, this is also very important one. And also, if our participants passing our quality controls process, we will directly issue the electronic coupons, 7-Elevens, okay, convenience stores coupons to our participants. So the participants are very easier. They can just inactivate the barcode, the password, and using this barcode to go to the convenience store to buy the goods. So it's a very important one because incentive scheme is very important to our study. Okay, so okay. The other one is so we also map our soundscape data from chatbot. So you can see that this is just for example for the decibel. So the right side is the decibel, and for different color is for different decibel. And the right side is the perception. Okay, perception. The red one is very uncomfortable, and the blue one is very comfortable of the sound. Okay, and also the place, location, which kind of location, at the home, at the industry, in the campus, in the restaurant, on the roadside. Okay, so different kinds of data there, and also the transportation, where maybe sometimes they record the sounds in the transportation, like the train, like high-speed rail, MRT, bus, and in the cars. Okay, so we can know which kind of transportation they are located. And also, as I mentioned, for the AI technology, we can use in this one for only the 10 seconds of the recordings, the recognition of the sounds. We have like more than 500 kinds of sounds, types of sounds. The accuracy for our respondents is like 80% because we will confirm by our respondents. So overall, during this survey, like 80% accuracy from our survey. And you can also, because we have the recordings, so we can conduct the further analysis of the sound characteristic, like sound pressure, and also frequency profiles, like low frequency and high frequencies profiles, because this will also affect the quality of life or the acoustic comforts for the person. Okay, so this is our findings, because this is a very detailed one. If you get interested, you can see our papers. But finally, you can see that we included like around 207 participants. Not so much, because although our participants very much, maybe around 700, but the sound quality is not good. So quality control is still very important, especially for like this online survey. So we screen out a lot of people. They are not pass our quality control. Of course, we don't give them the coupons. Okay, okay. So this is and also we included more than 10,000 sound records for further analysis. So we included like the questionnaires and also the sound recordings data together to make analysis later on. So you can see this is like a spatial distribution of all included recordings. So you can see we only have about around 207 participants, but you can see the distribution is all over Taiwan. Okay, so because people will move, people will travel, so they can record their sounds everywhere. Okay, even the outer islands, there's Kinmen Chemung counties also have a data there. Okay, so you can see using see this approach, and they have some advantage there. And also, because we have a location of where they record, so SY coordinate, so we can link to the land use, because we know where they record. Okay, so you can see like this area is very comfortable and comfortable acoustic comfort. So you can see that like in mountain areas or in rural areas of Taipei or New Taipei City, they have a more higher percentage of comfortable acoustic comfort, but in the downtown Taipei City, they will have a lower uncomfortable acoustic comfort there. Okay, so by the modeling, we're using some way like using the mixed model to model in the acoustic comforts, which kind of factors will affect of our acoustic comforts. Of course, like a rural area have a higher chance of acoustic comforts. This is the arch ratio, and also in on the weekends we have higher probability of acoustic comforts, and also we have some features, and we link it to some land use, like in the forest land use, they have a higher probability of better acoustic comforts. But you can see that very interesting. All traffic-related sounds, they are linked to lower acoustic comfort. Okay, so you can see like in a train and metro or metros on the road, they have a very lower one. Okay, and also in the transportations land use, they also have a lower types of lower acoustic comforts there. And the other one is on the agreement with positive health effects from sound exposure. Okay, so you can see the similar result from the previous slide. You can see also like in a built-up area or recreational facility land use, there will have a lower agreement on positive health impact from sound pressure exposure. Okay, also for the train and the metro, metros on the road, these kinds of locations. Okay, and the other question is that how about the correlation between the acoustic quality and the quality of life? Okay, so because we have different domains and different types of data in our structural questionnaires, so you can see for this, for example, for the acoustic quality in the dwelling. In your community, you will find a better acoustic quality in your community. You will find they have a better physical quality of life, psychological, and social environment. So these four domains will be positive related with your acoustic quality. Okay, and also we do many regression analysis for quality of life and like a personal burnout. You can see here, like if your overall evaluation of your living environment is very good or good, so they will have a better quality of life. Okay, and also in the other one, because we have daily exposure data, because daily sound exposure data is too much indicators, so we're using the PCA to reduce the dimension. Okay, so we have some clusters there. Okay, so this is like the personal daily exposure. Okay, one. So if your daily exposure is better, you will have a better quality of life. But okay, in a contrast, you will have a poor quality of life. And the other outcome is like a burnout score. Okay, so you have a very bad exposure or bad noise exposure time, so you will have a lower burnout. And some features from like the personal traits, like a neuroticism. Okay, some person from the neuroticism is very nervous, one, and then they will have a higher burnout score there. Okay, so personal traits will also affect the quality of life and also their burnout scores. Okay. Okay, this is the other one. It's like sleeping quality. This is a very intuitional result. Like if you perceive your acoustic comfort is better, your sleeping quality is better. Okay, but if your sleeping is disrupted by noise, you will have a poor sleeping quality there. Okay. And we also conduct many chain mediation model. This is just one example there. So well, we want to identify which factor affect like the quality of life is our major outcome. So like noise disrupt sleep and sleep quality and the personal burnout. And after our modeling, we found that like this direct effect accounted for 80% of the contribution. And the second, the direct one is accounting for like 20% of contribution of to the quality of life. Okay, so okay, just a very quick summarize of our findings for these two studies. So first one is like association between lower acoustic comforts, such as female, nocturnal, some exposure, urban land use. Okay, so this is related to the lower acoustic comfort, okay? And the higher acoustic comfort is related to the like natural sound, silence, music, and human activity, and also in rural areas. And then some human personal traits like introversions that will link to greater sound tolerance, okay? It's a very interesting one, okay? So overall, you can see our findings underscore the deterministic effects of noise exposure on sleep quality, burnout, and the quality of life, and emphasize the importance of addressing noise pollution in daily life. Okay, my next present will show how we engage, or how we translate our findings and engage the citizen to participate into the quiet tracking project in the Taipei City. So it's very interesting because we already find the result, how we can transmit or translate our findings into the community. That is what I want to do. So civic engagement to draw everyone's attention. So this is like a 55 dB program in Taipei City. As you know, in the United Nations, they published one report, so-called Frontiers 2022. They say quiet space and the present sound space is very important to the citizens in the city. Okay. So we engage some so-called quiet trackers to report quiet place. So here, red one is the decibel exceeding 55 decibel, and the blue one is below 55 decibel. And we let the participants to take a picture and record the sounds also. So we're using the multimedia data together, okay, to let participants know, to let our citizens know where are more quiet and where are no more noisy. Okay. And of course, we're using some apps to train our participants. Okay. So this is one example, like one location in Taipei City near the MRT station. This is like pictures. So but maybe picture you have some feelings like very quiet one. Okay. Of course, the recording is really also very quiet. Okay. The other one is like this one. It's a very uncomfortable sound, like near the Taipei City. Okay, so you can see the AI recognition result is vehicles, traffic noise, road noise, motor vehicles, and the sound pressure is exceeding 70 decibel. Okay, so it's very uncomfortable one. Okay, of course the participants also report it's very uncomfortable one. Okay, so this is just one side project from our translating our results in the communities. Okay, that's what I want to share. Thank you.
Yeah, another fascinating talk. I didn't know that the damage of noise could be like very comprehensive to different aspects of quality of life, like even a social one, right?
Yeah.
Like maybe if you do this research in a community of people, maybe you can see like this kind of like could be an epidemiology. Like if I suffer from more noise, maybe this damage could transfer to my neighbor. Maybe. I think this is. You could use that in the future study too. Okay, so we will have like 10 minutes. So any questions or comments for this research? Okay, so I see two. Okay, then you first.
Thanks for this talk. I mean, I really enjoyed the use of AI in this way to, you're basically using image data to come up with measures of a different format of data, sound data, right? Which is fascinating. I was thinking if there is any like what sort of? I mean, I know that the last thing you mentioned is it's not published yet, right? You're still working on it.
Yeah.
So I'm wondering what sort of validation exercise you might want to do to check if there are, if ChatGPT says this image corresponds to high volume or high decibels of noise, what sort of validation would you do to check that this is indeed the case?
Okay, great. It's very great. We don't use image one. For this case, we don't use image one. Is just only for like the citizen projects.
Okay.
But for our projects, one is recording the sound.
Yeah.
So how we using we're using the AI algorithm called YAMNet. It's like it's from the it's trained by the YouTube. So you use many YouTube sounds there to build up these AI algorithms. Okay, so we cannot train that model because we don't have that kind of sounds there. Okay, so the validation of sounds we use in like a sampling record. Okay, so we have using two ways. One way is because people will respondents there. Okay, so people will rating the records. Like I record the sounds for the 10 seconds, immediately the systems will automatically push out the results for the sounds. Okay. And the participants can make some correction at that time. So we let our participants as one of our correctors. Yeah. This is one side. And the other side is from our research team. Our research team, we're using some sounds from our recordings to test the capability of the AI sounds. Okay, so this is two way we validate the AI algorithm and how the AI recognition is correct or not correct from our sample. Yeah.
So you validate on a sample or the whole data set?
For the participants or whole data sets.
Wow, okay.
Yeah.
Okay.
But for our research team, we only using a subset. Yeah.
Thank you.
Thank you.
Thank you very much for the very interesting talk. And I have a question related to my talk this morning.
Yeah.
Okay, suppose you and I were neighbors, and if you and I had a good relationship, the sound you made to sound to not a noise to me, but if we are in a very bad relationship, a small sound you made would be a big noise to me.
Yeah, right.
So how can you? Is it possible to such an interpretation process in your study?
Yeah, it's very interesting. Yeah, the similar questions some other people ask me, but not directly related to this one. Like we're talking about like a sound pressure, right? Maybe 70 sound pressure is very noisy. Like you stand along the roadside, it's like around 70 decibel. dBA, 70 dBA, okay? But you can see like some animals, their sounds also around 70, but you don't feel animals' sounds is not a good one. But you feel from the motorcycles, 70 is a very bad one. So it's very similar questions related to Professor Sato's questions. So sometimes, if we conduct a survey in a confined community, maybe let's work. Because like in Taiwan, many people complain about the neighbors' sons a lot. So you can see even in Taiwan, each year, the complaints from noise from Taiwan EPA is around 100,000 complaints. It's very loud. From lots of proportions from the neighbors. Yes, yeah. So maybe the relationship is another issue we can consider about that. but I don't know IRB will. Is some kinds of you have to link the relationship between our participants, right?
Maybe you add a question to the questionnaire, the relationship between the source of the sound and yourself.
Yeah. In our questionnaires, they have one related to this one. It's called the acoustic comfort in the dwelling in the community. That questions they are talking about. They have some sets of question. They're talking about is there noise from your neighbors, upstairs, lower stairs, and your neighbors. In the structural questionnaires, they already have these items in that. Yeah, but they did not identify which neighbors. Okay, but in next structural questionnaire already have that kind of information there. Yeah. Thank you.
Oh, I see. Okay, Professor Han.
So I have a question and a comment. The question is about the hardware. So if everyone carry different cell phone with them to record, in the same place, maybe the dB you capture would be different across the instrument? That's the first question. The comment is, I can easily see how I could turn this into a sociology of education study by adding student outcomes. So if they suffer from noises, if we ask one additional question, what is the score or the grade that you receive in the semester, then we can easily build another study out of it. So yeah.
Yeah, you catch the key points. To the second questions, maybe I can address first. So you can see that in the WHO, they already published the guideline. The cognitions or the learning ability is really highly related to the noise. Like they already have the mechanical noise outside when the Professor Fu presentation. I cannot concentrate on Professor Fu's presentation there. Okay, but how to quantify the children cognition or the students' cognition is the other issues. Noise maybe you can use in some way like we use, like the cell phone or other ways to record. Okay, this is to answer your second questions. For the first question, it's very challenging because currently for everyone, the cell phones, the microphones is totally different. For a very expensive cell phone like an iPhone, right? It's very expensive. The cell phone is very good. Okay, so the accuracy of the recognition is good. For the quantify the sound pressure, that will really effective. Yeah, really effective. We do the in-house experiments for different cell phones. For the standardized sounds, they have a totally different result over some pressures. They will have some problems with that. But for currently, we don't have one better way to adjust the sound pressure. Of course, even for the line, we don't have that kind of application. But for the apps one, they have some apps. They can do some adjustment like this one. Okay, this one for the iOS, they have one I call this one is iOS. For the American NIOSH is like from the Labor and the Welfare Institutes. They have one app called what? I forget his name. His name. Okay, NIOSH some level meters here. Okay, this one can help you adjust, but you still have need to have a standardized sound meter at your hand to adjust. So it's really hard if you want to promote this kind of survey for everywhere. So you still have a challenge. For the other one, so-called for the Android platform called a noise capture, is developed by the European countries. Okay, so they're using 3 ways to calibrate the sounds. The first one is also by the sound meter. The other one is like they model in the number of traffic, number of cars along the world. So you only need to record the sound and see how many cars pass by you. So they have a sound relationship. This is the other proxy way to make adjustment. Okay, and the third way is that the other one have already calibrated one, like Shenwei already have one calibrated cell phone, and my phone calibrated with reference to his phone. Okay, so for the iOS, for Android part, they have 3 solutions for the apps. But because we're using the line, like currently they don't have this kind of application for us to calibrate the sound. But that is the key point. The key point. But it still have some limitation for current technology. Yeah, thank you.
Yeah, that's just a quick question. From a public health perspective, is the tolerance of noise adjustable? I mean, there was a recent article in Nature arguing that, for example, you grew up in Paris versus you grew up in New York is different. There's a difference in, for example, how you navigate, the world.
Yeah,
Because
yeah.
New York is a great structure. So I'm just wondering, for example, you grew up in the city, that the way you tolerate car noise is different from here.
Yeah, it's very good questions. But currently we don't collect this kind of information. But in our cross-sectional this survey, we found they correlated with the land use. So you can see for the people living in a mountain area, or in a forest area, or in a rural area, they will feel better acoustic comfort. Maybe personally, because we also found that their noise sensitivity maybe quite lower. So noise sensitivity is the other issue related to their personal traits, like a Big Five. They have some traits related to the personal noise sensitivity. So, but we don't know the reason why maybe they in their neighborhoods or their childhood they expose more or less. That we don't know. Maybe, but that's very good questions. But from our findings, we already find that the personal traits is highly correlated with that. Yeah, thank you.
Yeah, let's thank for Professor Zhang's presentation again. Thank you.
Thank you.
I'm just wondering, is the noise still loud or is it tolerable? I don't know, because here I think it's adjustable. I think I'm used to the noise, in the background noise. I think it's okay, right? Okay. Because now I know it could be very damaging to our health.
You might want to try to use as like mirror display. Is there that option? Yeah, mirror. Does that work? Okay, good. Good. Yep, good. Okay.
So our last speaker for this afternoon will be Professor Mu-Rong Zhou. He is a very new assistant research fellow in Research Center for Humanities and Social Science in Academia Sinica. So he has his PhD in communication at Stanford University. So his research fields are digital interaction, media psychology, artificial intelligence, and data science. So now let's welcome Professor Mu-Rong Zhou.
I just joined Academia Sinica last December, so by new, I mean really, really new. Before that, I was working on. So before joining Academia Sinica, I was working at Stanford Med School as a postdoc for several years, and the topic I'm presenting today is an ongoing project I'm still working on, even now back in Taiwan. So it's like my main project in collaboration with my previous institute. It's not like a paper-like research project per se yet. It's more like a architectural design of a system that would be a paper itself maybe, but enabling several other projects. There will be one personal research project based on this architecture, but this presentation today is more of discussing what I've been working on these days to enable some research using the kind of data we are working on together between Academia Sinica and Stanford University. Okay.
So to kind of like give you a heads up about what this system would be enabling us to do is to describe something like this. For example, adolescents food-related content exposure on smartphone screens. This is like the temporal distribution. So there are 20 adolescents here. Each row is an adolescent, so it's represented as a bar. And each column here you are seeing is 1 day. So it's a week of 20 adolescents. Collected, this data was collected in the United States. I selected only 1 week to use here for the visualization purpose. And the yellow bar here you're seeing are just the time when they have their smartphone screens on. And the green, bluish bars are the ones that have some kind of food-related content on their screen. Okay. And there are some very few small dots there, and those are the screens with food-related content that are branded. So we care about this kind of branded information because we want to work on a project I'm going to talk about later on to see like what kind of food and whether the food, beverage information adolescents are seeing are branded on their digital screens. Okay. And then this is another kind of like visualization of what's possible with this current system right now. By using embeddings extracted from screenshots, both from the image itself and the text we extract from the screenshots of digital screens. We could kind of like identify what we call screen type. So it's like a term we coined ourselves, and I'm going to explain it a little bit more later in the next slide. But basically, we collect sequences of digital screen records, and then we analyze the information on it. And then one of the basic way of doing that is like you extract embeddings from those, and then you want to kind of identify if there are prototypical types of screens, cluster of screens, based on the various different computationally extracted features you get from them. And then I'm just using a really small subset of data points here because compared to what we have right now, we have like 300 million screens, but I'm only using less than a million here to get a sense of like in this subsample of participants what kind of behavior they are engaged in. And then you can just project it into a reduced dimensions of the embedding vector and then see how are they clustered. So it's not a perfect visualization. You see, it's really hard to see the clusters because the UMAP 3D projection is just not perfect to kind of like help you really clearly understand the really high, very high dimensional space and the embeddings, how they're there. And you can see the small stars here, like the dark purple stars here. These are the food information that are on smartphone screens. And then right now, in this visualization, it's hard to see which of the clusters they are associated with. But if you use a table, it would be much easier. This is just a visualization. But by doing this, basically, the idea is that you can kind of know in what kind of on what kind of screens and when adolescents are engaged in what kind of behavior they are seeing this food content, and that could obviously result in some kind of hypothesis testing for some theories about whether media interaction would cause them to have different kind of dietary behaviors. Okay. And so I say I would want to discuss a little bit more about Screenom and the idea of screenomics. And so just a brief introduction about the kind of data we're working on now for this kind of project is that we collect screenshots of digital screens. Like the photo you're seeing here is the, oops, sorry. it's the first wave of data collection we did back in 2017 on laptops of Stanford undergrads, 30 Stanford undergrads. And the idea then was just to look at what people are looking at and thinking that, okay, nowadays no one really consumes media or as a whole anymore. Like they are just like watching, looking at different screens and different content, and it's just like very sporadic. It changes rapidly, and there are just like a lot of like idiosyncrasies in those behaviors. So we want to just like, instead of asking them why not we just track what they're seeing, and we kind of analyze it ourselves, and not asking them what they are using and what social media they are using. So maybe this is a way to go to actually understand the small mini doses of media consumption going forward. So that was the idea, and then we kind of draw a comparison of this kind of research to genomics. So it's also a kind of like structural data that have sequences, and those sequences could be used to analyze a lot of like different media experiences and behaviors. And then by seeing the variations and changes in those structures and identify small sequences of those behavior, you can kind of associate that with bigger behavioral or psychological constructs. So we kind of like compare it to genomics, and we often talk about screenome-wide association studies. Compared to like what you usually hear about, it's like genome-wide association studies. So we do this kind of things with the screenome data. And the original architecture looks like this, like this original computational system that we built to collect smartphone and laptop screenshots, and then send it to the cloud server, and then use like first generation computer vision and NLP tools to analyze them and save them in the database. And then we have like human annotators, a lot of them, to annotate them, or just simply, if you want to do something more qualitative, you just have a viewer to view lots of them and formulate your own research questions. And then we also built like many different tools to do this kind of research, which now when you look back, it's pretty cumbersome. We built search engines based on the text we extracted. It was like very interesting, a lot of fun to work on, but it's just like very difficult to use because the tool back then was just like not mature enough to deal with this size of the data that we have. And then we immediately faced a lot of problems with using this system to do research. So now we just call it like Screenomics 1.0. We still have this data, and we are connecting this data with the new system. Actually, we finished connecting them with the new system. And, but still, like back in the days, we still were able to use that system to do some research, media psychology. For example, in the graph on the left, it was like a model of the, it's a multi-level VAR model for the mechanism of media sequencing, like whether people would select different kinds of media based on their previous media experiences at seconds level. So this was based on the theory that was like really important in the field of media psychology. But before this study, every study in that literature deal with time scale at the level of maybe hours. But like based on this system we had, we could test this hypothesis at the time scale of seconds. So, and we still kind of like found evidence of whether consumption of negative information on screen could lead to selection of positive information on screen at the seconds time scale. And also based on this like original framework, we were able to kind of like compute estimates of carbon CO2 emission. of like a digital device use. And just based on very basic data using the framework, which is just the smartphone use characteristics and the GPS signals. You do that. Okay. I'm going a little bit too slow now. I'm going to go a little bit faster. So, and then we have the Screenomics 2.0 system, which was done in my first couple of years during the postdoc. It was like a computational, we call it assay. So we collected lots of different computer vision and AI models to extract as many useful features as possible to do lots of analysis of the screen database we have, Screenom database we have. And then we use that to generate some other, to estimate some other content measures, but very rough content measures to enable some research that is like less granular than what we could do now, but it's still kind of interesting. Like the left one, I'm just analyzing the production behavior on smartphone and see if there are rules based on these patterns. And eventually we found that production behavior on smartphones are occurring more often after contexts, so consumption screens that have similar textual features with production screens. But it's still insufficient. Like we work on this and we try to analyze a lot of different things and answer research questions. And oftentimes when we get responses from journal reviewers, it's just to actually match the theories and research questions that are in different fields. For me, it's more like media psychology. A lot of times you would need more granular understanding of the content. And recently, there's a lot of like reviews about digital trace data collection and social science or psychology methods, research based on this kind of data. And one of the challenges that people often mention is that you need new methods for extracting meaningful variables from the data stream, especially like the kind of data stream we have. You really need to kind of dive deep into it and get good estimate of the visual data, image data. And then we have many ongoing content-based projects. So the like two figures I showed you at the beginning was based on this project. It's for this project here. It's like examining the food content exposure of adolescent smartphone on adolescent smartphone screen. And we're trying to associate that with their actual dietary intakes and their dietary preferences. Okay. And there are some possible solutions for doing that based on because this field of computer vision is like developing every day at a very, very fast pace, and there are just many possible solutions to do that. And there are at least like 3 classes of solutions that we could now think of. Like you can do VLM-based open vocabulary content analysis. Like this YOLO world thing that I'm listing here is like pretty groundbreaking. It's really lightweight and it has like a frame per second, much faster than other models. But although it's open vocabulary, you still need to kind of like, I tested it myself. So for some specific content categories, it would not be that useful. You still need to kind of tune it in a way that it would match your research question needs. And there's also the high, like really high power, like very well pre-trained commercial large multi-model models, LLMs, GPT-4v, for example, and now the Cloud and Gemini. They have their own problems as well. One of the main problems is their cost. Okay. And the last class of solution I could think of is the open source LLMs. Okay, so this is the kind of solution I have right now, and I personally tested extensively. So like Lava, Llama Adapter, CogVLM, and the constraints me and my colleagues are having right now is because our data is confidential, right? So we need to use open source tools. Our IRB do not approve use of commercial tools on this kind of data because it contains a lot of pretty private and sensitive information on smartphone screens. And you have also limited time and labor, obviously, for generating like truth labels from human annotators, and especially when you have lots of content-related research questions. Those are the main constraints. Okay. So we have this architecture right now to do this based on open source large multi-model models. Okay, so I'll just talk about each component one by one. Okay. Okay, so from the screenums, so the sequential screenshots we collected from the participants, you get the image embeddings. And you use the image encoder, and there are many of them that you can choose from. But one of the most obvious choice right now, which is also the kind of the backbone of many modern state-of-the-art computer vision architecture is CLIP. Okay, this one is from OpenAI. Okay, but this is one is open source. And it's pretty revolutionary when they published the paper because the idea is actually very simple. You train two encoders at the same time to minimize the pairings that are correct, matching the text and image labels, okay? And you maximize the other ones. So then you get encoders, two encoders that could project their embeddings into one stem space to allow you to kind of like encode the text and find which of the image in this set of images are the closest to this textual concept. So that is a very revolutionary idea, and many of the CB architecture now just use this one, and I included this as our image encoder. And then you could also use CLIP as a data filter, right? So I say like you can use CLIP to kind of identify in a great number of screens, a subset of screens that are the closest to a visual concept. And for our use case, for the research question I showcased was the food-related concept. So you can use it to identify beverage labels, food-related content, that kind of thing, and you select a subsample of it for human labelers. So it saves you some time for labeling. Okay. And then we need OCR as well. So we need to extract text from the screen. Okay. So OCR stands for optical character recognition, which is a pretty much solved CB problem right now because of this technology here, like the Craft plus STR. So these are like two models work together. One is for identifying the region for extracting the text. And the second is for extracting actually the characters, okay? And there's a pretty complicated CRN architecture back behind that, but now people have bundled this model pretty well into packages, and you can test different kinds of them and see which one best suits your needs. But for me, I just use the original ones from the authors. So it's Craft plus SCR, that's the OCR engine. And then from the OCR text, you do text encoding. So still, there are lots of like different choices to do this, and you just need to experiment to see what gives you the best result eventually. But some popular choices here, like MiniLM and Distill Roberta. Okay. The reason why I'm choosing them is just because they're lightweight and we have lots of data points. And oftentimes, you are not sure whether this textual embedding, and especially the very unstructured text from smartphone screens, could be that useful. You just need the feature itself, but you don't know the feature, how useful it would be. So you need to have a fast solution first, and then gradually move into like better solutions and try to get better results. Okay. And Distill Roberta is like one very popular choice here for this kind of task. for many different reasons. One is for the speed, and the other is for the data that was used to train this transformer, which is like net language, net speaking, like lots of unstructured data when training this model as well. So it's like most likely would suit our needs for smartphone text. Okay. And then from there, we have users label some subset of screenshots. And for the content categories we care about, for the use case I just showed, was that, okay, I would need to identify whether there's food content on it, whether there's no food content on it, whether the food content has branding on it. We have like much more detailed human coding for that, but we use the kind of like simpler coding for the LLMs to kind of learn from it. And then in order for the LLMs to perform well, there are many things that you need to do. And there are several different open source LLMs that you could possibly choose from. It's still relatively new technology, so you need to kind of like choose from them based on several benchmarks. And Lava is the kind of like winning solution right now. There are 3 different kinds of paradigms for LLMs right now, and this belongs to one of them, and it's like kind of the champion right now for that specific paradigm. Okay, and this LLM, like lots of people are developing it to adapt it to their own needs. So if you look at their GitHub and how people are using their GitHub repo, and you can see that there's a lot of applications already for this model. Okay. And it has like pretty amazing capabilities compared to commercial solutions. It could do zero-shot OCR. It performs very well on several benchmarks compared to the commercial solutions. For example, GPT-4v, which is very, very powerful, but it does really well on some tasks compared to that. And it's relatively cheap to train and operate. So with A100 40G, you could like retrain itself. Retrain the model like for how many days? 8 days. Okay. Well, a GPU thing you train it in 1 day. Okay, for the smaller version of the Lava. Okay. And but for most of the users, like our lab, like although we have pretty good computing resources, it's still not enough. Okay, you still need to apply some techniques to train this kind of model. One such technique now is called parameter efficient fine-tuning, PEFT. Okay, LoRa, L-O-R-A. This is like one kind of like PEFT technique. The idea is very elegant and simple. So basically, in each layer of the model, you could kind of add 2 adapters. Actually, 1 adapter of like 2 matrices, and then you kind of reduce its rank. Okay, so you have like much less features to train. And actually, they found that by adding that prediction to the layer output of the original weights, actually it changes the behavior of the transformer to like a very desirable way. Okay, so it actually saves you a lot of time for tuning and a lot of memory for tuning that. Okay. And by using LoRa with Lava for this specific test, we were able to achieve an accuracy of 0.96 and a kappa agreement with human labelers of 0.85. So very well, okay. I would say like for the amount of data we have, it's already doing very well. And then you output this to like a machine learning classifier and then use a machine learning classifier, conventional one. Like for me, I just use a CatBoost, which is like very typical for this kind of like tabular data to kind of approximate the output of the LLM. Okay. The reason why I'm doing that is still because if you want to use the LLM itself to populate the levels over like millions of screenshots, it's still very costly. So this is just one additional step to kind of approximate that result. So this is why we're using the like fast solutions, easy solutions, but not using the not using Lava itself. We did an estimate of how much we would be spending on computing resources. If we use the LLM itself to generate these labels, it would be prohibitive because we are spending a lot of resources already on the storage itself. So it's not possible. So we just decided to go this route. Okay. Of course, like there are alternative routes that you can use in the future. Eventually, the cost of computing and the cost of operating these models would go down and down. And then Google or Microsoft would lower their costs if they're competing on this end. And then we're already seeing that the cost is like going down day by day. Like there are lots of ways to find discount and get cloud computing credits from many places these days. But still, once we have like sufficient resources or for our researchers to directly use LLMs, then we would just sort of remove the eventual like machine learning classifier and use Lava itself. Okay, and then you can use Lava in two ways to accelerate this whole architecture. One way is like you could use these models to generate synthetic data. So for example, there's like two screens here. Like these are just like very basic instructions for the models. Like this is DALL-E to generate similar data based on the data we have for additional content categories that we don't have yet. Okay. You can also have the LLMs like GPT-4v to generate pseudo labels based on your actual data. So this is not the actual data. This is something I just captured on my own smartphone. Okay, and I just asked GPT-4v to generate like a structural JSON output to identify any food-ready image or food-ready text on the screen, and it gives like perfect result. Okay, so these models, like commercially available ones, are very, very powerful. Okay, so they give you like almost perfect results for this kind of question. So an example prompt you can give it here. So it's called meta prompting. It's another kind of technique. So you basically have the model itself draft the prompt for you, and then use the prompt to ask the questions. Okay, and then you do it iteratively until you get the best prompt for your specific research question or a measurement problem. Okay, and then this is one of the prompts that I used to get this result. I used the same technique, right? I asked GPT-4v to draft me a prompt, and then give me a response of this image based on that prompt, and see if I'm satisfied with the output, and then fine-tune my prompt, engineer my prompt to get this result. So after you get the JSON output, you could give it back to Lava, okay? So the open source solutions to tune your model. And that would most likely solve most of the content measurement problems we have for the screenum data. So like a summary of the whole architecture is here. Like we have the smartphone screenshots. We want to identify content categories to study our research questions. And then we have different solutions. And nowadays, to kind of apply Lava to our measurements, to measure content categories for our data, we use this architecture and then output the labels to a machine learning classifier to eventually get pretty good results for the content classification problems. Okay, and I used up my time. Thanks. Yeah. Thank you.
Yeah, very fascinating talk. Again, so I think this is like very interesting. This is one of the talk in social science workshop. I see a lot of acronyms like Lava, LoRa, LLM, a lot of things at the social science workshop. It's very fascinating. But it also showcases a lot of challenges and opportunities, which we are going to discuss later today and tomorrow. I think you have a lot of experience to talk about. Okay, so we have probably 10 minutes for questions and remarks. Anyone to say something? Professor Sato.
I'm quite amazed to see the high-tech advancement of the model. But then my question is how to relate the result of the program and, for example, the health condition of the respondents or the feeling, positive feeling or negative feeling. So far you showed how the content of the smartphone screen can be categorized. But we need information on the respondents of the subjective variables and objective variables such as education, age, and so on. So how can you relate to the two main factors?
Okay. Yeah, thank you for the question, Professor. So we, for this data set, I'm showing here the adolescent data set. For the 154 participants we have here in this data set, we have EMA studies along with it, come with it. So we collected pre-study questionnaire, post-study questionnaire, and fortnightly questionnaires. So every 2 weeks we ask them about their psychological well-being, their emotion, their like lots of like health-related problems, and we actually send researchers to do like biological, physical measures like their weight, there are lots of things. It's like an additional data collection program on top of like a very big data collection program called WISE in the United States. And that WISE program that they have actually researchers going to people's home to estimate their like physiological measures. So we do have that data. It's just the problem itself. It's not about the other part of the data today. It's more like for us, like we know we have those physiological data, but how can we kind of estimate or like associate those patterns with passively collected smartphone data collected in real time? So that's the goal. So eventually we hope that we won't need to collect that much of physiological data anymore. We just need the smartphone data in some ways to understand those behavioral patterns. Or we can, so the NIH proposal we have for this project argues that we would be able to kind of say that, okay, because adolescents are looking at this different kind of food information from these brands, and these are like unhealthy kind of food. So these are somehow associated with their actual dietary preferences or their food choices or their actual physiological measures of their health. Okay, so that's the eventual goal. But we're still not there yet. We're still working on the kind of computational part of it. So still a little bit far away from the question.
Actually, the data you get through the system is continuous, so the density of the data set is very rich. Yeah. On the other hand, if you ask questions every day or every 2 days, so the data set is much sparser than the data you collected. So one possibility would have the respondent wear smartwatch or something to get the data simultaneously, so that you can get a very rich data set to see the exact temperature change in the screen and the mood or the heartbeat or something like that.
Right. Yeah, that's kind of in the plan, but not yet. Yeah, we want to combine those other measures as well. Like we're actively developing the data collection app we use. So now it collects even more data. But for the like other sensors based on the smartwatch or other sensors like based on other devices that you can wear on your like body or even wearing your clothes. Okay. We have ideas about that, but not yet plans about it because it's going to be even more challenging. So, yeah, but we have colleagues interested in that. We have like a colleague in my previous department also analyzing like sound and personality, ambient sound, how social they are, and like their personality traits. So yeah, this like people are trying different ways of measuring behavior and psychological state.
Okay, thank you.
Thank you for sharing. I want to ask two questions about the models that you adopted here. Have you ever considered about there might be some baseline, even though that you present there's some SOTA model, but I'm wondering that what would be the baseline for you to decide which model is better, and also some base model, I mean, from the original model that is not for analyzing the images, but it's for language processing. So, I mean, how did you really decide that which model will be better for your data set or for your study context? That is my first question. Is there a baseline? The second question is that I consider about the time that you process the data is really a lot of time. So have you ever also considered that you to just replace your machine to change another hardware or to collaborate with some AI center or high-speed computing center so that you could run the model much faster?
Okay. So for the first question, I guess the answer would be multifaceted. So when choosing model, there are different ways to think about it. Okay, so there are ways that people develop their architectural, and you refer to their architecture. Okay, and I briefly mentioned that there are different paradigms now for the LMMs. So there are basically three grand themes of the architecture right now, and then you choose from one of it. And when you choose Lava, it kind of automatically tells you which of the embeddings you should select because it was trained or it was built based on those embeddings. So naturally, those embeddings would be the most suitable for that model. Okay, and the other thing is also based on the time and cost constraints. Okay, there are much more complicated models with that generates bigger embeddings, supposedly that would cover more details in the semantic space of those images or text. But you still need to kind of get the ones that's best for your needs. You might not need that big of a model, okay? So that's another thing to think about. And for the second problem, my experience working at Stanford was that we have pretty good computing resources, but that's only compared to the other academic researchers, okay? Compared to the industry, it's nothing. Okay, so it really depends on whether they want to collaborate with you in those cases. But our experience was that they were pretty generous in most cases. To our project, the first several years, 5 years or so, all our research credits from Google Cloud was provided by Google Cloud for free. Yeah, so we were able to just freely use whatever number of GPUs we want to have. So that was a good time, but now we don't have that anymore. But yeah, I guess this is a major issue right now for most researchers in applying these models to their research these days, especially for us, we are the social science scholars applying this technology. We don't develop the model ourselves. We kind of change it, modify it in certain ways, but we don't have that need. There are more details in this. To train LMMs, the PEFT I mentioned is actually a very thin layer on top of it. But if you want to fully retrain the model, it would take a lot of resources, and that's not possible, at least for our kind of research resource right now. And we actually don't need it. We don't need to kind of do the reinforcement learning with human ourselves. We don't need to do the full pre-training ourselves. We just need to do the PEFT ourselves to get sufficiently good results for our research problems. Yeah.
Maybe one quick question. Do you have Professor Cho? Yeah.
Very interesting study. Because currently for the generated AI content platform, most of them use from the text to text, such as ChatGPT, or text to video like Sora, okay? So you reverse use the clip, that kind of a framework to generate the image from the, generate content, AI content from image to text. So I'm curious about who will be your target audience. How come? Because your research content about the food actually has been, particularly the food commercial, actually has become a very big trigger for the famous weight reducing drug called Ozempic. This is a multi-billion drug developed by a Danish pharmaceutical firms called Novo Nordisk. So actually, I think you have used a very standard way of generate AI. Generate the AI content platform, and fully appreciate. And I think they will be a very good commercial implications. I would like to ask you, in your mind, who will be your target audience after you publish your final outcome? Thank you.
Yeah. Okay. So the figure I showed in the first place was just trying to answer that research question our NIH project has about associating food content exposure on digital screens with their actual physical health measures. Okay, and we didn't really think of any commercial use beyond that at all. It's more of against commercial use of like food information in an improper way. So yeah, but there's potential for that, of course. Like if you could use this system in a way that's like very efficient, like one day maybe we don't need LMMs for this kind of task anymore. We just need the YOLO world, which is like a VLM itself, not this large models, but the much smaller model. You could like have a FPS of like 53 images with like just one A100 GPU. So if that's good enough for for this kind of research question and for this measurement, then there could be real-time detection or real-time identification of food content on screen. And that could kind of like give guidelines or like give strategies about like advertisement, like how people should use ads or commercial to kind of advance their commercial goals, for example. Okay, so you would be able to know like at which time point, if you give people this kind of information, it would most likely trigger like a behavioral response to buy that product or something. There's the potential for that, but I don't think the technology is there yet. Maybe it's there yet. Maybe people at OpenAI already done it. I don't know, but yeah, but I think it's not yet there yet. Yeah.
Okay. I hope like next time if we have this kind of workshop next year or the following year, you can present Screenomic 4.0 or 5.0 to our audience. Okay, due to the limit of time, I think we just thank Professor Zhuo's presentation again. Thank you.
Thanks.
So I think we will have a 15 minutes break, and after the break, we will come back to here for a forum for a discussion of the challenge of computational social science. So let's come back here at 5 p.m. sharp. Thank you.
I know that everyone should feel tired. At least I am. I do. But still, still have more in-depth discussion for about 30 minutes or so before we go for dinner. And I summarized some questions that come up in the previous presentation. If I miss them, but feel free to come up with more. For example, I believe that this morning or this afternoon we talk about how can we communicate with computer scientists, right? Because that's sort of like the technical support we could borrow from in the future, or any other kind of technical oriented people. Second, how do we recruit students? Okay, this is a very important job. Okay, to continue the endeavor of CSS. And for example, and remember in the afternoon or some session we talked about the data, okay, And when we have the data, how do we know that is useful? For example, take my personal example. I have one computer science friend said he has access to very private bank data. Okay, that's a very sensitive issue, but of course anonymized. And then she said, "Why don't I give you the data, but you try to come up with some research project?" I said, "How do I know? What kind of question I'm going to ask?" So this is a typical the way that we communicate or collaborate with computer science people who have the data but don't have the question. But on the other hand, we have question, no data. So that is something we can discuss further. And how do we collect the data in a panelist way? Okay, now when I say panelist, not just to subject, but also to research as well. I believe that Da-Qian just brought up a very good example of citizen science. Okay, we recruit citizens, lay people to collect the data for us. That's a good way to think about. Finally, in my talk, we talk about, some people raise the possibility about field experiment. How do we do that? Okay, that's also a question we can think about. Finally, I think Professor Sato's session, there's a lot of discussion about theory. And one challenge that I'm facing right now is that, especially for sociology or any other social science, is that do we still need a theory? Okay. Because if the data or the machine learning can predict quite well, who would need a theory to tell the underlying story? That's a very practical challenge we may face in the future. And finally, in Jerome's study, and we know that is a complicated choices machine learning. You just showed a good example. I choose that one, assemble them together. But for social science, to me, that doing machine learning is like a grocery shopping. I like that one, I pick one and assemble one and to see how it works. But what's the strategy? What's the arts of doing that? So there are many other kind of open questions that we can talk about, but feel free to raise them. So the next 25 minutes or so is everyone's, okay? Yeah.
I think two questions are related to each other. That is, how do we communicate with computer scientists, and do we need theory anymore in the era of CSS? So if we propose, the sociologists propose interesting research questions, to be exact, research questions which are interesting to computer scientists, then they and the sociologists can collaborate with each other. So we need a good theory to create interesting research questions to attract more computer scientists. So the motivation of my talk this morning is this. So we need a good theory and derive good research questions from the theory to attract computer scientists or computational social scientists.
I start with the last two challenges. Actually, I'm quite excited and also learn a lot from just today's sharing. Okay, I think we say the best machine learning model, that actually, like ChatGPT or among others, they actually use deep learning. However, we use deep learning versus machine learning, that actually there's an issue about the computing power and energy saving. Professor Guo Zhongjie Yuanshi, actually he mentioned a lot about the green learning. Okay, so actually we need to talk. We need to address the issue of whether we can choose a model, regardless whether it's a machine learning based or like a deep learning based. Actually, can be more green. Is a greener in terms of power consumption. Okay. And also, I think that for we say that do we need a theory? Personally, I think for social science we especially need theory. How come? I have learned a lot from the computer science or like a EE about their findings. But if when I would like to apply to the social science issue, particularly in my field, like a strategy or international business, I found that it's very hard to convince my colleagues about whether it's just a giggle, garbage in, garbage out, or it has a theoretically grounded. For example, I think the question I just communicated with Professor Zhang regarding like the Professor Thomas Schilling's landmark book called Strategy of Conflicts. Okay, actually, I see it applied the game theory into the side or like the neighbor finding decision. Okay, but gradually, I think that today I learned from you. You actually provide a kind of very convincing the network experiment, and gradually, how can we develop a theory that can accommodate like a network with the finding from the network experimentation that you presented. So maybe we do not have the final or like the unified theory, but we probably have a middle ground theory. They can tell a better story based on such a diverse quantitative analysis approach, and also we may be much easier to communicate with colleagues even in the same discipline. Okay, so this is my my two little feedback on the question that you raised here, you put here. Thank you.
Yeah, so I actually have a question about theories. What the theory means depends on your field, I think. And most papers have research questions. And research questions are like hypothesis testing. Is this hypothesis true or not? But the hypothesis is like a theory. What is the difference between the hypothesis and the theory?
Can I try? I mean, normally people think the difference is that once you get to a hypothesis, you already have some evidence to actually say it's true, whereas a theory can exist with just a theory. I could have a theory about things that I can't collect any data on. The normal, if you look at some of the philosophy of science and things like this, they will make this distinction between something which is a theory, something which is a hypothesis, and then so it's really when it's got to a testable stage. And I think that's one of the important things about the difficulties with social theory is many computer scientists or scientists would say, I don't see that as a theory because I can't see what I can test. And I think, we've really got to actually say that when we call something a theory, it really is a theory. There's something in there that means I know I could go and test whether it's true or not, or I could predict something with it. And I know that's not what a lot of social theorists would say is a social theory. But I think in terms of computational social science, then that's exactly the kind of thing we actually need. And we need more of it. I remember once I saw a talk, and people had taken some theories in sociology and then put them through to mathematical theorem provers. And what they actually found out was that none of them held, they're all logically wrong. There was no logical consistency in them at all. I know that's an extreme example. But I think about communicating with computer scientists, I don't think that's a particular issue. You've got to find them. But a lot of computer scientists work in areas such as human-computer interaction, and they're already very well aware of the social sciences and are happy to talk to them. We've just got to get that common language, and I think that's the bit that's difficult. People that have changed disciplines, have been very interdisciplinary, can see this all the time, that one group says this, the other group says something, they're using a completely different language, completely different philosophy, and we've got to somehow find means by which we can find the people that are, in essence, the computer-orientated social scientists to meet with the sociologically orientated computer scientists. I guess it's finding them, but I think when you do find them, that communication is not that difficult.
The other issue, the other day that our president, the academic senior, came to meeting with us, I raised the question that the upper level should take care of the publication outlets. That's the key to interdisciplinary research. For example, you work with a computer scientist, and they're going to ask, where are you going to publish? In social science journals? In IEEE journals? different formats, different styles. That's the key. If I publish in IEEE, I talk to my colleagues. I mean, in my 10-year review, I say, hey, I publish in computer science. I say, that's a conference journal. That's a conference paper. You know, in computer science, conference paper is actually the formal journal. It takes a lot of time to convince colleagues that this is serious stuff, not really like the common sense of conference paper we're talking about. So really a lot of things. Yeah, please.
Yeah, so I mean, I think I can speak to this, both the topics that have been discussed so far. One, the how to speak to computer scientists, and this question of a theory. And building off of what I was discussing with Professor Chiang over lunch, is that often computer scientists and social scientists have different goals for why they want to do a project, why they want to do some research. And so Matt Selganik refers to that as the difference. I mean, in like one has a predilection for prediction, while the other has a predilection for explanation. Social scientists like to explain things, and computer scientists like to predict things. And there was a recent paper, not very recent anymore, by Duncan Watts and some others, where they showed how, you know, if you're really serious about computational social science being a substantive field, then how theory must also include a kind of predictive validity, and that explanation and prediction are basically two sides of the same coin. I think that's the name of the paper. I forget the exact title, but something about if you have a theory, then it's not just enough to explain why something works, but to be able to predict, when something will happen. And there was a fair bit of pushback from social scientists, I feel, because there is this, I think social scientists in general tend to be a bit skeptical of overarching grand theories. They are more interested in special cases of, if something has worked in this context, it may not work in the other contexts. And so maybe we don't want a theory that is overarching. I think there's a bit of a difference there in how we think. So I think, I think that, with more and more collaboration between these fields, the gaps are reducing, but there still seems to be enough people on both sides who are kind of interested in the traditional goals of their own disciplines. I think that can be a problem, and that can translate into more like differences in what kind of journals you want to target, whether you want to target journals or conferences. But I think fundamentally there is this kind of apprehension about why are we doing what we are doing. And I think there is a fundamental difference there that is being bridged, but I think that needs to be bridged even more. Yeah.
Just one quick comment on that paper, of course, in terms of the Duncan Watts paper that was published in Nature.
Yeah.
And I think every computer scientist would actually say, yes, that's a very good place to publish. In fact, I think everybody on the planet would say it's a good place to publish.
Hi, I think I might be able to provide a sample about, which I think the CSS or the computer scientists also working with the theories and working with the sociologists, is that the fairness issues in training the machine learning algorithms. So in the United States context, there are many discussions in the computer science talking about how to address the bias, the racial bias, for example, in the AI or machine learning algorithms. And I found that they almost cite sociologist papers from Deepak Pages about how to use the field experiment to identify the racial discriminations when a person is trying to find a job. So they're trying to send do an experiment and send a resume and say, okay, this person is a white and this person is a black. And so they found a racial discrimination. And I found that the computer scientists always cite this paper when they talk about fairness in training the machine learning algorithms. But I think the difference between the computer science and sociologists, for example, so social scientists in general, is that the computer scientist is very specific about operationalize the concept in their in their studies. So, for example, they figure out there are 21 definition of fairness and discriminations in evaluating a machine learning algorithms. So I think there's a gap because sometimes the social scientists will make the concepts a bit vague or a bit open to different interpretation, but computer scientists are much more focused on a very specific definitions. So, but I think here might be also a good opportunities for computational social scientists, because when we do this kind of work, we usually also want to have a very clear definition of a concept we try to operate in our empirical study. So I think that might be a good bridge between these social scientists and computer scientists in working together to address some most important social issues. So just some experience sharing. Thank you.
Yeah, I totally agree. Used to talk to a famous computer science in Taiwan, and she shared a lot about the troubles about AI. And back to the ethnicity issues, I say, that's your field, right? You're a social scientist, that's your problem, not our problem, right? So that's sort of like the area just consistent with Professor Avery saying, human-computer interaction, that's exactly the field that I believe that computer science and social science can work together. Yeah, they realize that. That's an issue we have to deal with. Yeah, yeah, Professor.
The team of sociologists have worked with two groups of computer scientists. The first groups are from the Institute of Information Science here at Academia Sinica, and the other group is from the University of California, at Davis. And the patterns were very different. With the first group, those computer scientists help us collect Facebook contact records. And when we went out to collect representative sample of adults in Taiwan, we asked those computer scientists to design the platform, to design all the tools that we need to ask those respondents to agree for us to retrieve all the contact records from their accounts. And that was wonderful. We could not do that without their help at all. And the second group was quite the opposite. Professor Ma, the professor at UC Davis, is a very well-known computer scientist at network visualization. So after we collected data with contact diaries, he came to our presentation and he learned about the pattern, about the structure of our data, the diary data. And he then came up with the idea, the design of the contact trees. So he asked his postdoc to design the contact tree, and we wrote the paper together. So these are two very different patterns. We can communicate, we can collaborate with them in a very different ways.
I totally echo your opinion. Also, I'm wondering if this is because of cultural difference in the UK. You said, you too said it seems to express some successful experiences, probably in UK and in Japan. And here, probably Professor Mukherjee, we talk about that over lunch, that in Taiwan, probably in India, right? There's a huge division between humanities and engineering. And when sometimes we contact computer science, they say they just provide technical support. They don't want to get involved. And even though we motivated so much, this is an interesting sociological or humanity question, they don't seem to care. I believe it's really rooted in the very, the foundation of education in Taiwan, probably in India, but probably not in UK or Japan, I'm not sure. This is something we work very, very hard. And also remember one time when I was still working in the US, again, I agree, even similarly in the US, I contacted a professor and said, can I hire you a graduate student, computer scientist? Can I hire you a graduate student to help me design this online experience? He said, okay, go ahead. But don't treat him as an engineer or programmer. Involve him in your project. That's totally new. This is totally mentality that I learned in Taiwan. So that's really cultural differences. Yeah.
I should add that Professor Ma from the UC Davis was exceptional. He's an exceptional case because he often traveled to East Asia, to Japan, South Korea, Shanghai, Beijing, Taiwan, to look for a very unusual data set, because it has been used to all the data retrieved from the computer, from the internet. So he has been looking for any kind of opportunities to collaborate with social scientists. So his case is exceptional. Yeah, different, very different.
Data is the other issue. I mean, this could be advantages or disadvantages. Yeah, that's an interesting. For example, WeChat. That's totally. I know a lot of people are so interested in that because that represents what's going on in China. Yeah, Joey.
Sorry, having a serious jet lag here, so if anything that doesn't make sense, please bother with me. So I think one of the things I've been struggling with and thinking about over here is all these questions relate to one thing, which is how do we evaluate computational social science as opposed to like a regular, for example, sociological article or let's say a computer science article. And one of the ways that I tend to kind of think about it is what do we think is bad computational social sciences? I've seen quite a few talks where there's fancy data, big data, and fancy methods. But then the question boils down to, if we could just use survey data to answer exactly the same thing, why do we bother to go through using so much computational resources and collect like social media data with these very fine-tuned traces and then use complicated multi-level modeling to do something where we could just ask people? For example, let's say we want to think about whether social media use is related to the mental health of adolescents. For example, I'm just randomly making things up. If we could just use survey data to find the relationships and then collect the demographic data, then why do we need digital data where we track people's like social media habits? So is there a niche in that? I think that's an open question, where we use a different data set to examine the same thing. Is it for triangulation purposes, or is it just a fancy fad that we seem to have more statistical power to do these kind of things? I'm still not sure. Yeah.
I mean, I can quickly, a quick response would be to kind of check if what we know, all these, what we have, the wisdom that we have gathered, I won't say wisdom, that's doing it too much, I think. The knowledge that we have gathered over decades of survey research, often when you look at behavioral trace data, you kind of feel that, okay, all of that we have learned is actually not happening, right? So it's maybe, I think the reason people start to do it is because of triangulation, that indeed what people have been reporting, because there's a lot of problems with, survey data in that people falsely state things, people don't remember, right? So I think there is an initial kind of reason for trying to see if the same theories hold when trace data is analyzed, for instance. But I think the larger question is beyond that. Does all the bells and whistles of computational methods, do they offer any additional meaningful insight? I think that is the more fundamental question, right? Yeah. Right. Are we just doing this because we can do this, or are we doing this, because it advances our understanding of social phenomena? Yeah. So, yeah.
Yeah. Quick. Just kind of follow up on Dr. Mukherjee's thing. So, this goes back to the old question of sociology, or maybe the social sciences in general. Often sociological research has been criticized of one of the two things. Either, that's intuitive, or that's impossible. So once the findings are there, people are like, we already know that. So I think perhaps the same standards may apply to computational research. We still try to figure out what's new over here beyond we used a very complicated procedure to examine something that we already knew for decades.
Yeah, I think the topic is fascinating because a lot of challenges are personal to me. Because I think all of these are difficult questions. Because my background is from mathematics, I got a PhD in mathematics, and I switched to social science. So I think a lot of things are different in an opposite way. But I also think the biggest issue here is the level of abstraction. Because from a mathematician or a physicist point of view, like we care about a lot of social systems as well. Only if you can abstract it to a certain level. Like we care about human dynamics, we care about dynamical systems, complex systems. But a lot of social phenomena are like the complexity is super beyond our control. So if there are some people can make an abstraction to a certain level, like simple disease propagation, simple cooperation game, like Prisoner's Dilemma, then I think applied mathematicians and physicists or computer scientists, they are very willing to build theory behind it. Because you can see there are a lot of journals in mathematics, computer science, and physicists. They care about the same thing, like your Professor Zhang's presentation. Cooperation, these are very common topic in statistical physics. There are a lot of people in that field. But my observation is when I look into a physicist journal, they only cite physicists' work. When I look sociology journal, they only cite the sociologist's work. This is like I can see a still very big gap between it. But another thing is like if I try to apply this like agent-based simulation, like Professor Sato's talk in the morning today, and a lot of challenge from reviewers is too fake. It's unrealistic. Like you need to justify why you build this kind of simulation without using real-world data. So this is a thing like we need to overcome it. And I think another insight or idea I've come from Professor Han's talk today, I think like interdisciplinary things should be encouraged. Collaboration should be encouraged. Like if we use Professor Han's insight or the thing she found, like this could increase the like prestige or people's creativity or even student salary in the future. Maybe we can recruit more. But I have one good thing for opportunity for this thing, I think. I think one, there is a very easy fix or a solution, like the second one. How do we recruit students to do CSS? I think to my observation is just go to talk to them or teach or have a talk. I think students will, they really like to think differently or because they have a lot of opportunities already. If we can formulate this thing to a thing they can understand and maybe build a model. I think like I teach in physics department, they are willing to do this kind of modeling too. I think this should be workable, but a lot of things are still a lot of challenges. It's just some personal like point of views or sharing. Thank you.
I think one of the things we have to remember is how young computational social science is as if it would even call it a discipline. Now, those of you there this morning saw me when I started doing social network analysis, 20 papers in existence. And people would say to me, various other academic friends, why are you doing this? You'll never get a job. This subject is going nowhere. This is a non-subject. And I remember about 20 years later talking to somebody who actually said he started doing social networks, decided it wasn't going anywhere, it wasn't a discipline, and therefore changed to do something else. And he said, I look like the stupid one, you look like the wise one. So we do have to remember that. A few years ago, I was talking to people early on in agent-based modeling. And they said, our topic is really difficult. Nobody takes it seriously, unlike social network analysis, which is now mainstream. And I said, but I remember when it wasn't mainstream, and agent-based modeling will become mainstream, and computational social science will become mainstream. I mean, at the moment, I don't think we can actually probably frame the sort of questions that will make it famous we haven't got yet. We haven't got the right kind of data yet. And those will all fit together over time as long as we engage enough people into the whole discipline. And I think it's that engagement that's important. So I agree, it's talking to students. It's another thing to get computer scientists and sociologists, the best way you'll ever get those to work together is you co-locate them together so that they talk to each other. And they talk to each other very casually, not just, oh, I've got this project, but they actually say, oh, let's go to dinner, let's go. You know. But that's actually how you do it, and that's how most interdisciplinary things have occurred. And the other example I will give, I remember when I was very young, biologists didn't do mathematics, and now mathematical biology is a big subject. So all these things work in the long term as long as we work at making them work.
We should have more dinners and reception. That's actually Chinese, also probably Japanese tradition. I think that's a good idea. Yeah, Siqi.
So just to speak to my own experiences with the second question students. So our PhD students and some of the MPhil students, many come from mainland China. And I observe that this STEM originated students are very interested in pursuing CSS. Unlike maybe in the other parts of the world. But I think there are some problems in this phenomenon. The first one is there a selectivity of the STEM students into CSS? Meaning that maybe those are people who cannot stand the pressure of pursuing STEM or cannot stand the competition of pursuing STEM, so that they come to a softer major that is called CSS. This would affect their quality. And the second is that most of the students, PhD level, that I interviewed for our CSS program, so we have a PhD program in CSS, and when I interview them, they seem to follow the most obvious and popular topic, and in the current moment is the social media. But in China, the social media data's quality is very bad because it's censored. So I don't know how this will lead to their dissertation topic and dissertation results. So I think there needs to be more support or more advertisement to the STEM majors about the breadth of CSS in addition to social media, which is the most popular and obvious topic choice. So given this, I started to communicate with these candidates who are applying to our program. And I think the trainability of them is a little bit, I don't know what to say, because it is easy for them to do all the work related to the analysis, but it will make them into good RA, but not independent scholar. So how can we help this group of people to be more than an RA? Because that sounds like exploiting them in a way that you just need their technical skills, but you don't actually care about training them into some good thinker. So that's my concern. Thanks.
I totally echo, because if you look at most CSS publication, this is like a team with a high division of labor. But that really is at us, our sociological tradition, because we encourage people to be independent. First author, sole author paper, but how can you handle everything by yourself without, acknowledging the contributing of others? That's totally really a problem. Yeah, Charlie.
It's kind of following the thread by Professor Han and Professor Jiang. I think going back to Dr. Everett's lecture in the morning, I think this idea of structural holes is especially critical in this field. As computational social sciences, we are not computer scientists. I mean, maybe a small subset of us are able to achieve that, able of technical expertise, but for people like me and a lot of people, well, you ask me to write code, I'm never going to be writing code as efficient as computer scientists who work at Microsoft or Amazon, for example. But then how do we occupy a structural hole with that we know enough about the latest developments of technology so that we can keep up with those trends? But on the other hand, we also know enough about sociological or social theory so that we can connect that part. And I think that goes back to one of the questions about often we are presented with data, myself included, where people just hand the data and like, what's interesting about this? And there's the creativity. It seems that computational social science is a technical field, but there's an art to it, which is from the humanities and the social sciences. And I think that's perhaps one of the ways that we should advertise that to students.
Agree. I mean, one time I thought to myself, should I call it computational social science? If we go into too technically, should I call it social computational science? That's actually
I mean, there is something called social computing that is being taught in computer science schools these days. Yeah.
Getting back to your comment on the relationship between computational social science and the conventional social surveys, I've been also thinking about the relationship between them. And Duncan Watts once said that the social scientists got a telescope named computational social science, which means using a telescope would give us new findings, which we cannot do with my eyes, right? So, for example, Martin showed the networks of blogs of the Republicans and Democrats. We can know that using the conventional social survey because we can get the result of the polarization of political scenes in the United States. But getting back to your presentation, the positive correlation between the interdisciplinarity, of course, and economic yield returns could not be found by using the conventional social survey. So you use a telescope to find the new patterns. So then we need a theory to explain why there's a positive correlation between the interdisciplinarity of the courses and economic returns. So this kind of interaction between computational social science and sociology or social science in general would be a good direction to make a good collaboration between the two camps.
Have a dialogue.
All right, over dinner or over wine.
Yeah, thank you. Wenqing Wu from Academia Sinica. So I like the metaphor of telescope. Yeah, especially if we say that social scientists or political scientists can use a theoretical telescope to look into the data and have some new finding. But I think most of the time I would like to do that kind of magnificent task. But I realize that most of the time I use a very lousy telescope to look into the data. And then sometimes the reviewer will just say, oh, you need to polish your tool, which is your telescope. Yeah. So I think sometimes, I fall into this kind of dilemma. So whether it's my tool that is so poor that I cannot find new data, or it's I don't know, the theoretical training that I am not good at and I cannot find a new perspective. I mean, here there are two kinds of telescope. One is about the tool itself. I mean, whether we are using the very advanced technique to collect a lot of data. So I think that's one kind of telescope. And the other is about theoretical perspective. I think that might be what you meant by a telescope, because that's a theoretical perspective into the data we have. But I don't know, because most of the time I don't think I have a very normal theoretical perspective into the new data, and I'm not sure how to develop that. So if some of you can have some insight on this issue, then that would be helpful. Yeah, thank you.
I think there are interactions between the two telescopes. So in my case, I begin with a theory and derive a hypothesis and to check the empirical validity using the big data or the conventional social survey. Then the most interesting thing is that I find a pattern which could not be predicted by the theory. Then we need to think about a new theory to explain the pattern. Then after getting a new theory, I do another research using big data or social survey to check the empirical validity of the theory. So the data collected by the anything, big data or conventional social survey and the theory should be interacted with each other to advance our knowledge in social science.
Yeah, I just wanted to chime in here because this is a topic that that's often discussed in my previous lab, because we got so many reviews about why you are doing things like what you are doing and why do we need this, and what you're doing is atheoretical or something. And I guess one of the most common responses from my colleagues about why we are kind of inventing a kind of a new telescope we call it microscope actually, because we're looking at more detailed things, right? And is that oftentimes for media scholars, like media researchers these days, we reach to our theories too quickly. We reach to our theory before we have sufficient inductive reasoning about what's actually happening out there. So a lot of theories, especially in the field of media psychology, talks about things that don't happen anymore, okay? People are just not using their devices or looking at media or get exposed to media in a way those old theories are predicting, are explaining. It's not a phenomenon, maybe it's correct, but it's not a phenomenon, or the phenomena it's explaining is not important with modern days kind of technology use. So I guess a very important thing to remember here while doing this is that you need to kind of get sufficient level of understanding of what you are trying to research and the kind of behavior you are trying to look at, and the sufficient data points for inductive reasoning before you come up with a theory. The theory is the eventual goal, but don't think about theories that fast, or don't try to apply those theories that fast. It needs to be a little bit more iterative and focus. We need to focus a little bit more on the iterative, the inductive part of the kind of procedure, the process of the making good science. That's the kind of response we usually have. Yeah. Yeah.
Okay, good morning. So it's about the time to start our morning session. So our distinguished participants, it's my pleasure to chair this morning session. My name is Dachin Jam from Research Center for Humanity and Social Science at Sinica. So I know that it is very difficult for everyone to get up early on this sunny Sunday. Okay, so I really appreciate your participation. So in the morning sessions, we will have three excellent speakers to share their recent work. First speaker is Dr. Xuanwei Li from Institute of Sociology, Academia Sinica. Dr. Li has a very special background as Professor Everett. So his background in PhD training is mathematics. Okay, Dr. Li is currently also an assistant research assistant in Academia Sinica and also jointly appointed assistant professor of Department of Physics and also the assistant professor at the Political Science and the Department of Sociology at the National Taiwan University. His research interests focus on complex systems, computational sociology, game theory, and machine learning. Okay. Today he will present a topic entitled Health Communication on Social Media at the Early Stage of the Pandemic, examining health professionals' COVID-related traits. Oh, let's welcome Dr. Li's presentation.
Good morning, everyone, and I want to thank Da-Qian's introduction. And today I'm going to talk about a recent publication we have, and this is titled Health Communication on Social Media at the Early Stage of the Pandemic, examining health professionals' COVID-19 related tweets. So you can see this is a Twitter research, and this is epidemic and opinion dynamics. Okay, so this is a joint collaborative work, and we have like 3 authors. The first author, I don't know if he is online or not, but he's Yao-Tai Li, and from New South Wales, University of New South Wales in Australia, and he's a sociologist. And the second author is Manning Chen. She's right there. She like wave your hand. Yeah, she's right there. So she's my research assistant, my student from NTU, and she joined our lab from her freshman. So, and she's going to UW this fall for a PhD study in sociology. So she did all the analytical work, the quantitative analytical work. So I'm glad she's here to answer the questions as well. So I'm the third author. So previously I done some opinion dynamics and disease propagation, but most of my work is in agent-based modeling and mathematical modeling. So this is the first attempt, we tried to implement the methods in a real social network in social media. So as I said, this is a recent publication in Social Science and Medicine. It was just published less than 2 weeks ago. Okay, so I want to talk about opinion dynamics and pandemic in the environment of online social media. So we have social media for 20 or 30 years, so this is nothing quite new. But we also have pandemics in human history. But I think this is the first time we have a pandemic, a global pandemic, but also we have online social media. So people are very uncertain or quite not sure about this pandemic, the trend, it will happen and how damaged it will be. So they just talk about a lot of different things on the network and social media first. So what we want to think about is we care about health communication, and we focus our target to be health professional during the pandemic, especially the first early period of the pandemic. And we know the infodemic is, people use infodemic, this term, to describe the overabundance for information. And some are accurate and some are inaccurate, or some are even fake or manipulated. So this is something people are not certain about and people are worried about, at least at first. So we want to study the role health professionals are in and doing this kind of opinion dynamics. So we focus on health professionals, their opinion and their comments and their posts, and they are expected to provide timely and accurate information. And people think that they have the responsibility to deliver correct and verified facts. And some studies show that these health professionals, some people think that they are not neutral encyclopedias. They also have their personal sentiments, could be positive or negative comparing to other citizens. They are not neutral. Some of them say that neutral, it is because these health professionals could use some tactic too, like scare tactic to make people to activate or to be more careful. And some study also show that negative sentiments are dominant on the internet. And especially during the pandemic, COVID-19 related tweets are negative sentiments are dominant. And this can cause bias, hostility, and discrimination as well. So negative sentiments could be dominant, and health professionals, they are not neutral. But these could be possibly explained that these health professionals could use like negative sentiments or this kind of strategies to facilitate digital activism, like Professor Xiao's research in Black Lives Matter could be related to make people to do some to activate or to do some to gather together or to have some collective action. And we also know the sentiment information is important too. So we've come to target whether we can find any like specific sentiment like fear, anger, anxiety, depression, guilt, and helplessness. This could be very related to this context. So our hypothesis and research question for this study is, the first one is hypothesis. We want to examine whether health professionals in the COVID-19 related tweets, do they express positive or negative sentiments? So this is our hypothesis. We hypothesize they do not express this kind of sentiment. They are neutral. So we got to refute it. And our research question, the first one is, how frequently are health professionals COVID-19 related tweets and information sharing infused with their personal political and partisan stances? So there could be a lot of political stances and political arguments, and we want to see whether these health professionals are aligned with their own political stance. And our second research question is, how do the positive and negative sentiments reveal their COVID-19 related tweets align with their political stances? So we're going to examine this. We're going to first identify their political stance and then see whether their post tweets comments align with their political stance. So this is our flowchart and data for this study. So we start from the left. We have COVID-19 related tweets. I don't know if I can try this. Okay, we start from here. So we have a loop here. So we're going to start from here. So we're going to use different methods. This is obviously a mixed method study. So we're going to analyze the social networks of these tweeters, these accounts, to try to find the clusters of Democrats and Republicans and other people. And then we're going to do community detection to do that. So we can identify pro and anti-Trump cluster and neutral accounts. So this is a first route. And the second one is we're going to do the data wrangling. So we start from 7 million tweets and containing keywords, trends, hashtag, emoji, and we're going to filter it with professional tweets. So a lot of tweets we collect, we don't know whether they are from health professionals. So we study their bios. And first we make sure they are health professionals and we collect their tweets. So this is here. I hope it's here. And then we did sentiment analysis and topic modeling to see whether we have like specific sentiment and whether they are talking to which kind of topics related to COVID-19. Okay, so our data collect is from January 1st to mid-May 2020. So we can see this is a very early COVID-19 pandemic before and after the outbreak. So we collect data, we scrape data from Twitter and X. So this keyword combination. And I must say this is the insight from Yao Tai. This is very, I think it's very smart. At that time, he just has his own group of people like scrape the data from the Twitter. I think it's nowadays kind of very hard to do this. So he did, he find COVID will be one of the keywords and combined with other keywords. Like we can see, like combined with health, pandemic, science, statistics, and maybe some other keywords like hospitals, lockdown, hygiene, sanitizer, frontline, virus, etc. So we have scraped like over 7 million tweets. Okay, so we can see the tweets, the trend of tweets here in the early stage of the pandemic. So this is a number of tweets per day in thousands, and we can see there is a obvious like spike near the mid-March time, but that is also the time like WHO, World Health Organization, officially declared COVID-19 as a pandemic. Also, in the U.S., because we know most of the Twitter users are in the U.S., U.S. began to implement lockdowns in mid-March as well. So we can see there's a spike discussing COVID-19 related tweets. And we have the data like 4.5 months until mid-May. But you can see the trend is going slightly down. I guess the first time like people see this, they're really shocked and very uncertain about what happened. But after that, they are kind of used to it. So the trend is going down slightly after late March. And these are some descriptive results, statistics about the keywords we have. So all the keywords are combined with COVID-19, and we can see we have like 20 keywords, around 20 keywords here, and we see their reply, retweets, and like. But most of the people just have like kind of like, it's not like very active reaction, it's just only like. And many of them, we only have like one reply or no reply. So we can see the first one is like frontline, and second one is hospital, I mean for the frequencies, and flatten the curve, etc. So how do we identify these health professionals? We use their account profiles. So we study their bio, and if the bio contains MD, MPH, PhD, RN, DO, or doctors, then we, or doctor, but doctors, also doctor of medicine, public health, etc. So we identify these health professionals. This total number is like over 9,000 health professionals, and their location, if this information is on their bio. Almost half of them are from the United States, and 700 of them are from UK, etc. But the rest of them, maybe we don't know their location. Okay, so we will use different methods to analyze this data set. So the first one is text analysis. So the first thing we use is to try to identify the topics these tweets are about. So we use like kind of standard method called latent Dirichlet allocation. So this is a probabilistic model, and just try to use unsupervised machine learning to distinguish the total tweets or text into different topics. But this is unsupervised, so there is no accurate or true answer. So eventually we have 4 topics. It could be 5, it could be 6, but we study the text and the topic together, and we determine it could be 4 topics is the more appropriate selection. The second method we use is we want to study the social networks of these health professionals. So we, as I said, we study their bio, and we use their following related relationships. So we have more than 5,000 accounts, and there are almost 25K edges. So we use this to construct a social network. But this is only static, because during these 4.5 months, we assume the network structure will not change too much. And we measure the centrality or the importance of each node, and like we use the measurements like in degree degree, eigenvector, closeness, betweenness, and PageRank measures to try to see whether which nodes are important or not. And we also try to determine the community structure or the clusters in this network. So we applied a method called InfoMap. So this is also a community detection algorithm. It is kind of a standard one to determine the community structure of this network. So the third method we use is sentiment analysis, because we want to capture the health professionals' sentiment during this early stage of the pandemic. We use an algorithm called Crystal Field. I don't know if you know this or not. I didn't know this before this study. So this main goal is to determine the text, whether it is positive or negative or neutral, or it is which kind of sentiment it contains. So the input is text, and the output is, there are 5 outputs: joy, fear, sadness, anger, no specific sentiment. So this is people like computer scientists or linguists, they trained the algorithm already. So this is a method like publicly available. So we just trust this method, this algorithm. But this is not ground truth as well. So we can see, because we want to see how accurate or how consistent it is with our judgment. So we also randomly selected 1% of the tweets, and then like all of our authors, like Yao Tai, Manning, and I, we just see whether this tweet is positive, negative, or which kind of sentiment it contains. And we found out it's the accuracy or consistent with our opinion is like 75%. It is consistent with our judgment. So this is not ground truth, but I will say like a lot of things like sentiments. You can see the negative sentiments. They are kind of close. It's hard to distinguish, like fear, anger, sadness. It's kind of hard to tell. So I think like 75% is okay, but this is also a limitation. Okay, so this is a trend of the keywords for the first 4.5 months in 2020. So we can see spikes like around early March or mid-March, and the first curve, the tallest curve is virus, this one, and the second highest one is, I think, is infection or pandemic. Is pandemic. So it's like similar to our at least impression. Okay, so these are the hashtags and emojis we also have scraped from the Twitters. And the first few popular hashtags are lockdown, pandemic, corona, etc. And the emojis, we also described it in the paper. Like the top 6 most frequent emojis are like folded hands, maybe they are praying or maybe they are thankful, and face with tears of joy, and with medical mask. So here are the results of our topic analysis. So we found 4 topics of the health professional tweets. The first one is cases related to deaths and health and data, coronavirus, obviously. This is the first topic. The second topic is hospital and related to people, health, patients. And the third topic is pandemic, related to spread, health, information, etc. And the fourth one is lockdown, and lockdown is already like in there too, like stay at home and so on. So we're going to study the 4 topics and their trend. So we can see the hospital related topic is dominant among these 4 topics. So but the 4 topics, they have similar trends because it is from the same data set and the same event. So as the case went up, like hospital and intensive care capacity, it caused the hospital topic to be the most eminent one for this data set. And the second result is our social network analysis. So we study their bios, and we use cluster analysis to distinguish the clusters. And the blue ones is anti-Trump or Democrat cluster. And the red one is pro-Trump or Republican cluster. And the rest of the nodes, the black one, are the other people. We cannot distinguish their behavior, or we don't know their political stance. So for the Democrats one, or the anti-Trump one, is the left. So we can see their the keywords in their bio, like RN, or like liberal, BLM, and Democrats vote blue, etc. And the right one is the keywords in their bio for the Trump camp, like MAGA and conservative and Christian, proud, etc. Trump supporter. So we can see there's a big difference. So we study their network cluster, their features, network feature of the clusters. So the first cluster, the anti-Trump cluster, they have high mean in degree, but their overall in-group density, there's no statistical significance difference. So the anti-Trump cluster, they have a higher mean out degree, higher mean page rank. This is different. But the pro-Trump one, the t-test shows they have different mean out degree related to other people for the main rest of the group. But their local clustering coefficient are similar. Okay, so we also study their accounts. For example, the top influencer for the Trump camp is a proud Trump supporter in her account, and this is a health professional as well. So, but her account was banned after like 1 or 2 years after our study, because she has some like vaccine hesitation or some conspiracy theory involved, so her account was banned. But her influence was still a lot, because she has a lot of followers and a lot of like almost like 300, like 400,000 followers. So she has a lot of influence. So let's take a look at some example of tweets for Trump supporters. So we can see for the Trump supporters, like the first one, they try to blame the Democrats, blame the Joe Biden as, but he was not like president that time. And Bernie Sanders and Democrats was the target they blamed, and even Obama. You can see the second tweets, and they are worried, but they also have fear, but they try to root for Trump. And let's see the example of tweets for the anti-Trump comments. So basically, they are just blaming Trump. Just Trump did a bad job, and he's like not good at dealing with this task. Okay, so go back to our research questions. Are health professional tweets emotionally neutral? And the literature show they are expected to deliver neutral and correct information timely. But there is also literature says sometimes like health professionals, they use scare tactic to make people to activate or to behave properly. So we want to examine this. So we use, as I said, crystal field algorithm to categorize their tweets and know their sentiments, like joy, fear, anger, sadness, and no specific sentiment. And we found fear is dominant during these all tweets, regardless of time and regardless of topics. So we can see the first topic, the case topic. We have like 4 or 5. The last one is like, there's no specific, so we don't talk about this. So we can see fear here dominates almost all the tweets for this topic cases, the first topic cases. And this is kind of consistent. And for the second topic, fear also dominates this topic. And we can see this second topic is hospital, and fear is also dominant. So we analyze the sentiments and the relationship of each topic. So we found fear was closely related to confirmed case. Like we use these keywords, and then we see fear is very related to this confirmed case. And anger is more sensitive to hospital and lockdown. These two topics we found. I think it's perhaps people didn't expect lockdown, or people asked for lockdown, but they didn't see that. So there's a lot of anger behind it. And joy, what is joy related to? We sometimes see it's hard to find joy during the pandemic, especially related to COVID-19. There are a lot of negative statements or scary information, but we also found joy here. So joy is more associated with pandemic and lockdown topics. So these are some examples. So this example is here. So like we can see, to tell the healthcare professional across the globe, salutes to, there's an image here, salute to the health professional, they work hard and to fight COVID. So, and we should we can touch each other only when they are in protective gear. So this is classified as joy. But we can see there are a lot of sentiments could be associated with this tweet. So we use crystal field to analyze it, and we can see the result is anger, like 0.39, and fear for 0.37, joy for 0.41, sadness for 0.37. So this is more related to joy, but we can see the sentiment is kind of mixed here. And so we can see different clusters. What are their joy? What are the things they are happy with or happy about? So for the pro-Trump cluster, the joy is from like defeat the viruses, or thank Donald Trump to save his life. This is their joy. So we study the difference. We use t-test to study the difference of these two clusters, the pro-Trump and anti-Trump cluster, and we found pro-Trump cluster has more fear. This is statistically significant, and no specific they are different, but I don't know. Just the other sentiments there are no statistical difference here. So we also study different clusters, their emotions toward each other. So in the cluster 1, the anti-Trump camp, their anger is almost always towards Trump because he was the president at that time. So we can see, like, they say Trump is a liar or a biggest danger during the pandemic. And what is a joy for the anti-Trump camp? So a lot of time it's mixed with anger. So like he says, this tweet says Trump is delusional and is a complete failure. But this is a negative statement. But then this tweet thank God and have accurate information. So it turned into joy later. So it is classified as joy tweets. And next thing is like great. Trump doesn't believe in science, blah, 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 and invite every mega people to fight the COVID-19 disease. So thoughts and prayers. So this is also classified as joy. But a lot of them contains sarcasms into it, because sarcasms can be thinking like positive statement for the algorithm, but indeed is kind of being sarcastic. And the last one is like how ignorant Trump is, but it's still classified as joy because it's an amazing man talking about other people like for their camp, in their camp. So we focus on health professional tweets related to COVID-19 pandemic, and we focus on their politicization of their health communication. So we have the three, one hypothesis, they are not emotionally neutral, and it is often infused with political stance, and they have specific sentiments doing with their topics they communicate. Okay, so we found the tweets are contains politicized information dissemination during the early stage of the pandemic, and it's not free of value. and it has impacts on public cognition of the pandemic. So we also have our limitation of this study. So the first one is obvious. So this is only a very limited period, the early stage of the pandemic, and it's not the stance or the emotion of the pandemic will change during the time, and it's still ongoing. And the second thing is we only analyze the tweets from individual health professionals, but health association tweets could be as important as well. The third one is we didn't analyze the popularity of their tweets, and I know that this is could be a big one. So, but we also know the role of the social media politicizing the health information. But a lot of the tweets, there are no comments behind it. A lot of them, like 90 or 80% of them, are just like retweets or like. And there are some other limitation. So the health professional we recognize, so they have PhD or doctor, but the PhD or doctor may not be related to health. This is another caveat. And the unsupervised machine learning could be biased as well, because it is like we decide which topic it belongs to, so this is could be biased and misinterpreted as well. And the research cannot be generalized, maybe because most of the Twitter users are from the United States. And the anti-Trump and pro-Trump stance cannot be generalized to other countries as well. So in summary, so we found health professional tweets have political remarks, often contains political remarks. And the majority of users did not identify with any shared patterns. And the tweets are, we analyze it into two clusters with anti and pro-Trump stances. And we find the sentiments of health professionals often align with their political attitudes. So thank you for your attention. And if you have any questions or comments, please feel free to let me know. Thank you.
Okay, thank you for Professor Lee's presentation. So we are now open the questions and comments. Professor Xiao.
Super excited about this research. It has relevance not only to sociology, but also the field of communication. I'm very curious how my fellow communication scholars, Dr. Mukherjee and Dr. Zhou, think about this project. But I find this very, very interesting. My kind of half comment and half thought here is about how the research questions were formed in terms of the supposed neutrality of emotions regarding health professionals. So to my understanding and to my imagination, this is developed in the context that medical doctors, when they deliver information to their patients, they should deliver it in a neutral and unbiased way. Now the question is whether when these professionals transition into an online social media space, whether that logic still applies, because fundamentally, the logic of social media is personalization, and there's a bunch of literature on this, the logic of connective action, or what perpetuities cause effective publics. So I guess my question is, on the analyses, are we able to distinguish content from the two? So for example, let's say one person tweets, we should, quote, we should seriously deal with this pandemic. Therefore, we should stand together with Trump, MAGA 2020. So the first sentence says, we should seriously deal with this pandemic. It's emotionally neutral. But then it's also infused with the social media logic because there's the personalization of social media users, including health professionals. We should stand together with Trump, MAGA 2020. That has emotions. So I'm wondering if it's possible as a next step. I mean, this is a very important fundamental cornerstone to understand in general what's the sentiment. But is it able to parse out these two pieces? Specifically, for example, when these users talk about COVID-19 itself, whether it's emotionally neutral. And then what about the other content in the tweet? Like they talk about like Trump is either stupid or smart, depending on their perspective. And then if there are these differences, there might be like even more exciting research coming on. For example, emotional overflow. In the communication literature, there are all these research articles talking about gateway effects, right? Using something that is easy to digest to lead into other parts. And I'm wondering, for example, you starting with the emotionally neutral, like we should seriously deal with this pandemic, to get people hooked onto this topic, and then in turn support Trump, for example. So I'm wondering if these next steps are feasible with the data, and yeah, I just feel that this has a ton of relevance to communication as well.
Sorry, technically speaking, if I phrase a positive thing in the beginning, but then end with a negative thing, I'm just wondering, how does algorithm deal with that thing? Is it neutral or is it like bimodal? I think that's also my question.
Yeah, sorry, just to follow up Dr. Jiang's thing. So perhaps one way is to calculate the distance between the keyword, right? Because you sampled like COVID-19. So the words or sentences surrounding COVID-19, and then, you know, there's the front and the end, and those might be like further away from the core topic COVID-19. I'm wondering if that's a feasible part.
Yeah, excellent questions. So I also agree with Professor Xiao's comments. So the neutral, supposed neutrality should be like health professional, like doctors to their patients. This is supposed to be like no severe sentiments in this context, but also in social media. These are individuals, they are citizens. They could have a lot of emotions. I think it's very natural. And we found this correct too. So, and the second thing is, if we want to try to give the sentiment score or allocation more accurately, we should do more parsing. I mean, for the example you gave, like if there are 3 sentences or 4 sentences, the first one is neutral, the first one is positive, and the last part is negative, as Professor Zhang said. This is could be parsed into 2 different things. The first one is neutral or positive. The second one is more biased or negative. But we didn't do that because it is still a lot of work. We all know the unit of analysis is per tweet. It's only 1 tweet. So we study the manual of Crystal Field. So it is very common we can have like mixed emotions or sentiment in one text. It is very common. So the algorithm just do a math behind it. Like the first part is negative, like minus 0.3. The second part is positive, plus 0.5. Then it is positive. So there is a lot of things behind it. So we pointed out that this is not 100% accurate, and we also examined this by ourselves. So we study 1% of the tweets, which is a lot, and we try to allocate we try to find their emotion, their stance, and their positive or negative sentiments, and we say, okay, this is only 75% consistent with our judgment. So this is a obvious limitation.
Yeah, just to follow, but I do think it's an opportunity as well, right? Because does the algorithm work well on like short sentences? If you give it 1 or 2, then at least one parsing could be the sentence focused on COVID-19. You feed that to the algorithm and see what are the sentiments related to that, and then feed the other parts of the tweet into the algorithm as the next step. And then I think that opens up exciting doors.
Thank you for the comments. Yes, I totally agree. Yes.
I kind of have 2 questions. I was like reading the paper while listening to your presentation. Amazing. And I wonder if in the reviewing process, because it's a published paper, right? Like, did you face any pushback for using Crystal Field for doing the sentiment analysis? Because there are many tools that are available, and my impression of using this kind of tool is that each different discipline or subfield, they have their own kind of like standard or preferred tool. And for this particular journal, I find this journal very fascinating, Social Science and Medicine. I wonder if the reviewers got any pushback about the post-hoc evaluation and using the tool to do the sentiment analysis. And the second question is that if I were just to test the 2 research questions you have for this study, the network analysis and the table about the network statistics itself are very interesting, right? But eventually, to test these two hypotheses, you only need to identify the two clusters, which is pro-Trump and anti-Trump. So you don't necessarily need the network to identify the clusters if you just kind of sample the accounts and kind of verify it also manually, in a sense. Maybe there's like an added strength here by saying that this is the natural structure of the network. But there's also a possibility that I can kind of identify multiple different clusters without the network, right? So the network is interesting, but it's not a necessary element to test the research questions. So I'm just wondering if there's, for example, if I have like data but not tweets during that time range for COVID-19, but I don't have the network structure, could I do similar analysis and formulate interesting research questions based on those kind of data? And would you find it valuable to do an analysis based on those kind of data? Yeah, those are the two questions.
Okay, thank you for Professor Zhou, your comments and questions. So the first one, the crystal field. Yes, we have some pullback from the reviewers. So one thing they asked about was the accuracy for sure. So we said it is a typical thing or from other computer science journal. They have a lot of tests already. So we cited our papers for the crystal field.
And this algorithm is focused on short text, such as social media posts, and some of the past research focused on pandemic and the social media posts during that time also use this algorithm.
Yes. Yeah. So as Manning said, that this is commonly used in social media context, and we also check by ourselves. So we provide the accuracy or consistency like 75%. And for the second question, yes, I agree. Like, I think this we don't need to do the. I mean, this is a value could be added on for if we have these social networks and we can classify their clusters and we can see the difference of their clusters for the some network measure. But if you want to do things, you classify these as pro-Trump or anti-Trump, you can do similar analysis as well. So, but we just have like more information of the connectedness and the in degree, out degree, and the importance for these accounts on the social networks.
Actually, I have two quick questions, but time's up. Maybe, okay. Maybe give me 2 minutes. Okay, sure. So I have two quick questions for Xuanwei. So first one is, in your tweets, can you differentiate their locations, maybe like the states? Because at the beginning of the pandemics, different states have a different policies for coping the pandemics and also have a different severity of the disease. So maybe this will related to their sentiment. So this is the first one questions. And second one is that because you already find some influential person, like you mentioned, so they have many followers. Maybe they also have a higher centrality. So did you can you try the diffusion, identify the diffusion effect of like emotion, like a fear, contagion in your network? You identify network. Maybe is that possible? Okay, two questions.
Fascinating questions. So the first one, it is a little bit difficult because we only study their bio. If the information of the state is not there in their bio, we don't know.
Like for the accounts in America, they often like mention the states rather than the country. So I think we have. Yeah.
Okay.
Yeah.
Then we can have one project to work on later. And the second thing is we only know the static structure of the following relationship. So it is a little bit difficult to know the propagation of emotion. So it is possible, but I don't know many idea. No. Okay. So it's not that easy.
Okay. So maybe we thank Professor Lee again. So now we proceed to our next speakers. Maybe our next second speaker is Professor Subhaya Mukherjee, right? From Department of Communications and New Media, National University of Singapore. Professor Mukherjee received his doctorate degree in communication at the University of Pennsylvania. He graduated with a Bachelor of Engineering in Computer Science and a Master of Science in Mathematics in India, and has working experience in industry of software and data analytics. His research interests focus at the intersection of digital media and online human behavior by using extensive computational methods on hybrid observational and experimental approach, such as network analysis, statistical inference, and agent-based simulations to understand how digital audience navigate online media environments. Okay, today he will present a topic entitled Informational Asymmetries in the Production and Consumption of Digital Media. Okay, let's welcome Dr. Mukherjee.
All right. Thanks for the very kind introduction, and thanks to Professor Chiang for this very kind invite. It's my first time in Taiwan, and I'm really excited to be here amidst such company. So today I'm going to talk about informational asymmetries in consumption and production of digital media. And I know, in my intro, I was introduced as, I've kind of a complicated trajectory in the computational social sciences, right? So I started off as I did a bachelor's in computer science, then a master's in maths, and then I plunged into the social sciences without knowing what it was. But I kind of survived, and so the way I approach a social science problem is not from the methods, but from the phenomenon that I'm interested in studying, and then I decide what methods best fits that phenomenon, or what method is best used for that phenomenon. So, which is why I don't remain very localized to a specific or very faithful to a single computational method, but I try to use whatever methods I can use, what is available to me, what best fits the problem, right? So, even though, in my talk today, I don't really, I'll not talk much about networks, even though I've used them in my previous work, but hopefully, and I know that this workshop is pretty heavy on networks, but hopefully there's enough computational material here to justify, my talk being part of a computational social science workshop, right? So, so let's get started. So I'm going to start by making the following claim. The 2010s was the decade of the echo chamber, right? And its closely related cousin, the filter bubble, right? And so these two graphs show what I mean. So if you look at the worldwide Google search trends of these two terms, it is during the 2010s that they really became part of our collective consciousness, right? Filter bubble peaked a bit before echo chambers did, but then nowadays the kind of routine terms that we see in the media, that we hear about in regular public discourse. And so there is no greater indication of their prominence than the explosion in media coverage that these words have received. And this slide only shows a handful of these examples from popular media during that decade. So, and the reason I dwell on this specific article published in Wired in 2016 is because it kind of foreshadows an important message that will become clearer towards the end of my presentation, right? And in parallel to the heightened prominence of these terms, academic interest in echo chambers and filter bubbles has also accelerated, as these trends from Google Scholar indicate. However, a close reading of the literature suggests that kind of a nuanced turn in how we are thinking about echo chambers and filter bubble, which takes me to this next slide, which is the echo chamber dead? And of course, I don't mean literally dead, but are we realizing that maybe echo chambers aren't as important as we had thought them to be? Here's why I say that. So this is a 2018 Knight Foundation report where some scholars reviewed the then burgeoning empirical evidence on echo chambers and found that selective exposure to like-minded material or political news is less prevalent than you think. And another more recent review published by the Royal Society in the UK came to a similar conclusion, that echo chambers are much less widespread than is commonly assumed, and the work reviewed here finds no support for the filter bubble hypothesis. But what about selective exposure, right? Echo chambers and filter bubbles speak to a macro level structural phenomenon. But how about human agency? I mean, do people at the individual level also not show a predilection for favorable content? And I mean, decades of selective exposure, of social science research tells us that selective exposure is very real, that humans indeed actively seek out information that they like and avoid information they don't like to avoid cognitive dissonance. And all of this is pretty much established to be quite true. How then do we explain the lack of echo chambers? In other words, if selective exposure is indeed real at the individual level, that is, if people do indeed seek out information in a biased manner, how do we explain the mounting evidence that suggests that echo chambers don't seem to exist in terms of the empirical evidence? One answer, I argue in this presentation, lies not in the concept of selective exposure, but in how we are defining it, right? So this takes me, for too long, we have been looking at selective exposure through a specific lens, which is in the case of the US, Democrat versus Republican, liberal versus conservative. In the case of the in the UK, you have news consumption during Brexit among the Remain group and the Leave group. So basically there's a left versus right divide in how we think about selective exposure. And it is tied to partisanship. And a handful of these studies just show that, right? Almost the average selective exposure study, including one of mine which is shown there, is about looking at selective exposure through the left versus right perspective. And there is a problem with that, in that this obsession, I argue, it presupposes the prominence of politics in people's everyday lives. So if you stop for a second and think about it, think deeply about this assumption, many things begin to fall in place, as I shall show. So this takes me to the central and somewhat controversial message in my presentation, which is that people don't care about politics, right? Okay, I'll admit that's a bit too clickbaity. So here's a more toned down version of that. People care far less about politics than what we think they do. By we, I mean academics think we do. Maybe I'm just generalizing, and I say we, I mean political communication academics who are obsessed with politics think that everyone is obsessed with politics just like they are, right? But perhaps they are not as obsessed with politics as we think they do. And this lens, I argue, is a bigger determinant of what information we consume, and it goes a long way in explaining why we don't see real-world echo chambers on digital platforms. So I will now talk about two studies where I will hopefully demonstrate why thinking of media consumption and production through the lens of political versus non-political is perhaps more important than looking at it through the left versus right lens. Both of these studies are ostensibly set in the context of US politics and are about the American political system, but I do believe that there are certain insights which can be applied to other concepts as well. So the first study is the political landscape of the US Twitterverse, published in 2022 in Political Communication, was about understanding how political Twitter, now X, in the US really is, or at least how political it was in 2019-20 when the data was being collected. And it was set in the background of a lot of media and popular narrative about Twitter being a very politically charged platform. So our initial question was, how political is Twitter, right? How polarized is Twitter? However, when we looked at the data, we quickly changed our question to how political is Twitter really, right? And so and then when we thought about it, this new question made a lot of sense because there is a lot of literature on Americans being notoriously uninterested in politics, in that it has amongst the lowest voter turnouts among developed countries. They have severely low levels of political knowledge. And our question was, is this disinterest in politics reflected in their use of Twitter? So what we did, we collected a large geotagged sample of American Twitter users, a random sample, and then we obtained their friend networks, which accounts do they follow. And then we identified the most followed elites on American Twitter, right? So, so each elite is now a unit of analysis in the study, right? So what we did, how we departed from previous studies is that who or what is important on Twitter is not pre-decided because they are politicians or because they're the speaker or because they're the president or the vice president, but based on behavioral trace data, right? So we look at what ordinary people are following on Twitter and then decide who the most important people on American Twitter are. And then each elite was categorized manually into genres, such as sports, politics, media, entertainment, and so on. And then we used this Bayesian ideal point estimation technique to identify their political slant. There is a great paper on this, and there was an R package associated with this also, how you can infer the political slant of a Twitter account by looking at who they follow, but that no longer works because of Twitter's API changes, right? But it was a great piece of software by Pablo Barbera, who's in USC, I think. So anyway, basically we looked at each elite, we looked at who these elites were and where they stood on the ideological spectrum. And so here's some findings. On the x-axis, you have the total number of unique followers of elites in that category. On the y-axis, you have the total number of tweets sent out by elites in that category. And we found that politics is a sideshow on Twitter. In that, all the political figures, the political pundits, the hard news, they are dwarfed in visibility and prominence by entertainment, sports on Twitter. All right? So if you look at it from another perspective, from the perspective of ordinary users, this is the number of elites in each category they follow, right? So we find that the median Twitter user in our sample follows 10 entertainment accounts, 1 brand account, 1 sports account, 1 political figure, 1 public figure, 0 political pundits, 0 hard news, and so on, right? So already there is a huge much greater importance assigned to entertainment or and so on, but not so much to politics. Next, when we look at, so remember our original question was how polarized is Twitter, right? So then we tried to see with this data whether the distribution of ideal points or the distribution of ideologies of these elites showed a kind of a bimodal distribution, right? So if it was polarized, we would expect something like this, where there is a peak towards the liberal end and a peak towards the conservative end. But instead, we found no evidence of polarization that we had initially sought to measure. Instead, we find a largely unimodal distribution. So the pink distribution shows the lack of polarization in ideologies, like there's a huge peak at the center. And the cyan distribution shows the lack of polarization in perceived ideologies, according to MTurk workers. So not only are these elites not polarized, if you look at their ideological scores, they're also not perceived to be polarized by ordinary Americans on MTurk. And then the problem with this was, this assigned the same weight to a account that tweeted a lot versus an account that does not tweet at all, right? So the Twitter may have a lot of extremely, right-wing or left-wing accounts, but if they don't tweet much, then they're not really contributing to the polarization. So then we weighted these ideologies, based on how much they tweet. So the higher the weight, the more they are active on Twitter, and we found that the polarization almost completely disappears. It's just this huge peak in the middle, right? So again, not only was Twitter not very political, it was also not polarized at all. But there were still some interesting political findings, or rather findings about politics, or where if you look at the decile of each tweeting activity, where the top axes have the most active tweeters, the bottom axis the least active tweeters, there is an increasing slant towards the right. In other words, considerably more right-wing elites among the most active tweeters than among the less active tweeters, even though there is a consistent spike in the center throughout, right? So what does all this mean? Much scholarship about political communication presumes the prominence of politics in people's everyday lives, and these findings are often an artifact of this assumption, in that a lot of studies that try to find how political Twitter is or how polarized Twitter is, they're often looking at the accounts of policymakers or Democrats and Republicans, not of what ordinary people are doing. Right? And I think this is a big reason why there is a lot of literature on Twitter, both in academia as well as in regular media, of Twitter being political. And there are two key asymmetries that we find. One, that right-wing elites tweet more than left-wing elites, but most importantly, most people don't care too much about politics. So we scholars are kind of in an echo chamber, just not the one we think. Right? We are in this echo chamber within an echo chamber of people who only care about politics. So if you step outside this echo chamber for a while, we'll see that there is not much interest in the political process, in the political discourse. And there is some supporting evidence. So around the same time when this paper was published, there was this book by Yana Krupnikov and John Barry Ryan, where they it basically brought to light what they call the other divide. In an NYT op-ed, they call the real divide in America is between political junkies and everybody else, not between the left and the right. Right? Okay, so that is my first study. The second study is about, so the previous one was kind of about people's information consumption habits on Twitter, who they followed, and we find that they don't really consume too much information about politics. The second study is about, published last year, where we look at news production on social media, on a very different platform, on Facebook. And this study was published in a Journal of Communication special issue, and this is set against a very journalistic background and was aimed at generally trying to understand how news production practices have changed after the news moved online. So when the news moved online, journalists were suddenly able to get a granular understanding of what their audiences actually liked. Did this change how journalists did their job? And specifically, do journalists use social media engagement metrics to decide what news to publish? And related to this talk, we were interested in finding whether there are similar divides in news production on social media as there are in consumption. In other words, does the process of news production also show asymmetries in left versus right, political versus non-political, and so on? So for this combined a lot of various techniques, including topic modeling, time series analysis, and so on, causal inference. So here what we did was we downloaded a whole bunch of, like all Facebook posts published by 29 English language outlets, which according to Pew Research Center are the most prominent sources of news in the US. All their Facebook posts between 2015 and 2019. We didn't want to get in 2020 because we figured that COVID might skew some of the findings, so we stuck to before COVID. And we used all the textual content, which is the kind of the lead that appears on Facebook and the headline, and we used the engagement, that is the number of likes, reactions, shares, the number of comments, and so on. We had a total of 2.23 million posts over that 5-year period. All right. And then this is where, kind of an analytical slide where I kind of show what the pipeline of our analytical process was. We had this whole data set of Facebook posts. We first divided the Facebook data set into 1-month seasons because, we were trying to find topics in the data, and topics often change over time. So we didn't want to, do topic modeling on the whole data set, but instead do topic modeling on each of the individual months. And then we did NMF topic modeling, and this goes back to the previous talk where, when you're, that's a question I wanted to ask, but there was no time. So apparently NMF, non-negative matrix factorization, is a more suitable topic modeling algorithm for short pieces of text. So which is why we use this. And then we found a whole bunch of topics over, more than 1,000 topics over the 60-month period. And these topics were also rigorously validated because that's a very common question among reviewers, right? You found the topics, but so what? How do you know these topics are real? So we kind of used a kind of new method to validate these topics, a sample of these topics. And then we did some causal inference techniques to try and measure what we call measuring media responsiveness. So this is the one mathematical slide on this presentation. But it's important to understand this to know how we fit our models. So first we had the independent variable, which was engagement signal received by posts about a specific topic published by a specific outlet at some point in the at some time in the past. So you see it's t minus lag, so it's some time in the past. Next, the dependent variable was the frequency of the same topic published by the same outlet in the current day, that is in the present, hence the subscript is t. Now, because this was panel data and not experimental, we had to be very careful about considering all the possible confounders. So we controlled for several confounders, including fixed effects for time, outlet, topic. We controlled for news value, because that is something that determines whether something should be published or not. And finally, we estimated this linear model, basically a fixed effects model with a lagged dependent variable, and where we are trying to find the effect of engagement with a certain topic published by a certain outlet on the future coverage of that topic by the same outlet, after controlling for a variety of confounders, most importantly the news value of that topic. We define this coefficient, this beta 1, as the responsiveness, which is the effect of engagement on future coverage. And then let's see some results. So the first results, the first kind of overview result is that a twofold increase in engagement signal leads to an average increase of topic frequency by the same outlet by around 0.02 standard deviations on the very next day. Okay, I haven't put the numbers on the slide to not make it confusing, but basically, if there is a twofold increase in engagement with a topic published by, say, the New York Times today, then there is a 0.02 standard deviations increase in the frequency of that topic published by the New York Times on the very next day, right? And as the response window is increased from the lag 1 to lag 4, we find that the effect diminishes over time and no longer remains significant after day 4, right? Which means that news outlets monitor engagement with topics, with yesterday's topics, the day before yesterday's topics, the day before that topics, but not necessarily any further back, right? But this is, so responsiveness was not significant after lag 4, right? So all subsequent results use lag 1, all right? Now, this is a very, this is the average effect size for all the media outlets in that time span. But what is interesting is when we delve deeper into the individual level outlets, right? And we find that a lot of heterogeneity in how different outlets respond. So on the right, you will see Breitbart, which we all know about Breitbart. It's an extremely right-wing kind of provocative outlet. They are the most responsive to audience metrics. And something like Business Insider is the least responsive to audience metrics. Now here's where the asymmetry comes in. Here's a scatter plot showing the association between the slant of the outlet and responsiveness. And what we find is that right-leaning outlets are more likely to respond to audience metrics than left-leaning outlets. That's a correlation probably driven by a handful of extreme outlets on the right, because there aren't that many mainstream left-wing outlets in the US on the left. We didn't have that, we didn't have things like Daily Kos, which are like pretty hyper-partisan outlets on the left in the US, but they're not very popular so they're not part of the data. So it is possible that this correlation is driven by the Washington Examiner, Sean Hannity, and Breitbart. But even then, it's still a finding in that the right-leaning outlets tend to be more responsive to audience metrics than others. But here's where's the kind of the punchline of the study is that we find a very interesting dynamic where the left-right dimension intersects with the political, non-political dimension. So if you look at political topics only, we see this correlation as is, right? So right-wing outlets respond more to audience engagement with political topics than left-wing outlets. If you look at entertainment topics or non-political topics, instead, there is no correlation. In other words, this responsiveness of the right-leaning outlets to audience metrics is purely driven by responsiveness to political content and not non-political content. So there is no significant correlation in non-political content between slant and responsiveness. So what does all this mean? It means that audience metrics on average affect news production. There is substantial heterogeneity across the outlets. Some outlets respond more, some outlets respond less, and responsiveness is contingent on outlet slant. That is, a handful of right-leaning outlets are more responsive than other outlets, but specifically to political topics. So I realize that I've gone quite rapidly in this presentation. I still have 9 minutes left, but I don't have too many slides left. Which means there's more time for questions, I guess. But some closing thoughts is that when you think of information asymmetries, there are two axes to consider. The first is left versus right, and the second is the political versus non-political. And we have worried too much about the left versus right axis, and not so much about the political versus non-political axis. And so the hope is that when we do more political communication research, we try to contextualize the importance of politics by also looking at non-political content as a benchmark before we make as inferences about how much people, about people's political behavior online. So, however, this helped me reconcile the somewhat contradictory findings from lots of prior work, including my own. So this is a work I published in the Political Communication Journal of 3 years. Yeah, this is 2024. So 3 years ago now. So experiments have routinely found that people seek in-party cues and, more importantly, they avoid out-party cues, right? So in this study, we found that people avoid outlets with an out-party slant and people avoid messages with an out-party slant and choose messages with an in-party slant. That's like a figure from our previous paper. However, if you look at the macro level audience networks, again, this is from a different paper of mine from several years ago, using trace data, there is no evidence of echo chambers. So there are heavy overlaps between Fox News and CNN, between Daily Mail and the BBC in the UK. So what is going on? Why are there individual biases that people definitely do care about, in that they choose based on in-party, out-party cues? But when you look at the overall networks, there doesn't seem to be any fragmentation. Why does this happen? And all of this makes sense if you just assume that the Daily Mail and the Guardian, or the Fox News and Washington Post, shares heavy overlap because people are mostly reading non-political stuff like sports news and entertainment, right? So they're not really reading political news on these websites. I mean, they don't seem to be. So information asymmetries exist in news consumption and production digital platforms. In consumption, the non-political/political divide seems to be far more important than the left versus right divide. And in news production, these divides intersect in very interesting ways. And that takes me to the end of my talk. So these are my collaborators whom I worked with, Tian Yang, Kokil Jetka, Ilang Peng, Silvia Vasquez, Yves Lelkes, and Sandra Gonzalez-Bailon. So they're all some of them are advisors, my committee members, my current colleagues, and my collaborators. So none of this would have been possible without their work also. And so I look forward to your questions. Thank you.
So any questions or comments from audience? Oh, yeah.
I really enjoyed the talk and learned a lot because I don't do media studies. But so maybe two very layman questions. The first one is, because you mentioned this content type, some are political, some are entertainment. In daily life, my observation is that, for example, if I am a professor in college, I have a public account that everyone can see. But I don't want others to know that I follow really stupid entertainment accounts, or if I support Trump. I don't want my colleagues, especially in sociology, it's a very leftist major. Most people are unwilling to reveal that they support Trump. So they separately have a second account. So how are the current technology here help us identify the same account of the two different or three different many accounts that one person holds? Because if that's the case, then you can capture an account that only follows entertainment and a second account only follows normal things, right? That kind of thing. The second question is, I don't know, well, since a lot of people are familiar with the Twitter, blah, blah kind of things, platforms, is there any way to better capture people's age? Because I think political view is highly related to how old I am. So when I was young, I'm more progressive. And then when I'm older, I'm more conventional or conservative. So how can we control for that? Is there any practical methods to do that? Thank you.
Okay, so your first question, I think that's a great point in that, you know, people often have multiple accounts which they use for multiple different personas. I actually got to know that, you know, my students, my undergrad students, at least in Singapore, they have at least 5 or 6 different Instagram accounts, one for each persona that they want to show to different circles in their lives. So yeah, I think that is true. Yeah, we didn't control for that. So, but what we did was, so we are hoping that because we did a random sample of American Twitter accounts and then looked at, you know, who they followed. So there's no reason why a second account would not be in that random sample, right? So we use the Twitter firehose to get, which I think the 1% of all tweets sent from the US, we sampled from there. So this includes, I would think this includes, if it's a truly random sample, and that depends on, you know, who did the random sampling on the Twitter side, right? Then I would expect such second or tertiary or secondary accounts to appear in that random sample as well, as long as they're geotagged to be from the US, right? And if there are enough people who, with their second accounts, followed political elites, then that would show up in the data. But it did not, right? So either there are not enough accounts like that follow political elites, in which case the findings from this are still largely valid, or there are people who don't geotag their tweets when they use the second accounts, in which case we have completely missed the dynamic because we only focused on US accounts, right? So that's possible. Yeah, that's a legitimate concern. And for your second question, what was it about? Age, yeah. Again, so I'm guessing your question applies to the first study, the Twitter study, right? Not the second one about Facebook. To the first one, yeah. So again, these are our question. The context of the scope of our study was Twitter. The title was the political landscape of the US Twitterverse. So, and by using a random sample of Twitter accounts, we're assuming we kind of captured the median Twitter dynamic instead of, I mean, if Twitter has more young people, which it does, or at least it did 3 or 4 years ago, then that is part of the scope of the study, right? So. Yeah, okay. Yeah, okay. Yeah, so yeah, I think that's a great study. I think if you can do the study again in the future or now, in some few years in the future, then we can see how the trends have changed. Yeah, but it's very difficult to do the Twitter study now because the API is gone and it's very expensive. But yeah, I mean, if you've seen Facebook, I think we discussed this yesterday, right? The demographic change of Facebook users, right? So Facebook earlier, I'm pretty sure, was far more liberal than what it is today because the user base of Facebook has aged, right? And the young people have all left Facebook. So I'm sure TikTok and Instagram are far more young, you know, youthful than Facebook is. So yeah, I think it's the important thing about these platforms is they change continuously. So it's important to keep doing these studies to see how things are changing. But this also means that, you know, we need to ensure that the platforms remain investigable. Like Twitter is no longer pretty much investigable, right? So it's a challenge that we are still navigating with it. I think there's a discussion session today on the challenges of computer social science, and we can talk more about these problems of how do we deal with studies or how to deal with platforms that are becoming increasingly opaque. Yeah.
I have a questions for each one of the study. For the first studies, I'm just wondering that the formula that you presented, I think it's in the second study. Yeah, okay. Can you go back to the formula with the time lag, with the time log? That one. Yeah, this one. Mm-hmm. Yeah. My question is to challenge the time lag that you are proposing here. Is because every media, they has a time pressure to publish their article. So how did you really know that this is the right time frame for each one of the posts that they presented, or they have the audience to exposed in the media.
You mean the value of the lag?
Right. So, I mean, how did you really know is this the time, not for the publication, not for the post, the time pressures that from the each one of the media, or is this really the time for the news reporter to see the post and then they react by the topics?
So this was somewhat driven by the main findings, where we find that there is a significant effect for next day's coverage, the most significant effect for next day's coverage, which reduces over time. And there's also some literature, albeit some qualitative work, which has based on some newsroom observations in France and in the US. There's a book called Metrics at Work by Angel Christine in Stanford, where she actually spent many months in I think CNN newsroom and some French newsroom to see how the different journalistic cultures in these two countries. And she finds that in the case of the US, there was no the editors did not respond to audience metrics, whereas in France they kind of chase the metrics every single day. And that's kind of what we find, in that the outlets like the CNN and New York Times and all, they don't really show significant effects. So we stuck to the day one, lag one, because that had the highest average, the highest average estimate for in our sample. So it is possible that different outlets have different time lags that they kind of that yields their highest value. For example, New York Times may have 4 or 5, and Breitbart may have 1, like we find here. Breitbart has the highest for time for lag 1. So, but we didn't do that analysis because then there's just too much analysis to be done. In that, for every outlet you have to try all different lags, and then it just. But I think it's a good question, yeah. So, is there an optimal response window for every outlet? I think that's a great. I mean, we didn't look at it that that deeply.
Yeah, and for the first study, I think that you use the topic levels to do the analysis, and my concern is the topics usually very attractive to the readers. So
for the first study,
for the first and the second, I think both of them you use the topic analysis. I'm not quite sure, but I mean.
In the first one, there is no topic.
Okay, so maybe it's also the second one. Yeah, so I mean, so the topics usually, the editors would like to attract the readers, their attention. So the topics may influence their reading, not necessarily they like this news. So I mean, how did you really control that topic influence? And that is the things, because this is also the method, the main method that you are applying here. So reflecting back to this kind of a method, and if the topic is very attractive, but the topics also not from the original source, it's actually borrow or purchase from other media. So did you also control this?
So that's the first covariate, the news value of the topic.
That's the covariate.
That's the first covariate, So basically we controlled for the same topic appearing across all the outlets.
Okay.
And what engagement that received.
I see.
So that was really the main confounder.
I see,
so,
I see.
Yeah.
Okay, thank you very much.
Quick questions for you.
Yeah, thank you for the talk. I remember reading this paper for the first study like a while ago, and found it very fascinating because one of my colleagues who, I'm not trying to promote our lab's work, but one of my colleagues did analyze political content on screenshots, and the percentage he found was like less than 2%. It's like 1.89%, and he referred to your work about this, we found similar conclusions. For people actually don't care about politics that much. They care about sports, entertainment, personal communication much more than politics. But I guess this is not a question, but it's just maybe it's still a question. But moving forward, right? Because polarization is not just about media, about selective exposure. There are other ideas and studies about polarization, about affective polarization, right? Affect polarization, for example. found people choose their partners, form families based on political party identification. And if you actually ask people in the US about their party identification with surveys, their self-reports, it's about 30%. 30% people consider themselves as independent. 30%, a little bit more, consider them as like democratic, and a little bit less than 30% is conservative. So there's still that in influencing the actual voting behavior and political behaviors. So moving forward, like for your kind of like research, how would you approach other areas of polarization research in your like?
That's a great question, and it's very true because I'm currently focusing on affective polarization myself in my work. So the thing is that people there is this theoretical divide between identity and ideology. People are Democrat or Republican in the US not because they have ideological inclinations towards certain issues, but because their families are Democrats or Republicans, or because their friends are Democrats or Republicans. So they identify with the Democratic Party or the Republican Party because of identity reasons, not because they believe in the partisan issues being one. They're deeply committed to being pro-abortion or anti-abortion, pro-immigrant or anti-immigrant. They start with the party and then decide where they stand on issues. So which is also ties in well with the idea that they don't have the political knowledge to know, and I don't mean to sound disparaging here, but it's just that they don't decide on the party based on their principled stances on issues. They decide on their stances on issues based on their party identity, right? And so, so they are still vehemently Democrat or Republican, and they dislike the out party, they love their in party, but without really the political without the political knowledge that one may expect to be underpinning this animosity. So I think it's far more important to study this incivility, this is kind of hatred for the other party or the love for their own party, rather than seeing where they stand on issues. So your point is very well. Actually, I'm doing some experiments to do that, to kind of measure the affective aspect of polarization right now.
That's very insightful. Thanks.
Yeah. Okay. Because of the time, we've a little bit fall behind the schedule. So now, thank you, Professor Mukherjee, again. Okay. According to our schedule, our break will have around 30 minutes. Okay. So please come back at 11:10. 11:10. Okay. Thank you. The morning is Dr. Wenqing Wu. Okay, Dr. Wu currently is the research fellow of the Institute of Political Science at Academia Sinica. Dr. Wu also currently serves the coordinator of the Institute for Social Science Methodology, founded by Taiwan's National Council of Science and Technology. His research interests focused on comparative and international political economy, comparative authoritarianism, and the Chinese politics. Okay, so let's welcome Dr. Wu's presentation.
Yeah, thank you for the kind introduction, and thank you for the invitation. And I'm very happy to. Today I'm going to present one of my project collaborate with Wen Canfu and his team member at National Defense University. So the topic here will be about the Twitter and how Chinese diplomats retweet other diplomats' tweets. Before I start my presentation, I would like to talk something about me because I am not a computer social scientist. I'm a political scientist with some limited statistical training. And I work on issues of political economy and cross-strait relations with a specific focus on authoritarian politics. So yeah, I have no formal or informal, thank you, training on data science. And yeah, thank you very much. And I have a Twitter account, which I don't update very often. But yeah, because I'm going to talk about Twitter, so I think it will be useful for me to introduce my Twitter account. And I also have my personal website, so you can visit there. Before I start my presentation, I also want to do 2 commercials. Yeah, as Dachin introduced, I am the coordinator of the summer program of the Institute of Social Science Methodology. And yeah, we have a website. And every summer we 3 weeks. And this year we extended to 3 weeks. And each year we have the annual theme. And the annual theme here is about categorical. And one thing that I need to do this commercial here is that we will have of data science in 2025. So I hope that you can join us, or you can introduce your students to register in our summer program. And it's almost free. So we offer, funded by the National Council. So we for 3 weeks, and we offer free lunch. So you are welcome to introduce your student to participate in our summer program. And starting 2 years ago, after the COVID-19, we also live stream most of our courses. So if your student cannot participate in the full course for 3 weeks, they are encouraged to go online and listen to our courses. So you are welcome to join us, or encourage your students to register. Commercial is about our next workshop. So we will offer a workshop in June, which is focusing on ChatGPT and statistical teaching. So we invited 2 political scientists teaching in the United States. One is Minlin in UT Austin. So he will introduce how to use ChatGPT to assist teaching statistics. And the other is Austin Wang from University of Nevada in Las Vegas. So he will share how to use ChatGPT to assist. It's not teaching, it's writing quantitative studies for your research. So those are 2 commercials that I would like to do as a coordinator of the summer program. I would invite you to join us. So I'm going to start my presentation for my project. So as you know, I'm not a computational social scientist. Then why do I write a paper on Twitter? The reason is that I got a grant for a project on Chinese diplomat, or China's wolf warrior diplomacy. So that's the beginning of the project. And when I start this project, I noticed that, there are some Chinese diplomats who are very active on Twitter. It's not only on Twitter, it's only in international news media outlet. So they are very vocal, and some of them are very aggressive. So political scientists or scholars in international relations just label this new style of Chinese diplomacy as a wolf warrior diplomacy. The reason for them to use this term is for the movie, because there was a movie called Wolf Warrior, and it was made by China, and it was very popular. So there is a sequel of Wolf Warrior, and then people it's about nationalism of China. So foreign media just label those active or aggressive Chinese diplomat as wolf warrior, and then call this new style of Chinese diplomacy as wolf warrior diplomacy. And the most famous one is about Zhao Lijian. So I'm not sure if you know this person. And this gentleman was a diplomat to Pakistan from China many years ago, in early 2000. And he was one of the first Chinese diplomat registered on Twitter, I think in 2010 or 2011, before Chinese government tried to embrace the wolf warrior diplomacy or Twitter diplomacy. And so it's very amazing that he followed about 168,000 accounts, and it has 1.9 million followers. Yeah, and you can also see that he tweets a lot. So it's 71,000 posts as of yesterday. I just checked. Even so here is some very boring career history of him, but it's very interesting that he was in Pakistan twice, and he was also sent to the United States for a couple of years. And it's noteworthy that in 2019 he became the deputy director of the information department of the Ministry of Foreign Affairs of China, and more importantly, he was also one of the spokespersons of the Ministry of Foreign Affairs of China. So that's why he was very focal on a lot of Chinese affairs. I will give you two examples. One is about he tried to tweet the Australian soldier killed Afghanistan civilian and prisoners. So that raised a very serious concern from Australian government. Yeah. The other controversial tweet he posted is about the origins of COVID-19, because he tried to hint that it's American soldiers who brought COVID-19 virus to China. So that was also very critical and controversial. And he has also a lot of controversial posts. Yeah. And one before he posts those controversial tweets, actually foreign media already noticed this gentleman, so they made an interview with him. So you can also find this report on the internet. And one reason for him to post those controversial tweets is that he would like to fight back against Western criticism on China. It's not only because he was a diplomat, but also he would like to be noticed, among the numerous diplomats of mainland China. So this is a big, I mean, this report is pretty well written. I encourage you to read it. So, and of course, I'm not going to write a paper about Zhao Lijian. I need to, as a political scientist, I need to think about how do I link this kind of phenomenon with political science literature or international relations literature. And fortunately, there are some previous studies trying to link tweet to international relations study, especially the issue of public diplomacy. And the combination of tweet and public diplomacy result in a new word. It's a tweetplomacy. Tweetplomacy, yeah. So I asked ChatGPT to give a definition of tweet diplomacy. It's the use of Twitter and other social media platforms by head of state, diplomats, or governmental organizations to conduct diplomatic outreach and public diplomacy. Yeah. And one of the very striking examples is about President Trump. Yeah. So he tweeted a lot as well, and then he also tweeted a lot of controversial posts. Yeah, so I think you are familiar with that period. And here I try to investigate China's diplomacy. So this is also the statistics conducted by BBC in 2019. So starting in 2019, China tried to encourage its diplomat to register Twitter account. And it's not only the diplomat, their diplomatic institutions also establish a lot of Twitter accounts. So here I think then I would like to write a paper on Twitter. And unfortunately I noticed that many people are working on this issue already. So yes, you can see that even Jennifer Penn, the professor in Stanford Communication Department, so she published a paper recently with her students, and then also there is a paper on the network of China's diplomatic Twitter accounts. Then, of course, in those papers, you will see those fancy network analysis, and then you can see the jargon of node or, the directions. Yeah. So I think that fortunately, in the beginning, I did not intend to write a paper like that, right? Because it's beyond my skill set. Yeah. I just asked a very simple question when I try to go through the Twitter account of those Chinese diplomats. The issue or the question I have in the first place is, why do some Chinese diplomats tweet and retweet more than others? So this is a very simple research question. And in the following probably 10 minutes, I will just share my thoughts on this issue with you. So this is a very, hi. Do you have any question? No? Okay, yeah. Yeah, so I'm going to answer this question because this is just out of my own curiosity. So there will be no fancy network analysis or something like that to share in my later presentation. But I would like to answer this question with my own, theoretical perspective. So that's why I asked a question about theoretical telescope yesterday. So how should I start it? And as you know, or as we already know, that scholars already noticed that there is a hierarchical network of Chinese diplomats on Twitter. So there are some institutional accounts, especially the accounts of the spokespersons of the Ministry of Foreign Affairs of China. And there are also accounts of embassies to different countries. Also, it's not only, it's similar to embassy, but it's not at the level of embassy. It's called consulate or the mission to international organizations. So there are a couple of, there are dozens of accounts like that. And there are also many individuals, including ambassadors or consul or consular or staff. I don't know why F is censored, but this is staff members. So there are about 200 Twitter accounts of those Chinese diplomat or diplomatic institutions' Twitter account. So there is a hierarchical network. Still, you can see that then, I think when I try to begin this project, some of my colleagues just asked, were they robots? They are automatically robots. Then, it's possible, right? It's possible. But if that's the case, then the next issue would be they should share a similar post, or they will have similar post pattern, right? But it's not the case. I will show you. So this is the Twitter accounts of two Chinese ambassadors to the United States. And Qin Gang, many people are curious about where he is now. But I don't know where he is, but his Twitter account is still on tweet, right? So probably you can send him a message and ask him where you are. So during his tenure as an ambassador in the United States, so he posted about 1,000 posts. It's not many, but it's some, right? But it's above average, I would say, among ambassadors. And his successor, I did not. His successor is Xie Jian. So he posted about 500 posts since early 2023. Okay, but at the same time, you can see that there is China's ambassador to the United Kingdom. So he posted about 2,000 posts. From 2021 as of to present. So there is a difference, right? And if you check their tweet, the content are not the same. There are some similarity, but are not the same. Of course, because the numbers are not equal, right? So they post differently. So that's the ambassador to the major power, right? The next one is about because we have the Japanese distinguished guest, so I try to use the Chinese ambassador to Japan. So he posted about 831 posts, as an ambassador, okay? And there is also another consulate, so in Osaka. So he posts a lot, 142 Ks, right? So they were Chinese diplomats to Japan, but they tweet differently. And yeah, one person tweet much more than the other. And I would say that this one's ranking is higher than this one, right? Because yeah, this is an ambassador and this is a consulate. Yeah. And this is amazing. I mean, for this comparison, this is a Chinese ambassador to Somalia. Okay. I'm not sure if you know where Somalia is, but I know it's far away from China. Then this ambassador, okay, Fei Sengcao. So he is an ambassador to Somalia. Oh, he also tweets a lot. And the next question would be, why would China's ambassador to Somalia will tweet so much, right? At the same time, China's embassy in Somalia only tweet about 2,000 times. So, I mean, this is a very interesting question to me. So I would just try to investigate the variation of those Twitter accounts. Okay. I hope that you think this research question is interesting. So I have a simple answer. Okay, based on my reading of Chinese politics, so I would say that those Chinese diplomats try to tweet for promotion, or at least they would like to showing that they are doing their jobs. Yeah, because if you check those Twitter accounts, sometimes they will just say, "Oh, today I have an activity with local NGO or local government, or so I meet someone," right? So they would like to show that they are doing their jobs. Most importantly, they will try to signal their alignment with the state foreign policy position. So even you are doing jobs, your jobs you need to be endorsed or preferred by your superior or the Ministry of Foreign Affairs. So you need to fulfill those two goals. So anyway, so they try to tweet or retweet for promotion. So and if this is my answer, then the next question would be, how do we capture or pin down the promotion incentive among those Twitter accounts? So that's the next challenge, I would say. So I spent a couple of days and then reading those Twitter posts. So I decided to adopt a very simple way. It's very simple, among your, So how simple it is. I will just look at the Twitter, the retweet of their superiors' tweets. Okay, so it's very amazing that I heard Professor Fu's presentation yesterday, because they usually, he told me that usually there is no hierarchy among those tweets. But fortunately, in those Twitter network among Chinese diplomats, there is a hierarchy. So, so I will just look at the difference in those three dimensions among Chinese diplomats. So how they retweet their superiors' tweets. So I will just focus on retweets. So, and then I will see how the number of retweets will differ by institutional or individual accounts. That's the first test. The other is about the ranking of those diplomats. And the third one is about their station country, because if you are stationed in a less developed country, you probably would like to be promoted to another country with better living condition. So so I think that might be something I would like to see. So again, how do we capture promotion incentive, especially superiors' tweets, right? Because among those Chinese diplomats, especially for those ambassadors, how do we distinguish who are the superiors of the network of Chinese diplomat network, tweet network? So I focused on three accounts. The first one is a spokesperson of the Ministry of Foreign Affairs of China. So the Twitter account is MFA China. And interestingly, also this is an institutional account. If you check this X account or Twitter account, there's no single person on the banner of the account. So it's just a newsstand and then showing that this is a spokesperson of China's Ministry of Foreign Affairs. And I also focus on the other two accounts. Hua Chunying is also currently a spokesperson of China's Ministry of Foreign Affairs. And the other account is Zhao Lijian. So he was a spokesperson during the period of data collection, but he was not the spokesperson anymore. So so I collect the tweets of those three accounts from January 2000 to December 31st, 2012. So it's about 3 years of observation. So I will just look at the post of those three accounts because they are spokesperson of China's Ministry of Foreign Affairs. In total, they tweet about 18,000 tweets. And there are 1.8 million retweets of those posts done by 300,000 accounts. And of course, there are a lot of bots, right? If you check the account name of those accounts, it's XXXX, and sometimes it's 6X and the other is AX, right? So it's very obvious it's a robot. So, but fortunately, we have other previous studies collecting the diplomat accounts of Chinese government. Okay, so that's one source. The other is that if you check Hua Chunying's account, you can see that she follows about 200 accounts. And the majority of them are diplomat accounts. So if they are robot, it's hard to imagine that this person will follow robot's account. So fortunately, we can reduce our observations or our target of analysis from 300K to about 165 accounts. So that's a very lucky thing. And so those accounts tweet about 46K times of those three accounts. And the other 1.82 million retweets were deleted from the data set. So that's a good thing for me. So this is the first assumption that I will make. So those tweets from those three accounts will be retweeted by Chinese diplomats. Suppose that there is diplomacy among Chinese diplomats, right? So this is the data structure. So first of all, we download or we try to get the tweet, and each tweet has an ID, and then we just recorded who tweeted this, and then who is the retweeter. And among the data structure, we have a list of Chinese diplomats' accounts. So we will map those two data, and then two data sets, and then we will just keep retweets of those Chinese diplomats, right? So this is a data structure. So it's so unit analysis is a tweet retweet diet. So this is a interesting one. So this is just the frequency of those accounts. So remember that I follow 165 diplomat account of Chinese diplomats, and these are 162 because we don't calculate the three account we focus, right? It's a minute, and this is the number of retweets of Chinese diplomats or diplomatic institutions, of those three accounts. And you can see that so I differentiate those diplomats account into three types. One is institution, the other is ambassador, and the third one is a non-ambassador individual. Then, so interestingly that there are two significant outliers. One is Cao Yi, who is staff in the Ministry of Foreign Affairs. So he tweets 4,000 times. so much higher than others. And the other is Zhang Heqing, so he tweets 10Ks. So he's an individual in Pakistan where Zhao Lijian worked formerly. So yeah, so I just try to see that the pattern is not significantly affected by those two outliers, because if we delete those two outliers, then still you can see that non-ambassador individuals tweet more than ambassadors or institutions, and the institutions tweet less, and yeah, individuals tweet more. So that's a first finding. And remember that we have OECD and non-OECD, so we can also see that for it's very interesting to me, but for ambassadors working in non-OECD countries, they tend to tweet more. But if you are individuals working in OECD, basically you tweet much less. So you can see that that's why ambassadors in the United States tweet much less, right? And then ambassadors in Somalia tweet a lot. Yeah. But it's interesting that if you would like to see that, but the pattern is reversed for those institutions account. So if you are institutional account and you will tweet more than your counterpart in a non-OECD country. So that's the second finding. So basically, that's the positive evidence for my hypothesis. So I run an interaction between the ambassadors, the Twitter account status and the OECD. And basically, you can see a similar pattern. If you are so this is a one single regression model with interaction terms between OECD country and the Twitter account's location, right? So if you are on non-OECD country, either you are so basically this is a difference between account with the same type between OECD and non-OECD countries. So we need to focus on this. So 4-1 means that if you are an institution account in OECD countries, and then the difference between between this type account and the counterpart in the non-OECD country is about 67. So I already mentioned the institutional account tend to tweet more in OECD country. However, if you are an individual account in a non-OECD country, right, then you tend to tweet more. So because if you are non-OECD, you tend to tweet more. So the difference will be negative because I use the OECD country to subtract non-OECD country account. Yeah. So that's also the finding. Yeah, although you can see that for the individual, non-ambassador individual accounts, there is no statistical significance. And this is easy to understand because they already tweet much more. So your promotion incentive does not vary that much between OECD and non-OECD country because you are a low-rank diplomat. So you tend to tweet more. And so it may not matter that much whether you are in OECD or non-OECD. Although in the beginning, I would expect that non-OECD ambassador will tweet much, much more, but it's not the case here. So, so there are some takeaways. So China developed a complicated network of public diplomacy on Twitter. So that's already done by other studies. But in this short exercise, I will just try to see that, okay, the Chinese diplomat and diplomat institutions respond to central government's message made by those 3 official accounts. And then, so they will respond differently. So those in the lower rank diplomats, they would like to retweet those superiors' message. For those who are stationed in the non-OECD country, they tend to, retweet more of those official, countries. I know there are some, next steps. So, I would follow your suggestion to do my next step, or you have any comments. And thank you very much.
I just want to try and give a possible different interpretation to your data, and that is that in an OECD country, that there are bigger missions, there are more people, the ambassador is more busy, therefore doesn't have as much time as perhaps in a non-OECD country where the mission's going to be small, so responsibilities of the work are going to be distributed rather differently, and maybe the ambassador is the only one that's there, or there's very few there, and has to take on that responsibility. Just a suggestion. I'm not saying that I still think you're right, actually, but there are alternative ways of thinking about this.
Yeah, Shenwei.
Fascinating talk. I enjoy it a lot about the motivation and the finding. So I wonder, is there any way to like more quantify the asymmetry? Because like if we are trying to, if you are trying to say this, there is a promotion incentive behind the tweets. So we know that there are different rankings and different levels for the hierarchy. So did you ever try to quantify maybe the lower rank, like what is the distance between the level or hierarchy? Like maybe, like say I am a counselor and I'm an ambassador, it's kind of like the distance is kind of close. But if I'm more lower rank, do I retweet like the top level retweets, or do I retweet top level, or I just retweet a certain distance? And if I retweet down, like what kind of distance I will just consider? Maybe I'm a top counselor, I will not retweet like very low level, low ranking diplomats. So maybe this could be quantified. And for the network data, I think if it's possible to see if you can construct a following network, maybe they are trying to gain the attention for their like closer superior officers, maybe. But if the officers, the ranking is too high, maybe they will not try to do that. I don't know. So is there data can show this kind of information? Thank you.
Yes, thank you for the great comments. And for about the bigger dedication to the country, my impression might be wrong, but I understand that ambassador is busy, but my impression, maybe biased, is that those diplomats under ambassadors were busier than the ambassador. So I think, yeah, because according to our interaction with Taiwan's diplomats, so if you interact with diplomat in Taiwan to the United States, then usually they are much more busier than their counterpart in other countries. So I think you may be right, because ambassadors are very busy, so they don't tweet that much. But the next issue is that then why do his subordinate will tweet that much? Yeah, so if suppose that they're very busy, so it may be the case that the ambassador asks them to tweet. But the issue is that why do they tweet with their individual account, not the delegation or the institution's account? So I think that might be one answer to your question. Yeah, I think for Shenwei's question, I think it's interesting that we can do some network. And then I think I would like to highlight that there's a hierarchy among those ambassadors, and very appreciation for Professor Fu's insight. If you check, yeah, I'm not able to log it now, but if you check Hua Chunying's account, so she follows 218 accounts. Most of them are diplomat accounts. And for those diplomat accounts, they are ambassadors' account. It's not individual diplomats' account. So it's very interesting. If you check it, and you can see that for those ambassadors' accounts, they will have at AMD, and then there is their first name or last name. So indicating that this is an ambassador's account. And previous research has already followed, follow other Chinese diplomats' accounts, so we try to use them. And then we also look into who they are followed. So you can see that almost every diplomat account follow Hua Chunying's account. But not every account follows the other office account. Office of the spokesperson, yeah, something like that. So I think there definitely is a hierarchy, and there is a distance between those accounts, and then we can quantify them. Here, of course, we don't quantify them because remember that we have very limited number of individual accounts. So if we separate them into different categories, then yeah, you will just have a few observations for each category. Yeah. So that's why I just categorize them into three types. But probably we can do some more analysis regarding the distance between those ambassadors or diplomats. Yeah, thank you very much.
Thank you, Wenqin. I see a great potential for your project. To me, one fascinating point about studying diplomats is that especially about text analysis, is that they choose words very carefully. This is a different species of animals. So I actually agree that for Muro and you, I mean, this is a particular type of people that next time you study their language, it's very interesting because they choose words very carefully, but in the meantime, they convey meaningful messages. But what does that mean? This is not ordinary people. So I really see the great potential of training a model, studying and learning how diplomats express their opinions. Yeah.
Yeah, I also like the study a lot. It's very elegant and it's very theoretically sharp. What I was thinking is the focus on they tweet or retweet for promotion, right? So that's kind of the primary explanation. And currently the outcome is basically the number of tweets. So I'm wondering if there's a possibility to further distinguish the pathways that this volume of tweeting/retweeting leads to promotion. And I can think of two possibilities. One is they want to use the number of volume to increase their visibility, or in Mandarin, 刷存在感. So that's one mechanism. An alternative mechanism is that they're not just merely trying to increase their visibility, but actually signaling loyalty, which is, I think, implied in your study, but not actually tested. I do think there are a couple of ways that the signaling loyalty could be measured. One is following Dr. Lee's suggestion, thinking about the retweeting network, right? So let's say you have a higher hierarchy than I have. Then I would probably retweet you, but you would not necessarily retweet me. So constructing that, at least that kind of dyads, and see the proportion between retweeting one side versus the other, I think that's one approach. Another approach, which is probably more network analysis, and all the network experts here can correct me, is some kind of in-degree centrality versus out-degree centrality, or a more advanced version, basically some kind of directed network centrality, whether it's like PageRank or whatever. Another possibility is to look at the text. As Dr. Zhang was saying, the text could signal what the meaning is, going back to Dr. Sato's suggestion yesterday. So perhaps some kind of topic modeling and seeing if the ambassadors in, for example, non-OECD countries have a higher proportion of topics that are related to patriotism or national loyalty. Perhaps they have a stronger incentive to do that, whereas the ambassadors, let's say in OECD countries, they have other focuses because they're so busy and they have like foreign relationships and they also have domestic things. Perhaps by triangulating all these types of evidence, it could give an even deeper insight to this very fantastic study.
Should I answer that? So yeah, thank you for the comments. I think those are very promising way to go. I think for the first part, we did not test our mechanism or argument directly with the data, and we need to find some more data to support our argument for the mechanism about loyalty or visibility. Yeah, I think, and thank you for giving more description about a possible way of exploring this kind of mechanism by looking at the network data. And I think some studies already done the network data, but they haven't looked at the retweeting network. So probably I will just look at that retweeting network to see whether there is the pattern that you suggested. And at this moment, I can give you one interesting finding, because I remember that we have three main accounts for retweeting. And although Zhao Lijian tweet a lot, but those ambassadors or those other diplomat accounts did not retweet Zhao Lijian's tweet that much as the other two. So that might give you some preliminary evidence for the possible reason why they retweet much less. So they only retweet Hua Chunying or the office account. So that's one. And the other, we do have the preliminary analysis about the topic, but because I'm not very familiar with the topical analysis, so I decided not to present them here. But if my co-author is here, then he was not able to be here. But yeah, maybe we will incorporate those. So it's about nationalism, it's about COVID-19, it's about economic development of. Those are about those tweets are about those issues. So it will be very interesting to see what kind of institution or other diplomat account will tweet differently for those topics. So we will put them back. Thank you very much.
Thank you.
If further questions, please have discussions during lunch break. Okay. So thanks again for Dr. Wu's excellent presentation. Okay. So now we have a lunch break, and please come back at 1:30 in the afternoon. Thank you.
Good afternoon. It's on time, 1:30. We're going to start a new section. This session is a little bit different because we're going to talk about underground war. Okay, it's very interesting that when I first invited Professor Xiao to our workshop, he shared with us the topic. I said, okay, then I can join you, and we can form a panel talking about a different thing. Okay, and let's can compare how things are different, underground versus the nomadic sea, which most of you already addressed over the past sections. Let me introduce Professor Xiao. Xiao Yuan is now an assistant professor in the Department of Communication at the University of Washington, where he also got his PhD in sociology. And starting July or August? July. He's going to be assistant professor at the Yale University, the Department of Sociology. Okay, in my opinion, he's really the rising star. Although he's a very humble person. Because we graduated from the same university and actually the same department, he always called me, in Chinese called 学长. In Japanese called senpai. Okay, there's no such term in English. You can see the cultural difference. English only call senior fellow. Okay, so I think he's a very decent guy to talk to. We really look forward to your talk.
Well, thank you, Dr. Zhang, and I would like to thank all the organizers for inviting me to this very inspiring workshop. I've learned a lot over the past day, over all these sessions. It's a great honor to be here. Today I'm going to talk about multiplex networks of gang online and offline, conflict dynamics in the digital age. So there's a lot to unpack over here, and especially I would like to talk about a mixed methods approach. So the overarching idea, which I think was also brought up in yesterday's session, is how do we extract meaning from the statistics that we run either on big data or from simulations. And I think one of the ways to go is to conduct mixed methods research, which means combining quantitative with qualitative analyses in the same project and linking them together. So that serves my interest quite a lot. Here's kind of the structure of the talk. I'm going to talk, well, I think Dr. Zhang already introduced me, so I'm going to skip this part really quickly. I'm going to talk about the theoretical motivation for this empirical idea of gang online and offline networks. And I'm going to introduce this mixed methods abductive approach, which seems like a fancy terminology, but I do think it has its merits. I'll talk about results and the general takeaways. So I kind of jump around a lot of different disciplines. I got my degree in sociology. I got a master's in statistics. I'm a communications faculty, and I'm jumping back to sociology. So, which I think is a kind of sample of computational social science. It's interdisciplinary, draws perspectives from different fields, and that's, I think I benefited a lot. I'd like to talk about a little bit about my research focus and how that informs this specific project. So I study a lot of digital media, social networks, collective action, as well as quantitative, and recently I love to do mixed methods research. So a sample of kind of the other research that I do, for example, questions on how does social media affect protest mobilization? How do religious ideas spread through social networks? How can we effectively use qualitative data to challenge quantitative results. And with that, this particular presentation kind of reflects these cornerstones of my research career: digital media, networks, qualitative and mixed methods, leading to this project of using a mixed methods approach that explores online and offline conflict dynamics through social networks in gang conflicts. This is with Dr. John Laverso and Dr. Andy Papachristos. It appears in the American Sociological Review, and that paper has much more details than in this specific talk. I'd love to hear your comments and thoughts about it. So let's jump right into the general questions of this specific paper. So how do we use a multiplex network approach to understand online and offline gang conflict? And that's a kind of general question of the linkages between online behavior and offline behavior, which I'm going to introduce a little bit. That's the kind of theoretical question. The methodological question here is how can we develop a new mixed methods abductive approach to synthesize quantitative and qualitative analyses from digital data. So this approach is especially suitable for digital data. Now you might think, hey, what are all these fancy terms? What's a multiplex network approach? And why do you call it a mixed methods abductive approach? So I'll try to walk it through, and hopefully I'll explain it sufficient enough and good enough with my explanations. All right, but let's talk about the context. Although the study is about gangs, it fits in the broader social phenomenon of online and offline correspondence. This correspondence appears, for example, in protests, like in the Black Lives Matter protests in the United States. It also links to, for example, when Donald Trump talks about the streets, the protests. Here's a tweet by Donald Trump talking about Black Lives Matter and calling them thugs. So you see that these offline protests also correspond to what people are doing online. How do they describe the protests? Of course, this also appears in other arenas of online and offline behavior, for example, war conflict between the Israelis and the Palestinians. The fighting not only occurs on the streets, but also on social media, with both sides trying to taunt and attack one another. All this is to say is that this is a general phenomenon, although I'm studying it in the context of gangs. Of course, specifically in the arena of online and offline conflict, this already encompasses many, many types of group conflict: ethnic conflict, political conflict, and religious conflict. In this case, we study gang conflict, which draws from research from Jeremy Lane, who talks about the digital street. What's the digital street? It's an online space, basically, that allows gang members to initiate contact 24 hours via digital media. So before I get into the next couple of slides, here's a little disclaimer / warning. There's going to be some profane, even racist or sexist language in the presentation materials. And this is not because I'm racist or sexist, it's because it's part of the nature of gang language and culture. And I want to stay true to the data, so I need to represent the original data to illustrate these dynamics. I personally do not endorse any of the language. This is for the purpose of theoretical illustration. So here's a little example of what gangs are doing online. So this is a Facebook post, and one of the primary gangs in Chicago is called the Latin Kings. And this is a graffiti of the gang Latin Kings, which is posted on Facebook. There's the post posted by a member of the Latin Kings, and then you also see a taunt by the rival gang. What do? They flip the token of Latin Kings upside down, which is basically a taunt. Of course, the taunting does not end here. Another rival gang member says, I'm not going to read it out, but it's some profane language that taunts the Latin Kings. A Latin King gang member responds by almighty King love. It's a king's world, and you're just going to all die in it. So it's a reply taunt. So this is just a snapshot of what online conflict looks like, and needless to say, there's a bunch of offline conflict between gangs involving shootings, involving physical contact. So there we have two pieces. Online conflict, like these taunts. We also know that there's offline violence. Now the question is, how do we link them together? And in this context, there's actually not conclusive evidence. It's a debate. There are two sides that argue about this. On the one side, people say the online space provides greater opportunity for negative interactions, and these negative interactions could inflame gang wars in the real world. In other words, it's a linkage argument. It's a diffusion argument. Offline conflict diffuses to online and vice versa. The other side says, nah, none of that. It's performative. It's slacktivism. Online conflicts are performative and not related to offline conflict. You also see this argument in the arena of social movements. People click on social media, but they never go to the streets. Or in Mandarin, 万人响应，无人到场. So you can see these arguments are pretty general in the sociological literature. What we bring to this question is a different approach, a network analysis approach on online and offline correspondence. The critical question to us is not whether there is correspondence between online and offline conflict, but with whom do these conflicts occur? I'm going to explain this a little bit more. It might seem a little bit vague here. So it's not a yes or no question. Yes, there's correspondence. No, there's not a question. No correspondence. But it's a relational question. Who conflicts with whom? Which targets are you targeting? And that is a network relational question. So here's a little kind of illustrative approach. With whom is there conflict? So let's say there are three gangs, gang 1, gang 2, and gang 3. And the lines represent conflict relationships. There's a conflict relationship between gang 1 and gang 2, or you can think of social group 1 and social group 2 in a more general language. There's no conflict relationship because there's no line between gang 1 and gang 3. So this already brings some new insight. It's not like there's generally online conflict and there's generally offline conflict, but it's specific to the targets. Which gangs, which social groups conflict with one another. On top of this relational approach, we provide a multiplex networks approach. Now, multiplex networks, network analysis has many, many, many different applications, like what Dr. Fu presented yesterday. There are many ways to think about this question about gangs. We can think about certain gang characteristics are more likely to generate relationships. For example, large gangs are more likely to have conflict with other gangs, or small gangs may be less inclined to have conflict. That's one way to approach networks. Another approach of networks, which we're not going to do, is shared characteristics. Gangs that have a shared characteristic are more likely to generate network relationships. For example, gangs that share an same ethnic attribute are more likely to be in conflict with one another. For example, conflict among black gangs, gangs that are primarily African Americans, conflict among Latin gangs. Or in the network literature, this is called basically homophily, in a sense. We approach it from a multiplex network approach, so different from what I described above. What's a multiplex network approach? Now, there are many, many ways to do this. In this specific context, the idea is that the formation of a relationship is based on the existence of other relationships. So it's not characteristics. It's about relationships. In other words, relationships generate relationships. What does that mean? Let me give a simple example. Coworker relationships can often evolve into romantic relationships. So let's say there are two people, Jumeirah and Sarah. They have a coworker relationship. They work in the same building. And then over time, they find each other pretty attractive, and they develop a romantic relationship. So, 办公室恋情, for example. This is one example. One relationship, the coworker relationship, generates a new relationship, the romantic relationship. If we accept this premise that relationships generate relationships, this online-offline correspondence question can be turned into a multiplex network question. Do networks of online relationships correspond to networks of offline relationships? In other words, let's look at this plot again. Let's say gang 1 and gang 2, they have an offline conflict relationship represented by the green line. Does that also lead to a higher probability of an online conflict relationship? If there exists offline relationships, are online conflict relationships more likely to be generated? In other words, a green line leads to a blue line, or vice versa. So with this idea, that's the question we're asking. We have multiple types of networks, offline networks and online networks. Do they correspond? Our data come from Latino gangs in Chicago from 2015 to 2016. Why do we choose it? It's prominent. There's a lot of online conflict and there's a lot of offline conflict. So it's a good case to study this phenomenon. We have three types of data. Facebook data on the gang interactions on a prominent public Facebook page. We have the geographical relationships on gang territories, which gangs are physically proximate to other gangs. We also have police data on gang shooting events. So let's say there are people from one gang that shot at people from another gang. That's another type of offline relationships. So we have three networks, in other words. I have the details in the appendix. I can show it in the Q&A if anyone's interested. And the idea is that we have to transform these three data sets into three networks. I'm going to try to go through this quickly, but the idea is that we want to generate an online conflict network based on Facebook data. What we do a very simple approach. We identify gang members based on positive expressions towards gangs. So let's say I love LUV, LK. That means LK, which stands for Latin Kings. So LK love means I love Latin Kings. With this premise, this person is affiliated with the Latin Kings. We can also identify hostility between gang members based on negative expressions. For example, LKK stands for Latin King Killer, which is a taunt. It accuses a member of a Latin king as a killer. We construct a network tie between gangs if there's hostility between two gang members within the same post. So kind of that example that I just showed, right? So somebody said, Latin kings are the best. Another person just basically says Latin kings go and die, whatever. And we do a lot of these things. We construct a weighted network. So this is kind of what the online conflict network looks like. Each circle or a node is a gang. Each line is a conflict relationship between two gangs. The thicker the line, the more conflict there is. For example, in this plot, and I'm not sure if I'm able to use this. Well, okay, yes. So you can see that Latin Kings has a thick line with TS, which stands for 2-6, another gang. You see that thick line over there. So Latin King, TS, thick line. A lot of conflict. We also constructed two offline networks, the geographical conflict network, which we rely on geographical data. So the Chicago police publishes a book called the Gang Book, which documents which gangs are on which streets. We construct a network tie if two gangs are geographically adjacent, which means that the territories touch physically. We also construct a shooting network based on police shooting records. We construct a network tie if there is a shooting event involving members from two gangs. So here's the geographical network. For example, you can see the Latin Kings are adjacent to the SDs. And we do this for every single gang. We also construct a shooting network, which, for example, you see that there is a shooting event between the Latin Kings and the 2-6. So LK, TS, there's a line between them, which means that the police recorded a shooting event that involved members of the Latin Kings and the 2-6. All right, let's go through the mixed methods abductive approach. To investigate this question, we do this abductive approach that is especially suitable for digital data. Now the question becomes, why do I have to use mixed methods? Why can't I just do regressions? And then the second, more deeper question is, how's this fancy term of a mixed methods abductive approach different from standard mixed methods? To do this, I first have to define what's a mixed method. Well, some people define the definition of mixed methods vary. Some people say survey plus experiment is a mixed method. Some people say ethnography and interviews is mixed methods. For us, mixed methods, we define it as combining quantitative and qualitative analyses. It's a mixing of paradigms, and that involves different types of research questions. Why do we use mixed methods in this case? Partially because we're studying a very culturally specific phenomenon, gangs. So we're bringing we can't just rely on statistical tests. We need the qualitative analysis to tap into deep cultural context to recover what those statistics mean, including the cultural knowledge from our research team. So before I introduce this mixed methods abductive approach, I'd like to briefly comment on the traditional mixed methods approach. Often what people do in mixed methods is triangulation. What's triangulation? The qualitative analysis is used to support the statistical analyses. It's convergence. And often the qualitative analyses are secondary in importance. You get some main findings from the statistics, and then you dot examples from qualitative analyses and say, hey, this supports our stats. But coming partially from a qualitative tradition, the value is much richer. Often when people do qualitative research, the goal is not only for conversions, is to uncover, to describe, or even critique. That's one of the fundamental values of many qualitative research, and we would like that. And that brings me to this abductive approach. It's using the qualitative analyses to corroborate and challenge the quantitative analyses. The idea of the abductive logic is to uncover unexpected findings. It's not for convergence. It's to find something new. But the question is, how can you systematically find something that is unexpected? It seems counterintuitive. And this paper systematically outlines the steps. First, guided by theory, we operationalize important variables and do the quantitative analyses first. So the order is important here. In this case, we use the quantitative network analyses to test the association between online and offline networks. In step 2, we use the quantitative indicators to select two types of cases, the positive cases and the negative cases. The positive cases using indicators that are consistent with the quantitative analyses, and then we do a case analysis on those positive cases. In this case, we do the cases where we have a lot of offline shooting relationships and there were large amounts of online conflict, so a correspondence case. The negative case, we use indicators that are opposite to the quantitative analyses. We select these cases to challenge the findings. In this case, we have the cases when there were lots of online conflict, but we did not find any shooting events that occurred. Why is that? We do the qualitative analyses on the two types of cases to support associations found in the social network analyses and identify other dynamics that we did not capture in the social network analyses. Finally, and this is probably one of the most important parts, is to reevaluate the findings and draw general conclusions after combining the quant and the qual results. This is called meta-inference in the mixed methods literature. All right, so let's jump into the quantitative results. I'm just going to briefly comment on the methods. We do something very simple, an exponential random graph model. The dependent variable is the online conflict network. The core independent variables is the geographical network and the shooting network. Where you can flip this either way, it's all going to generate the same thing. The idea is to find if there's correspondence between the three networks. And then there's some details on the modeling strategy, which I can do in the Q&A. Like it's a count model, we have structural characteristics and robustness checks. Here are the results. This is what you should be looking at. But nobody likes tables, so I'm just going to say it in words. So here's the summary. We find a significant positive association between the online and offline conflict networks. If two gangs have a shooting event recorded, the expected number of negative interactions between those two gangs increases by 23%. Also, if two gangs are geographically adjacent, the expected number of negative online interactions increases by 75%. So, in other words, the three networks are interrelated. That's our multiplex network approach. Relationships generate relationships. Shooting event relationship, online conflict relationship. Geographical relationship, online conflict relationship. So let's do the positive cases to support the stat analyses. What we do is we find a series of online interactions in the 6-week period around the shooting event between the Saints and the Gangster 2-6. In other words, these are two gangs, the Saints and the 2-6. We find two geographically adjacent gangs with a history of offline conflict. And then we record all these different interactions and do a case analysis. And I'm just going to show a little bit of it to show the idea. So this is a time where we identified offline conflicts. And we want to see whether there's support in the meaning online as well. If people are shooting offline, are they also fighting online? So first, the Gangster 26 says, I chased you, a bona fide STK, which stands for Saint Killer. It's a taunt term. Then a saint replies, laugh my ass out. When did you ever chase me? Never got chased by, and which is a reply taunt, basically. So we do see these online conflict happening when there's offline conflict. And the Gangster 26 says, that's why your boy lit up on Thanksgiving, implying that he was shot. Lit up means shot. And then another saint says, you're all a joke, TSKK, which stands for 26 Killer. Damien is a gang turf, implying that the shooting occurred on Damien Street. So you can see that even with standard English, it's very difficult to decode these things, that's why we need these qualitative analyses to support the cultural context. And of course, English is not my native language. We have the people who are deep in this context to help us interpret this. Okay, I'm going to also show a snippet of the negative cases to challenge our shooting data and Facebook data. So what we find is that through this negative case analyses, we first find that there are shooting events that are not in the police data. We also found the limitations in our operationalization in our online dictionary approach. We missed negative interactions that took place around specific people. So remember, we characterize online conflict based on gang names like Latin Kings, 26, but if they are going against, for example, Steve or against Sarah, we don't find it. We also did not identify gang nicknames. Here's one of the snippets. It's on the challenges of using a dictionary in a highly contextual and rapidly moving cultural analyses. So Latin King, so this is a period where there's shooting events, but there's no online interactions. So the question is, are there really no online conflicts? So Latin King person says, RIP, somebody, the name is gone but never forgotten. Avenue D, finest. We find an additional shooting event that was not in the police data, which says that a person's name was killed at Avenue D. A person says the name rots, and then another gang replied, this person, the name got his crown cracked. So it's the Latin Kings, right? Kings have a crown. The crown is cracked, which signifies this is another taunt that we did not find, we did not operationalize in our data. Again, rots means rotten in the ground, another taunting term. So what do we make sense of all of this? That's the re-evaluation step. The quantitative analyses showed associations between online and offline networks. The qualitative analyses provided even more meat. It supported the linkages by showing taunting surrounding the violent exchanges offline. We showed that in the positive case analyses. But the qualitative analyses also challenged the operationalization of our online and offline networks. We missed shooting data that is not in the police data. We found that some kind of shooting happened. Somebody got his crown cracked, not recorded in the police data. We missed negative interactions based on the taunting on gang members' names, like name, rots. But the reassessment here shows that there are missing linkages between shooting events and online negative interactions. So in the negative case analyses, we find there's a shooting event, and it's a taunting. We just didn't capture it. In other words, we have a missing data problem, and our estimation is an underestimation of the actual effect between online and offline correspondence. So in general, it supports our general framework of multiplex networks of online and offline conflicts. So what do we make sense of all of this? What's the takeaway? I guess that's the multi-million question. So rather than understanding a yes-no question of whether there's online behavior correspondence with the offline world, Perhaps a more fruitful avenue is to not inquire whether correspondence occurs, but with whom correspondence occurs. In other words, networks generate other networks. And this multiplex network framework can be used to understand other types of online-offline correspondence. For example, digital activism, as Dr. Lee was talking about in the morning, and street protests. In addition to the theoretical applicability of this paper, the mixed methods abductive approach can also be used in a variety of settings. You use the qualitative analyses to uncover mechanisms and also to challenge the quantitative analyses. In this case, what we found were additional contexts, the cultural specific languages, the gang symbols, the neighborhood streets like Avenue D, Damien Street, and prominent gang members. There are multiple mechanisms where people can taunt each other online. You don't have to taunt the gang name. You can focus on specific streets. You can focus on specific names. This mixed methods abductive framework is useful for basically any project that you want to use as long as you have statistics, because you can select positive cases and negative cases. But it's especially useful for digital data. And why is that? Because with so-called big social media data, you have the large sample size to provide enough statistical power to conduct all kinds of analyses that you want to do. Network analyses, multi-level regressions, you name it. But what's unique about digital data is that the statistics are an abstraction of something that's way deeper. There's rich and deep data for positive and negative case selection. For example, in our case, each Facebook thread, comment, and replies, that can be a case analysis in itself. And we're just throwing away all this information if we only do the statistical analyses. And I think the mixed methods, the abductive approach just recovers that kind of complexity and links it to the statistical analyses. So it's not like you do qualitative analyses there and then you do the quant. There's the linkages based on the case selection. All right, I think I just ran out of time. Thank you for attention. I love your questions and your thoughts. Thank you.
Thank you, Professor Sharp, for such a clear and very insightful presentation. Now it's time for questions. Yeah, because you go first.
Thanks for this great talk. I mean, it's really interesting because, like the use of algorithms for exponential random graph models to kind of predict, I think, edges in some networks, depending on edges in physical networks, right? That's something that I've been trying to incorporate in my research. I haven't done it yet. But I had a question about reverse causality for some of the correspondence, not all. For example, I'm sure the geographic correspondence can't be, there can't be reverse causality there because I think the geography precedes the interactions. But say for, it's probably giving digital media too much, too much importance. But is it possible that the negative interactions could have led to shootings, or is it too much of a stretch?
Well, excellent question. And yeah, around the different talks, I think the question is, what's the direction of the causality?
Yeah.
And honestly, in this paper, we cannot do that because the state of the art here is, it's not even that question. It's like whether there is correspondence, let alone the causality direction. So this is not an answer that's answerable through the analyses, but through the qualitative case analyses, we did find evidence for both.
Okay.
For example, the online interactions often refer to past shooting events, saying that, for example, that's the Saints say, hey, you 2-6, you shot me like 2 years ago, and now I'm taunting you. So they refer back to the histories of offline conflict. Of course, there's also the possibility that the offline shooting event happens because of the online interactions. And the reason I say this is because often the shooting events occur multiple time points over a period. So there's shooting, online taunting, shooting, online taunting, shooting. So I would say in those cases, probably the online interactions fueled the animosity that, although we can test it, there's some supportive kind of smoke in the gun evidence for directions on both sides. Yeah, thank you.
Thanks.
Yeah, fascinating talk. I really enjoyed a lot. So I have two questions. So the first one is for the networks part. So basically you have like three kinds of networks. So, and I noticed that your networks are all undirected, right? I don't know if the data could show there is some direction, like hostility or animosity. And is there any like hierarchical structure of this kind of network? Like we found that there are some center nodes with high importance. Maybe there is some hierarchical structure. And you have like relationship or cases, positive and negative. So let me think of balance theory. I have done that in like adolescent, and we found that enemy's enemy may not be friends in our data set because there should be a hierarchical structure in like adolescent, but I don't know for gangs, like you have a lot of conflicts. Maybe your enemy's enemy will become your friends. Is there any like this kind of balance you can study? The second question is short. Is there any safety issue for this kind of study? Because apparently you have all the accounts like non-anonymous, right? So I don't know. What's your opinion of that? Thanks.
All right, let me answer the safety issue first. So the collaborators that I've worked with have dealt with this issue over time, and in general the impression is I think it's fine. Partially because they have personal network ties to the gangs there. So that's why we are able to kind of uncover some of the deeper cultural context. So I think it's safe in the Latin gangs Chicago space. I know if it's safe in the San Francisco Asian gang space that we don't know. So to your question about it, it's basically you're asking about triadic relationships, right? Like enemies of enemies are ties. So it's an interesting case because most social network analyses talk about positive ties, right? Like friends, like if I'm friends with Dr. Zhang and then Dr. Zhang is friends with Dr. Li, then it's more likely that we're friends. In this case, we're negative ties. So what happens over there? And it goes back to balance theory. In this cultural context, there's no positive ties, basically. Every gang is an enemy, and partially because they're trying to expand their territory. Why would I ever give my territory to another gang? So that said, it does decrease. We do find some evidence of the triadic relationships, and I'm trying to say it over here. Okay, so this thing, which I didn't talk about, transitive weights, that captures that triadic relationship. But in this case, it seems it's positive, which means that if, let's say, Dr. Zhang and I are now enemies, and Dr. Zhang and Dr. Li are now enemies, we are also likely to become enemies. Which seems superficially counterintuitive, but it's often the case that if there's a fighting occur, if another gang kind of joins, it helps establish the masculinity of the gang's status. So by involving in a fight, it shows that we are the tough gang, rather than just staying there and watching. So that's the, and then I think there was another question about whether it's a directed network versus yes, so there are certain gangs that receive more negative interactions than others. It's definitely over there. We did control that a little bit with one of the node covariates, which is gang size. So large gangs, medium gangs, and small gangs, which is the reference category over here, and huge gangs, which is basically Latin kings. But even controlling for that, we still find substantial effects.
Hi, thanks for a very interesting talk. I'll just come back to one thing about balance theory, that nearly all data says balance theory doesn't work. So and you can read lots of articles about that. So let's, balance theory in terms of how it's put in these network forms, the way Harari actually changed Haider's original ideas. But I actually want to ask about the network part as well. I've really got two questions. First of all, of course, the thing you notice about your three networks is that one is a lot denser than the other two, and therefore it's impossible for there to be ties in both networks because there just aren't enough ties. And then one of the other networks you said was geographic, so therefore it must be a planar network, whereas the shooting network is probably not planar, I don't know. So again, that's some impossibilities. And then my other question is that you've used ERGMs. I know they're very popular, But I mean, I would use permutation tests, which I think are far better at doing the kind of things you're trying to do. There's far less assumptions in there, and it works perfectly on valued data, which you could argue about ERGMs and how well they actually work on these. So did you think of using permutation tests? So quadratic assignment procedure for correlation or regression would have been the way I would have gone.
Yeah, excellent question. So yes, so to answer your first question, yes, there's a difference. That's why some of them are weighted networks and then some of them are binary networks. And that's just kind of part of the data realities that we had to deal with. We didn't specifically do permutation tests, but we did use latent factor models, which is a kind of an alternative robustness. You know, and different people have different mechanisms on different preferences on network models. We just kind of went with ERGM because that's what everybody uses, and we didn't want to argue with reviewers.
I've got a strong campaign to stop people actually saying ERGMs is the only way to do it. There are many circumstances in which that's true, but this is not one of them.
I'm just wondering, what is the applicability of this interaction of online-offline networks to all kinds of conflicts? Because the GAN conflicts here are very specific conflicts. What if we change the entity of the conflicts? For example, the US-China relationship. If we treat US and China as the two entities, this would not apply, right? Because if we observe US users and Chinese users on Twitter, they quarrel with each other, fight with each other, that would not lead to US and China actually offline doing the conflict. So I just wonder, what do you think the scope of application of this? Thanks.
Well, I would actually say that it's applicable in quite a few settings. For example, the Israeli-Palestinian conflict, because, for example, there's prolonged war over time, and with these repeated interactions, it is possible to look at whether the offline correspondence relates to the online correspondence. In the case of US-China, depends on the type of conflict networks that we want to measure, right? So if it's specific about wars, then the probability of that happening is a very, very, very rare event, fingers crossed. But if we're looking about a multiplex network idea where there are many, many types of conflict that could happen, for example, cyber attacks. And for example, going back to Dr. Wu's presentation in the morning, whether there's online hostility, either by diplomats or by Chinese social media users or vice versa from American users, it is possible to apply this kind of framework. So it kind of really depends on the operationalization of what types of conflict or online and offline behavior that you want to look at.
Yes, I also wanted to add one more question after that you asked regarding the languages, because I think that the GAN languages will increasing more different types of the letters and to post it on the media. So I mean, how did you catch those increasing different kinds of the GAN languages? I mean, you have an insider there, so she or he may help you to differentiate those, or to identify those languages. But they may have some new languages that are produced by those people. I don't know if there's a chance a lot of people will produce the new languages because they want to express their sentiment. But I'm just wondering, how did you really catch those languages? And then the last question is, I think that they are blocked if you have those languages, right? If you post some kind of languages like hate languages, then you probably will be blocked. Your account will be blocked. Or maybe the data that you collect is from the dark net, or how did you really get those posts?
Yeah, great question. I'm going to answer the second one first. So this is data from the 2015 and 2016, so it's not 2024, where all these social media companies are doing all kinds of basically moderation. That said, partially the reason that also that these kind of social media companies are difficult to so-called censor is because they use gang-specific languages. For example, let's say they find something about I chased you, bona fide STK. You know, it's like STK. That's a specific gang language. Got chased by like a bunny or Boston. You know, these words wouldn't necessarily be picked up by the. At that time, there's no way for that to catch those. I think it's so there's a literature on this in communication that talks about the kind of involvement between users and social media companies playing a kind of mouse and cat game, right? A cat game. So they do something and then they develop these specific languages, and then in our case, going back to your first question, the final product is some kind of language that is able to circumvent the social media companies' restrictions. And then the question is, how do we uncover those secret codes? And in this case, it's not just my co-authors. We recruited a bunch of gang members and asked them to identify, what are the common ways that people use. Well, they work as research assistants, informally. So, this is a kind of personal network type of thing. So, yeah. Well, yeah, it doesn't have. Yeah, we're not paying them to. Anyway, I don't want to get too deep in this, but it's based on qualitative data first to identify, something that's a reasonable operationalization set. Yeah. Well, there's nothing unethical about it, but it's just there's a backstory where you do personal networks recruitment, and then you develop these cultural specific codes, and then you apply them to this specific data set.
Thank you once again. Okay, it's me again. I even don't have to introduce myself. Okay, this is a very interesting project because you listened to my presentation yesterday. I see myself as a social psychology experimentalist, social network person. Never expecting that I would touch on this topic until someday, a policeman, really a policeman, contact me, say, hey, I have the data set. Are you interested in doing anything out of it? So, but of course, I'm far away from being a criminologist, but I'm trying to study the following issue from a network perspective. But let me start with a short history about this. I think Professor Everett definitely have more information to add on. Criminal network is getting more and more important. Actually, visibility in many journals, for example, by social networks, criminology, and journal of quantitative criminology. But still, there are challenges because we know that, of course, from Professor Xiao's presentation, this is very challenging because the data is always the issue. For example, you read the following remark by very famous criminologist Mussolini. He said, data access often depends on trust and prior relationship with criminal justice agencies and fit with law enforcement's priorities. This is true. This is actually the first beginning when the policeman contacted me. She's actually interested in teaching them how to catch a bad guy. Actually, this is not what we are concerned as a sociologist. On the other hand, that of course that even we have data, I mean, we have some kind of target. There are always some challenges. How do we define a network? For example, we know that criminals are definitely included, but what about those who are close to criminals? Should we label them as semi-criminals or suspects? That's another question. Even worse, how do we define a tie? This is always a challenge to criminologists because they will not tell you that they are cooperating, right? So what if they appear at the same time in the restaurant? Can we say that they have a tie? That's another challenge. Of course, that the final related question is validation. Because again, criminal will not tell you what they think. even though they got arrested, they still allowed the lies and twisted opinions. So it's very difficult to verify our theory or finding. Given that challenges, this is still many theoretical questions developed. For example, one of my favorite sociology or criminologist, Diego Gambetta, he wrote a book, and he's challenging the idea that actually when we look at criminals, actually they are more rational than we thought. Why? Because he said that in the underworld, punishment for mistakes and irrational behavior are harsher than they are elsewhere. The decisiveness and brutality of many criminal actions do not numb the cognitive skill required for immediate and reading the sign. I think that's why I make a comment earlier in the morning session to Wenqing's idea is that there's different kinds of people who use words and actually signal very carefully because it's a life or death issue. Okay. But if you look at the literature, I would say that at least there are two things we can move forward. First of all is that every time people study a criminal network, usually they just focus on case. They present a network, they study the structure, but the thing is that how different is it from the normal cases? I think that here we need a reference. And second of all is that most of the time we study criminal network, we focus on the criminal world. It's not easy to take into account the police reaction. And this is also something we can go beyond the case study so far. So let me introduce my first study. This is the study in collaboration with the Coast Guard agency. I raised the question is criminal network different from normal fishermen? Okay, and in what way? If you look at the literature, there are two related debates regarding what kind of strategies that criminals are using to elude police attention. The first one is, blending, which is meaning that, okay, for example, I try to behave like normal people, such that you cannot tell whether I'm a criminal or not, I'm doing bad things or not. And the second strategy is to hide out, totally isolated, segregated from the normal person, such that the police cannot trace from the normality of for example, the maritime activities. So there's a debate. Actually, the criminology find evidence in support of both studies. But here, it's somewhat difficult to hypothesize which strategy is going to be used in the maritime activities of Taiwan. So, but I keep it open. So the data I have is maritime convoyage networks. That means that, for example, actors take on the boat together, and then we just transform the two more network into a one more network data. Okay, so this is common way that network people would do. And if you look at the basic statistic on your right-hand side, okay, and you realize that there are many non-criminals. There are only very few criminals in this case. So this is actually created some kind of imbalance problem in the data set. And actually, the whole coalition network is composed of a large component size, about 48,000 nodes. Okay, and if you look at the data on the links, that I would say you check the average degree of a criminal versus non-criminal. You see that actually non-criminals have way more connected to criminals. But if you look at the strength, well, this is the weighted graph. The weighted graph just means that how many times they converge together. I would say that actually criminals have tighter or closer relationship than non-criminals. So the first question is that this is actually a request from the police. Okay, they said, we are very interested in machine learning. Okay, can you really come up with a model to predict? Because prediction is what they're concerned. Theory is what we are concerned. So per their request, I say, okay, I would give it a try. Okay, to train a model to predict who is criminal and who isn't. Okay, and because the request that I sort of give up on Ergun, not because it's an inherent problem, because just it crashed. Okay, running on a big data set like a 5,000, 50,000 data nodes is really a problem. I even got a chance to try permutation, the same problem. In R, it just crashed. Okay, So I turned to the help from computer scientists. Then I just used the very popular one, graph neural network. Okay, I choose the network by Zhou, and because they try to balance the data between criminals and non-criminals. So here's the structure they have. Don't worry about the complexity of the model. All you have to remember is that the encoder, it is that we import the network, okay, into the machine, and then what the model is trying to do right here is that you see this node generator and no edge generator. What does that mean? Again, because the data is so imbalanced, okay? You have too many non-criminals. If you let the model predict who is non-criminal, he'll just guess it is non-criminal because 98% is non-criminal, okay? So to really curb that kind of situation, they are very smart. Say, what about we sort of balance the data? We create more nodes for criminal and also add edges to the data set. This is how they deal with the balance of the data set. And finally, the model will get the output, which is called decoder, and the decoder will predict who is criminal and who is not criminal based on their network position. So this is the general idea of how the model functions. Okay. So this is the result of the model. I would just first comment that actually the model is somewhat okay. The accuracy is good, but recall is poor. So accuracy means that every time you input the data, it performs quite good, telling you predicting who is criminal or not criminal. But if you look at how well it performs at identify criminals in the real world, it doesn't do the good job. This is the reason actually we didn't publish this part of the work, because it's not really a good performance. But the point I would like to extract from the study is that if you look at the embedding value, embedded just means that this is a vector value representing actors' position in the network. Here is the data I've tried to argue that is it the case that criminals are different or not different from criminals? So by these embedded value, I can cluster them together. If it is closer to 1, I look at the Gini coefficient. If it look closer to 1, and I have strong evidence that criminals and criminals are not different, okay, according to the Gini coefficient. But if they are close to 0, then that means that I cannot tell whether they are criminal or non-criminal. And here's the result we got. The Gini coefficient is 0.44. I think it gives some evidence that the network position of a criminal are not really like the position of non-criminals. Okay, so this is the first step. And the second step, again, because the deep learning model is really sometimes behaves like a black box. We cannot really, well, it can predict, but we don't know how it predicts. Or we cannot know how different criminals are from from non-criminals in the model. So this is another way we do is that we use probably unconventional method we call bootstrap resampling. So the idea is very simple, is that we have empirical network, and we also try to sort of permutate it. So this is the idea also similar to permutation. We randomize a little bit, and then we choose a sample of that. This is called subnet network. This is why we call bootstrap thing. Okay. Then we choose some network statistics to study. Here I choose, for example, the basic network measures: strength of connection, homomorphy, clustering, things like that. So the basic idea is that I would like to compare criminals and non-criminals network with respect to the following 3 network measures. Okay, here's what I found. Okay, for homomorphy, if you look at this distribution of criminal and the distribution of non-criminal in empirical, and compared to the randomized network, I argue that criminals are more homomorphous than criminals against a randomized network. In the paper, we also include, per reviewers' request, we also include suspects, okay? Because sometimes, again, that's the issue of validation, because people think that, oh, you are actually focusing on people who have criminal records, but what about these hidden people? That are hidden behind the screen that really the criminal but never got caught, okay? So we include those some suspects right here who have close relationship with criminal to see whether they will be different from the original result. Turns out they are not, okay? Similarly, that criminals are right here, and compared to non-criminal, criminals are more cohesive than non-criminals. Okay, so here I can argue that probably they are more likely to use the Brandy and what did the other? I even forgot one. Oh, hideout strategy. The hideout strategy more likely to be used than the blend. Sorry about that. Okay. So this is the first study. The second study is on a different case. Okay. This is a real case in Taiwan. It's a drug trafficking group. Okay. And it's from another, not policeman, it's actually the FBI agent in Taiwan. And similarly, that he has the data. And he asked whether it's possible to come up with something out of the thing. And I look at the data, and the challenge is what kind of question can I ask? And I look into the literature, I say, okay, maybe there's one interesting debate that we can answer from the data set. It's about command hierarchy, okay? Why is also an interesting question? Because again, this is a difference between underground and the normal world. We know that in normal business, command hierarchy is always the case, right? You have boss, you have subordinates. But we are asking the question is that what about secret actions? Does it make sense to use command hierarchy? Does that really expose criminals' whereabouts? And if you look at the literature, it turns out that the findings are somewhat mixed because, for example, Natarajan investigated the games in New York and realized that out of 28 criminals, she found that there are 13 levels, okay, in the organization. But on the other hand, people like Erk and Gersh, they examined a higher number of cases, 620 cases in Washington, Baltimore area. They realized that actually it's not the case. Most of the time, the structures are loosely distributed. So we have mixed finding right here, and here I'm trying to figure out whether in the case of a Taiwan drug trafficking group, whether we can find command hierarchy. The data we have is based on telecommunications, okay, intercepted by the FBI. Among members of the drug trafficking group, the size is 8. We have 8 people right here, and the time of interception is from July 1st, 2014 to the next year, 2015. And 8 criminals held 63 phone numbers. Okay, you say, okay, why are there so many phone numbers? Because they try to, the detection of the police. Okay, and they had roughly 4,120 communication. Among them, 560 are phone calls and the remaining are voice messages. You can imagine why they use voice messages. Trying to keep their action secret. So based on this telecommunication records, we map a network who called whom and at what time. So now we can have at least the two network. The first one I call static network. Static network is just sort of like a summary of overall communication records. So here, for example, here A calls B and as well as B calls A. Okay, who calls whom? Okay, but can I really tell who is the boss from the directionality and also the volumes of the directionality? So here, because B calls A more than A calls B, can I say that, for example, A is the boss and B is the subordinate? Of course, you can argue against this one. You say, usually subordinate call more because they had to report, but we will come back to the issue later. Actually, this is exactly why I, analyze the temporal rather than the static network, because static network is all about the number of code. But temporal network, if we split the whole time into different windows, and then the timing of the code may give us some hints, right? And then here we will argue that, well, maybe subordinates call more, but they call later. Because always the case that the boss initiate the call, you do this one, and then later on the subordinate will report what I did. Okay, so timing of this may give a hint regarding who is the boss and who is the subordinate. So based on this one, I analyze the temporal network. Okay. Then the next issue is how we can estimate the hierarchy based on this telecommunication network. And here I draw on a very interesting method actually proposed by physics. They use the idea so-called agony. Okay, so agony is the idea is that based on the principles that boss are more likely to initiate a call to subordinates. Okay, so here is the function that I try to deal with the function Ri minus Ij. Don't worry about this 0.1, and then times EIJ. So what is EIJ? EIJ is actually, sorry, back here. EIJ is actually the calling from, the number of times calling from I to J. And R is the estimated ranking, where smaller r suggests higher ranking. So for example, we know that number 1, number 2, so actually 1 is higher than 2. So here, the idea is that if Ri smaller than Rj, which means I is higher than J in rank, we expect Eij to be large, right? That's based on the previous idea here, is that if we see that cost more cost from B than A, then we expect that B has a higher position. Similarly, we can apply the same equations to temporal network, but we only have to change this Eij into the timing of the call. So who initiated the call earlier, I would suggest that it could be the boss. Okay, so the basic idea is that we try to fit data to theoretical premises. So this is a standard computational approach to test whether the data can reveal the story we propose in advance. So here's the result we have. So for the group of A criminals, if you look at either static network or temporal network, it looks pretty close. Okay, for static network, we estimate a total of 4 levels. For temporal network, we estimate a total of 3 levels. If we look at the ranking position and also behave quite consistently, Mr. Su always at the top. Okay, although there's another Mr. Yang also at the top in the temporal network. Here's another thing I would like to share with you. When I analyze the data, I try not to, of course, in the beginning, I cannot help. I try not to look into the labels the police share with me. Because in the report, it's evident that the police will say, oh, this guy is the main suspect. That one is the boss. That one is the financial support or something like that. I try not to look at the case. I let the data speak and tell me that who the data will think who is the boss. Okay. Now, of course, the biggest issue is validation. Again, I cannot ask criminal who are among you who are the boss. So we just look into the core verdicts, and again, the verdicts will not exactly tell who is the boss because this is not something they are concerned with, right? So, but we did find some scanned evidence. I would like to share with you. The first case is that there's one sentence in the verdict say Mr. Tsai delivered 3 bags of heroin to designated places after receiving the instruction from Mr. Lin. So if you look at the case that, okay, it looks like Mr. Tsai received the instruction from Mr. Lin, maybe the case that Tsai is lower than Lin in the case. But of course, that is on the temporal network, they are equal. But the second one is not consistent because it is the other way around, okay? And finally, we also have another place where the judge, there's a debate in court arguing that they are not sure whether Mr. Lin or Mr. Tsai are the boss. Well, I say, okay, that's good news because here, if we look at this case, we actually put them equal in a hierarchy. So maybe that's another evidence to support our theory. Okay, so this is our second study. The third study is ongoing, but I would really like to share with you the first motivation. This is a study I got inspired a lot, conducted by a professor at Zhongshan University, Ye Gaohua. He actually presented the very first study about network disruption. Okay, this is in the time 1931 to 1945. Back then, is a colonial Taiwan, still governed by the Japanese authority. And if you look at the data, this is on your left-hand side, this is the data of their social network. So here, each node represent a tribe, okay? And what the Japanese government did is to relocate the tribe because they are trying to prevent rebellions. So if the two tribes are close together, they try to break it. To me, this is the very first study that there are people trying to dissolve a network. But it was surprising to me that back in 1931, there's no software at all. We don't have UCNet. It's all about paper and pencil. I don't have no idea how the Japanese authority can realize that we can, make the disrupt into a network. For example, if you look at this one here, this one, you realize actually this. I know it is somewhat small, but you can look at that. The Anurak. The tribe doesn't have a tie to Torama, but if you look at this one here, the Netora and Torama, because they don't have a tie, and the Japanese government say, okay, then you can move together to a new different place. Okay, now look at this one, because Natara, and you can pronounce that, has a tie with Marian. Okay, because there's a tie, so the government trying to break a tie, and this is the case if you look at right here, because now you see that Mara is right here, Natara is right here. They're moving to different places. Okay, so there's an astonishing that way back almost like 100 years ago, how can an authority had an idea to disrupt the network? So it came to me, okay, this is an interesting question. So the question is, how do people disrupt a network? Okay, I think it also have a value in filling the theoretical gap, because in the literature we know how people form a network, but I would say we know little how people disrupt a network, except for the following study by my ex-colleague McBride and his associate. So to me that, okay, also disruption network has some practical values, because for national security and defense, and also my collaborative law enforcement agents always encourage me that I can develop a tool helping their agents to learn how to detect criminals' behavior. I say, okay, maybe I can come up with something for your use. So the idea is that we just draw on network science, because we had already some idea how to disrupt a network. For example, Borghetti, way back in 2006, he provides that idea that to disrupt a network, look at the information regarding centrality, because those are the important nodes. Once you remove them, you disrupt or dissect the whole structure. Of course, that later on, computer science developed even more fancier ways to disrupt a network. You can see some review over here. And recently, there is an astonishing progress by computer scientists. They said that they already have an AI that can outperform almost all kinds of centrality measures. They published this article in Nature Machine Intelligence. So to me, this, I think what maybe as a experimentalist, I can do the following thing is that among many ways to disrupt a network, how do people choose them? Will people work, for example, with AI to disrupt the network? So the idea is that we will provide a real criminal network and then educate participants to learn the basic idea of selection with centrality measure, for example, including the following one, okay? And then ask participants to disrupt the network from the upstreams. First, you can just eyeball the network and just remove them one by one. Or you can just turn to basic network measurements, connectivity, centrality, or arbitrariness, or other things. And finally, you can just rely on AI suggestion, okay? Let me give you, we still have time, let me give you a simple demo, only for fun. Okay, so this is a tool, okay? So here's only the instructions, so let me just skip that. We just tell participants that this is the network we like to remove, and here's the way we to do that. Okay, and again, we tell the participants that there are some measurements you can rely on to remove that one. Okay, let me skip that. Okay, and then here's a bunch of a real criminal network. For example, let me choose the first one, September 11 hijackers. Okay, and already some information. Okay, so this is a real network. Okay, and people can choose, okay, what kind of measure they're going to use. They're going to use their own judgment, connectivity, closeness, arbitrariness, or eigenvector centrality, or AI finder. So let me choose, for example, I just rely on my judgment. Because I rely on my own judgment, there's no information at all. So let me just quickly take this one. Okay, and just gone. Okay, and the computer program will show me how much I score in this case. And the next step, okay, one step at a time, let me try distance right here. Now, if we move this one, you will show that because it's not based on the matrix, so the node size will be in proportion to the matrix. So here, for example, I choose the largest one. Okay, and again, the graph will show me how well I perform. And also, you notice that this is the blue line. I'm sorry, the gray line. The gray line is actually based on the AI. So we are actually putting participants to compete with AI to see how well they perform to remove the nodes compared to AI. Okay, so here it's still an ongoing project. We haven't got a chance to collect the data, but still testing. So any comments or feedback are welcome. Finally, let me conclude this my study and also the next section of the pen. Okay, there's a new term called computational criminology. It's not invented myself because I saw someone just label himself as like that. I said, okay, I can use that term. I see a great potential. First of all, just because the computation methods already show you that there's fancy ways to do that. And the second of all is that availability of digital data. I believe that law enforcement agents are working very hard to digitize their records. So in the near future, I think there's still opportunities to work on both sides. Still, challenges remain. Of course, validation is always the case. Second of all, connecting to theory. This is a more practical challenge I'm facing. For example, again, as I mentioned that in the interaction with the law enforcement agencies, they are not cared about theories, but we care more about theories. So there's always a tension that our goals are different. So when we collaborate with practitioners, we have to take care of both. How can we meet their goals as well as meet ours? Otherwise, they would like to share the data with us. So that's the challenge we have. Of course, the ethical concerns. As long as AI becomes more powerful, being more applied in the law detection area, but then that also causes some ethical issue. For example, abuse of AI weapons, and also some law enforcement agents might worry that they will lose their job because AI could do a better job in detecting who is a criminal and not. So these are all issues that we are facing in the future. Okay, with all that, thank you very much. Oh, I have to just host the discussion myself.
Another fascinating talk. I really enjoy a lot. So I think I have some idea for the third project you just mentioned because I think it's easy to formulate it in computer science or apply mathematics field because you have a specific goal. Maybe you want to disrupt the network. So I think it's not hard to find your goal or your target. You can make it into a target function. I think maybe if you can formulate it, then AI should be way better than human because this is like a small graph, but after you increase the size or the number of nodes at edge, then I think no human can possibly figure that out. But I think there is a potential for study like who can do better, like demographics feature of human or the settings, but I think still be interesting. But I think it's easy to formulate it into a mathematical or computer science problem. And for the second project you just mentioned, I'm wondering about the validation part because you said you have the ground truths like from the police office maybe. So I'm wondering like the way you put it into a static and a temporal network, would that affect your validation? Because I know you said you have the truths. Have you ever tried to validate that? Is there any accuracy for the second project? Thank you.
Yes, large graph is never my intention. I totally agree with you. I mean, it's so reasonable that humans cannot really disrupt a large network. They have to rely on computers. So this is the particular reason I choose a small size network. But in the meantime, not just for law information reason. Actually, it's another reason I'm investigating the project for cognitive network. As I mentioned, that we know so little about how people disrupt a network. And so I'm really interested in what kind of strategies, and maybe they are biases, of course, not humans are not perfect, but what kind of biases, what kind of fallacy they may fall into when they try to disrupt a network. That's the thing. This is a more general question I'm interested in. And of course, the second study, I'm using both a static and a temporal network just only for robustness testing. Again, it's that I don't have strong ground to validate the truth. So I'm saying, okay, what if you use static and static? If they come up with similar result, then I probably feel safer for the conclusion. Yeah. But of course, validation is always a big challenge in criminology. They are replicated, but I also believe that just because in the old time, this is probably not the most effective way. There must be some missing cases, So, yeah, but still amazing. I mean, back then it's only paper and pencil.
Yeah, it's amazing. And there's also data on there were a lot of rebellions by the
Aboriginal people
against the Japanese. So it could be empirically tested also a measurement of the outcome of collective action. So I don't know. I mean, this seems huge potential.
Yeah, actually, the Professor Ye is actually the expert. Unfortunately, I contacted him for further, investigation, but he wasn't quite responsive. Yeah, I think he should shift his attention to the other projects. But still, it attracts me, and it really intrigues me that. Yeah, especially in the old time, right? Still, people have that kind of intuition how to disrupt a network, even without the help of computer. That's at the very beginning of computation social science.
CIGO also had some kind of general recommendations on strategy, qualitatively, and it would be great to see it.
Yeah, maybe we can talk to Ye Gaohua.
Thank you, Professor, for your inspiring talk. I'm wondering about a technical problem in the first research about how do you train the graphical neural network to predict the criminal and marine workers, because you got a large network. Do you divide it into subgraph to training your model or how can we apply these methods to other application? Yeah.
Okay, we only focus on the largest component. So this is a connecting network. So there is no isolation. But if you look at the statistics, it's not a problem at all because.
But when training machine learning algorithm, is it does it require a lot of training data sets or how can this algorithm learning just from a connected network?
This is exactly the art of a graph neural network. I know little about that, And that every time I talk to computer science, it seems to me it's case by case. Every time you ask me, can you predict how well the model performs? You said it depends on the data. So it's not like a running statistical model that you put it and then you come up with a result. They're going to test it. Sometimes test the so-called hyperparameters, which means that sometimes it will make a difference. So there's so many uncertainties or undecisiveness going on. This is actually the struggle I have when working with machine learning people. But in any case, that it just works. Okay. For more information, you can talk to Zia. So Zia, he's an expert in that area.
I have two quick questions, probably. Yes, the criminal projects. I'm wondering, do the criminals, they know each other, or they are actually manage different cohort? That is my first question. And because I think that there are probably different types of the criminals. Some are, they are financial criminal, or economic criminal, or they are doing something really bad. I mean, so that's what I wanted to know. And the other one is when I see the accuracy and also the recall scores, I'm wondering why you do not consider about other kinds of the evaluation values that could be produced from the machine learning, usually using the confusion matrix. And so maybe you could also get the F1 score or the precision scores. And why you only wanted to report the recall and also the accuracy?
Let me start the second question first. I think that is a golden rule. I mean, accuracy is the first threshold. Okay, we passed that. But the second one, recall, is also important because we got reviews challenges that your model just sucks. Your model cannot really identify what the law enforcement agency cares that we can successfully catch the bad guys, but your model only can catch what you try to catch. That is the accuracy issue. So we already have the problem. I mean, we don't want to even twist the metric such that to make our model looks nice. So we already have that problem. So that's what the standard. You probably know that this is standard rules. Our F1 is not a high two. Yeah, that's actually the challenge we face. Yeah, and for your first question, again, validation. Criminals will not tell you that we're here and we corroborate each other. So we only can judge by the time they, board the same ship repeatedly. That's another issue. Is that every time they got caught, the police would interrogate everyone. But again, there might be some plots going on. You don't really know who is in charge. Maybe it has been pre-planned, and they were gonna have some, stories say, okay, once we get caught, you got to tell who is who, and we will not reveal who is the boss. That's the kind of the schemes already keep in mind. So it's very difficult to know from the integration. This is the whole challenge about studying the underground world. Okay, we run out of time. Thank you so much for this session. You can just. Okay, welcome back. Now we are going to start a special session. Okay, for those of you who are interested in where to publish your work, especially over the past 2 days or including today, we will in discussion about the challenge of computational social science. Well, sometimes it's very difficult to publish in our own fields. Okay, and here's a great opportunity to listen to the introduction of a new journal. Okay, let me briefly introduce Professor Kamihigashi Takashi. Okay, he is an economist. He got his PhD from the Department of Economics from Wisconsin Madison, right? Okay, and he is a theoretical economist. In economic, by theoretical, it just means mathematical economist. Okay, Okay, very serious stuff. Okay, it's now serving editor in 2 journals. The first is International Journal of Economic Theory, which is his special field. I mean, his professional field. The other is just the one he's going to introduce is Journal of Computational Social Science. I also want to mention that he started a Center for Computational Social Science at Kobe University in 2018, right? I would say it's probably the first in Asia. So that's welcome, Professor Kamibashi.
Thank you very much. I should press this. Okay, so maybe he talked about the first part of my presentation, but I'll talk about myself, the Journal of Computational Social Science, and maybe other thoughts, but I don't think I will have enough time for that. Anyway, thank you very much for giving me this great opportunity to promote my journal, and yeah, so I really have to promote it. It's been doing well, but let me start with myself, and yeah, so as he mentioned, I'm originally an economist, so I got my PhD in economics from the University of Wisconsin at Madison in 1994, a long time ago, and my fields of specialty in economics are like dynamic optimization and almost mathematics and macroeconomic dynamics and Markov processes and game theory. And I got the Nakahara Prize from the Japanese Economic Association, and that's one of the really good prizes for economists in Japan. And as he mentioned, I'm currently the editor-in-chief of the International Journal of Economic Theory, and I'm also associate editor at various journals like this. So I think I have a lot of experiences as an editor and also as an associate editor. I'm currently the president of academic society called the IEFS Japan, International Economics and Finance Society. So there is an international one, but I'm the president of the Japan subsidiary, and I'm also a member of the Science Council of Japan, and I'm also a member of the executive committee of the International Economic Association, which is like the society of economic associations all over the world. And so I'm almost like a mathematician. So one of my recent papers was about interchanging a limit and the integral. And there are some people with mathematical background, so I wanted to mention it. So does anyone know that exactly when you can do this? So when I do probability theory or dynamic optimization, in many cases I have to do this operation. I have to interchange the integral and the limit, and it's actually really hard. It was impossible to find the exact condition under which you can do it. So I clarify the exact necessary and sufficient condition. So if you are interested, please take a look. And also it's not so recent, but I also have a paper in the Journal of Applied Probability, and it's a very good journal in math, and it's about the unified stability theory for classical monotone Markov chains, and which makes no sense to you, I guess, but it's about the stability of Markov chains, and stability of Markov chains is actually related to machine learning and Markov chain Monte Carlo methods as well. So, and there are Bayesian learning methods. And stability of Markov chains is really related to artificial intelligence. And in many ways, ChatGPT is a Markov chain based on the current state of words or a sequence of words. It predicts the next word. So it's a Markov chain. So it's closely related to machine learning too. Okay, and as a computational social scientist, during this time period from 2014 to 2017, I got involved in a project with computational social scientists, including Yoshimichi Sato. So he was one of the first computational social scientists I met and I admired, actually, Fujio Toriumi and Karo Endo. And there was a community on computational social science in Japan, and it was starting to grow. And we were talking about how we can let it grow more rapidly. And I was an economist back then, and I thought that at the time, most of economics is computational anyway, so economics can be part of computational social science, but I was totally wrong, actually. But in any case, so there was a question about how do we recruit students and possibly researchers to computational social science, and we were talking about that, and particularly for me, my answers to that question is, well, maybe we need a formal academic society for computational social science. And maybe there should be a research center for computational social science so that we can recruit students. And also there should be a journal specializing in computational social science. And that was really important because, say, if you work in computer science and if you deal with social data, then it's really hard to find a good outlet for you. And there should be a journal that accepts papers on computational social science. And also, we are talking about writing a textbook on computational social science, but in Japanese. And we also talking about we should have a stronger connection to the international community. And that's one of the first things we did. So we invited some important people and we organized some events, and so I made a Center for Computational Social Science in Kobe University. So that was the first research center specializing in computational social science. And we also have a YouTube channel, and there are English videos as well. So if you're interested, please take a look. And we established the Society for Computational Social Science of Japan in 2021, and I'm currently a vice president. And we also wrote a textbook, not really me, I'm one of the co-authors, but Fujio Toriumi was the main author and editor of the textbook. In any case, we also published the textbook. So we had these lists, and we did most of them. And I also made the journal, the Journal of Computational Social Science. And many people ask me how that happened. And back then, I was talking with the publisher, Springer in Japan, and they were interested in making a new journal. So they always ask me, can you make a new journal? And I gave them some ideas, but they didn't like any of them. You know, I told them there might be I could edit the journal in theoretical economics, specializing such and such, and they were not interested at all. But then so I met these people working in computational social science, and these people as well, and I told the publisher about computational social science, and they were suddenly excited about hearing about computational social science. So I wrote a proposal, and it went through, and it was launched in 2018. So for the rest of my talk, I'll probably concentrate on this journal. Okay, so these are top 10 most cited, top 10 cited papers from the Journal of Computational Social Science, and these citations are from the web page of the journal homepage. So if you go to Google Scholar, these numbers are much higher, like twice or 3 times higher. But here, I just took these numbers from the homepage. So the most highly cited paper is Conspiracy in the Time of Corona, Automatic Detection of Emerging COVID-19 Conspiracy Theories in Social Media and the News. And the second one, Network Models of Financial Systems, a Systemic Risk, a review. The third one, Misinformation, Manipulation, and Abuse on Social Media in the Era of COVID-19. So COVID-19 is one of the most popular topics. and social influence and unfollowing accelerate the emergence of echo chambers. And enhance news sentiment analysis using deep learning methods, and bots and online hate during the COVID-19 pandemic, case studies in the United States and the Philippines, and partisan public health, and so I'm not going to read the whole thing, but so these are highly cited papers from my journal. And so I just made that word cloud to see, how the journal looks like. So here is the word cloud of all the abstracts from 1918 to 2024. So it exactly looks like computational social science, I think. Doesn't it? Model, data, network, social.
Is this sociology?
Social media. Online user. But from 2018 to 2020, it looks like computational social science. So what I thought was that if I do this for 2021 to 2024, I might get COVID, a pandemic, something like that. But they didn't show up here actually. So model, network, data, and so these was a really common in this journal. There might be something wrong, but so maybe I have to do it again, but so it's surprisingly similar. Network model data study social media, like this, just like this. Okay, and so yesterday there was a discussion about country bias in many journals, and so I get submissions from all over the world, but India, lots of papers are coming from India, mostly using machine learning, applications of machine learning. And I also get lots of papers from the US. I also have many papers from Japan, especially because at the beginning of the journal, I really had a hard time getting good submissions. So I had to ask people around me to submit papers. So it still has an effect. And so I get these papers. I also get papers from Pakistan, Germany. Actually, this is internal data, so it's not supposed to be public. Okay. Really, so it's really internal data. And I also get submissions from Iran, China, Netherlands, and Turkey, and really many countries. And so it pretty much covers the whole world, not really, but mostly. And reviewers come from the whole world actually, so almost the same. But for accepted papers, we really have a different picture. It's like this. So I get many papers from these areas, but none of these papers have been accepted yet. So there may be some bias, but I'm not really sure. That may be about the quality of papers. And in terms of numbers, many papers are accepted from the US, Japan, UK, India, Netherlands, Germany, Australia, Italy. But some papers are accepted from these countries as well. Turkey, Taiwan, Singapore. There should be more papers from Singapore actually. But Nigeria, Korea, Greece, and Bangladesh as well. Okay, and there was also a discussion about papers using country-specific data. So many papers used data from the US or Twitter data and things like that. And there are many papers from Japan, so many of them use Japanese data as well. And there are papers using Indian data Russian data and data from Hong Kong, Australia, and UK and Mexico and so on. Yeah, so there are papers using data from Bangladesh and Brazil as well. It's Estonia too. Yeah, so country-specific papers come from these countries. So these countries are colored by the corresponding author of each paper. So, no, sorry, yeah. These correspond to, yeah, so here's what it says. It says, so for each country, I count the number of abstracts that contain, say, the United States or US or some variations. And I also count the number of abstracts that contains Japan and so on. Yeah. So here's the country map. So papers published in the Journal of Computational Social Science covers data from lots of countries. I think as far as I know, there isn't any bias, or we never say it's a minor country, and the analysis of data from this minor country is not really relevant to the rest of the world, or anything like that. So yeah, but on the other hand, it's hard to find reviewers for such papers. So yeah, that's actually the hardest problem, and many people have that problem. Especially people in this field are very, very busy, and there are many papers to review, and actually, I don't know, one in 5 or only 1 in 10 people can, agree and submit their report. So it's really hard. So when you are asked to review a paper, please don't decline, and please accept and submit your report by the deadline. Yeah. Sometimes it happens that a few people accept to review the paper, but none submits their report by the deadline, and none delay by several months, and that kind of thing unfortunately happens. Yeah, so please don't do it when you're asked to review a paper. Okay. Yeah, so there are many country-specific papers. And let's look at what they are. So from India, so there are 5 papers dealing with data from India. How self-disclosure in Twitter profiles relate to anonymity, consciousness, and usage objectives across cultural study. Yeah, but these authors are from Japan and the US. And the second one, using Indian data, is, so they are from India, predicting applicable law sections from judicial case reports using legislative text analysis with machine learning. And also perception of COVID-19 vaccination among Indian Twitter users, computation approach. Okay, and there are papers that use data from Hong Kong, the intertwined cyber balkanizations of Facebook pages and their audience, analysis of Facebook pages and their audience during the 2014 Hong Kong Occupy movement. And I think it's the same paper, right? It's the same paper. Yeah. It's the same paper, but the third one, yeah, so this paper gets cited quite often. Another systematic approach. Oh, I forgot to mention a very important thing. Yeah, so we got an impact factor of 3.2 last year. Yeah, and 5-year impact factor is 2.9. And yeah, so after these impact factors were announced, I started to get increasing number of submissions now. Where was I? Hong Kong. Yeah. And a paper using data from Kenya, but these are all from the US. Identifying social media user demographics and topic diversity with computational social science, a case study of a major international policy forum, and Iran. Yeah, so the Kenya one was cited 10 times, and the Iran paper was cited 4 times. News loopholing Telegram news as a portable alternative media. And Colombia, predicting the probability of finding missing older adults based on machine learning. And yeah, so I think, yeah, it's a serious issue, I think. And also from Bangladesh, this one was cited 19 times. Random forest analysis of 2 household surveys can identify important predictors of migration in Bangladesh. Okay. Yeah. So actually, I mentioned that I'm an economist. Yeah. So the Japanese economy used to be doing really well, like back in the 80s and 90s. And those days, if people used Japanese data and submit their papers to journals in the U.S., they were received fairly well. But these days, the Japanese economy is not doing really well. It used to be the second largest economy, but now the 4th largest economy, and people don't take it very seriously. And so if Japanese economists use Japanese data to do some interesting analysis, so many journals react by saying that but it's a very special case and it's not relevant or something like that. So we always face that. Okay, yeah, but yeah, it's interesting. And what's interesting in these papers is that in some countries you can get very special data, and like in many European or Japan or the US, there are various privacy concerns, but in some countries people can get highly sensitive data and use it for research. I'm not sure if these papers really use sensitive data, but I have seen many interesting data, and if the data itself is interesting, it can be an interesting paper if the analysis is done properly. Okay, okay. And so from here on, I think I will talk about what people want to ask me, but never really ask. Yeah, so this is the distribution of days to final decision. This is also internal information, but I have all the data. But unfortunately, I only have a table of false date of submissions, date of submission, and the date of final decision. So I only have those data. Maybe the publisher has more data, but I only have the table for submission, the date of submission and the first decision. So here's the distribution, and you can see a large spike here. So many papers are desk rejected. Also, this distribution is for papers submitted after the first date of 2022. So it's a fairly recent graph. And I also exclude papers withdrawn and papers under review. And there are many papers under review currently. Okay, so days to final decisions. And days to acceptance. If you're lucky, your paper will be accepted, and in that case, mean is 153 days. I'm not sure. This number should be smaller, but yeah, that's what we do, and the median is 141. So typically, I think you will never get the report within a month. It takes at least a month. It takes a few days, at least a few days, to get to the editor-in-chief. People have to do technical checking, and they usually spend more than a few days, and papers go back and forth between those people and the authors, and it takes at least a few days. And then it usually takes a few weeks to find referees, and it usually takes at least a month to get their reports. And so, yeah, usually the most typical case would be to get the report back like 1.5 months maybe, and then you will spend 1 month or so to revise your paper and send it back, and then you will wait another month to get the report back. So that will make it like, yeah, these numbers. And days to rejection. This one is much faster, so the mean is 25 and median is 8. So most of these papers are desk rejected. Okay. Let's see. Oh, and what's important here is the acceptance rate is 0.22, and the rejection rate, including transfers, is about 0.78. So it may not really look good. It may not look really good, but most papers are actually desk rejected. So if we exclude these papers, so if your paper survives the first 30 days, that means if your paper is not desk rejected and sent to reviewers, and then the acceptance rate is more than 50%. And yeah, so as you can see, many papers are desk rejected, but they're not really about computational social science. And after getting impact factor, I receive all kinds of papers, and some papers include no analysis at all, and only words and criticizing AI and things like that. And some papers are only about machine learning and performance improvement and things like that. So there is no social science. Yeah, but if your paper is about computational social science, it's likely to survive the first 30 days, and you will go into this category. And in that case, the rejection rate is less than 50%. So it's 0.43. It's really low. So if your paper is sent to reviewers, you're more than likely to get acceptance. But it's internal information. So, okay. And finally, yeah, so Martin mentioned that, so you used to be the editor of social networks. Yeah, so. Okay, social networks, and yeah, so the most cited journal is PLOS ONE, but they publish thousands of papers each year, and Science and Nature and scientific reports, and then the Journal of Computational Social Science, and that's quite natural, and machine learning, and then social networks and papers, journal from economics, American Economic Review. This is one of the best journals in economics, and communications of the ACM, American Sociological Review, and it should be one of the best journals in sociology, right? And psychological science and like that. Okay. Yeah, so this journal is connected to these other journals, I think. Okay, so I only have 1 more minute. So as I explained, I'm currently the editor of economic journal, also the editor of a computational social science journal. So I think I'm quite interdisciplinary, but it's actually hard to be truly interdisciplinary, because when I work as an economist, I rarely talk about computational social science. People treat me as an economist, so I rarely talk about computational social science. And when I go to a computational social science conference, I rarely talk about economics. Some people ask me about economics, but economics is quite different from computational social science or any other scientific field. Economists really focus on rationality and optimization and equilibrium. And for example, agent-based simulations are very unpopular in economics, and agent-based simulations have no optimization and no concept of, or some concept of equilibrium, but that's not how economists view the economy. So but they're gaining something. And a paper using agent-based models was published in a good economic journal as well. So it can be mainstream in a decade or 2 decades or something, but still very unpopular now. Okay, yeah, so it's really hard to be interdisciplinary. Yeah, okay, thank you very much.
Thank you, Professor Kamihagashi, thank you sharing with us so much behind the scenes story. Now we can have questions. Yeah, please.
Thanks for the the behind the scenes look into the workings of a new relatively new journal. I'm really curious to know how computational social science, because this field in many disciplines, like in psychology, in political science, in even communication, there is a move towards open science practices where you're asked to reveal all data, pre-register your studies, and make open source your code. And then we have seen some new really top tier journals like Nature and all introduce things like code review, right? So given that this journal is situated at the cutting edge of social science kind of research, quantitative social science research, are there any do you see any ways to integrate these new ways of reviewing into your I mean, I know it's probably more work for you as the editor, but how do you have you been thinking of these things for
so that's a difficult question, but we have no policy to ask for open data or open code. Some programs and data are proprietary, and there are many interesting papers using that kind of data and programming. So we don't ask authors to make their data public. But we ask them to tell us how to get the data if it's possible. If it's impossible, they have to say so. So what do you think? Do you think all data should be public?
I mean, for example, in communication, more and more journals almost it's considered good practice to share your data, anonymized data, and to share your script. So a lot of these journals have started giving out these badges, so open science badges, depending on which open science boxes you tick. For example, if you make your data available, you get one badge. If you make your code available, you get another badge. If you make your if you pre-register your study, you get another badge, right? And so they don't mandate it, but it's a thing that you can do in order to get some brownie points, right? And also, I think in terms of experimental research, I don't know how many studies you get here which are about experiments, but which don't really analyze trace data, but actually run online experiments or whatever, right? So these I know some journals that reject papers because the experiments weren't pre-registered, So they require the analysis plan beforehand, and
Right.
and there are some journals that also have started doing registered reports, right? Like Nature, Human Behavior, and all. They you submit the pre-analysis plan, and then that is reviewed, and then irrespective of what your findings are, they will be published as long as you stick to the pre-analysis plan, right? So yeah, basically the whole landscape of peer reviewing is changing a bit, right? And I'm just interested in your thoughts on how you see this evolving.
Yeah, I think we are moving in that direction. Every journal, I think. Yeah, but on the other hand, I don't think we don't want to go there too early. And there are still people who use sensitive data, and there are people who are reluctant to make their code available to everyone. But then reviewers complain about it, and so I cannot prevent reviewers from complaining. So if they complain, authors may have to react, and so I leave it to reviewers at this point. What do you think?
Yeah, I believe that you mentioned Nature, Human Behavior. I think that's a crisis in behavior science regarding replication. So that's why psychologists are way more sensitive to sharing data. But also there's a discussion even among computer scientists. I saw the paper discussion that they try to collect code, not data, code from computer science, try to replicate, but still not quite successfully. Only 70 or 80%. So still there are bugs and any kind of issues. So that's challenging. Yeah.
What is the policy? Yeah.
Sorry, not on this. Another question, really. I had a quick look, and I noticed it's not an open access journal. Is there any plans to make it open access? Because I now edit Network Science, and that didn't used to be open access, but from this year it's fully open access.
Oh,
so there's
wow.
no cost for anybody submitting. You don't have to pay for submitting a paper if you want it on open access.
Oh, really?
Yeah, and a few journals are going that way.
Wow.
And they do it by getting. What they've done is they've got a load of contracts with individual countries and organisations to get paid to allow them to do that. And also, but if you've got a grant or something like that, and you can pay because somebody else is paying for it, they take the money. But if you say, I'm from a country which does not have that facility, then it'll be published and will be put in open access. So I wonder if you have any plans. Obviously, I can see you haven't.
Yeah.
I was going to ask you about reviewers as well. Over the 12 years I did social networks, it became harder and harder to get people to do review. And the more interdisciplinary a journal is, the harder it is to get people to review because they don't see the journal as being the main thing in their discipline.
Right.
And you find that's a big
Right.
issue. And have you got any ideas what we can do about that? Because I would love to know for network science as well.
So I think it's really hard. Say if it's a paper about computational criminology, if we turn to criminology people, I'm not a computer scientist. If we go to a computer scientist, I'm not expert in criminology, and it's really hard. So reviewers should have more open-minded approach, I think. Or maybe we can be more explicit that, you don't have to be an expert. Or in both, at least in approach or the subject matter. So either criminology or either computing technique, but you don't have to be an expert in both.
Usually for this kind of interdisciplinary journals, that editorial board is also very diverse. So if we got paper from, for example, from sociology, we definitely will designate it to sociologists, and then he or she will handle and reach out to appropriate people, review for us.
I just have a quick question. That when you review the paper for the first time, before you make decision whether you wanted to reject that one or just go into the review process, will you also count that I have collected enough numbers of the papers from science versus the sociology? So you will decide that the balance, to keep the balance, the numbers, that how many papers is supposed to be from sociology for this month or for this seasons or for this year. Or have you ever thought about this kind of numbers, balanced numbers?
Yeah, so I think, what I'm concerned about is more like if I accept this paper, and do I want to get more papers like this? And so there are many applications of machine learning and without any social implication or things like that. So if I start accepting papers like that, and my journal will be filled up with those papers, and do I want to do that? So I think of something like that, but I don't think I try to make balance between different fields. So I think there are waves of, at one point I get many papers on political science, and at one point I get many papers on sociology, and they tend to cluster actually. So when people see a paper on a certain topic published in this journal, then people start submitting papers on the same topic. So that may be a good thing actually.
Yeah, thank you, Professor Kamihagashi, for this very valuable experience on the building a journal. So I have a question about the discipline thing, maybe related to the previous question. So is there any, probably the mission of the journal to be recognized by certain fields of disciplines? Because it's obviously a interdisciplinary journal, but a lot of journals, there are some interdisciplinary title inside the journal name, but it's not recognized by some fields, for example, sociology or to name it. So I don't know whether as an editor you have some targeted discipline you want to target to, or is there any, what is your decision process of this? Thank you.
Yeah, I guess the main targets will be computer science and sociology, I think, obviously, and network science, and Another,
It really depends on the database, how they categorize it, right? Because they already have some certain category, unless they create a new one.
Yeah, thank you. I have just a quick question. So I saw that you publish 2 volumes per year, and each volume has 30 articles. And so for interdisciplinary journal, do you take special issues? Or
sometimes, yeah.
So how would be the process? I mean, if someone like Professor Zheng is going to propose a special issue, then how does it go? Thank you.
I usually answer by saying that we are not accepting proposals. There are many proposals sent to me, and right. But that that's a proposal from people I don't know. So right. What do you do, Martin? Do you get many proposals?
For special issues, about 3 a week sometimes. I suspect somehow the journal's got on a list somewhere, and they tend to be from people that have never published in the journal or possibly any other journal, and they come up with a lot of machine learning ones. So, but actually, in both the journals, the social networks and this one, on the page, we have a form you fill in if you want to do a special issue, and I just looked at your page, and you didn't seem to have that, and I think it'd be a good idea, because that puts people off, because the first thing they say, I want to do a special issue, say, fill in the form. They go through the form, and in there is, criteria by which you'll be accepted. Right. How do you fulfill this criteria? And that slows them down.
Right.
So do you review those proposals?
If they fill it all in, I'll look at it. But it's quite short. I mean, it's just a couple. But basically, the major one is you have to, on the guest editors, you have to have one of the current associate editors.
Yeah, right.
And that usually kills it dead, yeah.
Right.
I want to make the final comment. I mean, for example, in network science, I mean, definitely paper submission definitely have touch on network. If there's no network, there's no way to handle the paper. But when it comes to computational social science, as we discussed yesterday, that's a little bit vague. What do you mean by computational? As long as you use computer? So I still remember one time I handled a paper. The paper used psychological structural equation modeling. Okay, that's really it's a puzzle to me whether I should call it computational or just quantitative. I mean, that's a big challenge. Yeah. I wonder how you guys think.
Well, actually, even in networks, sometimes people actually say, oh, they submit it and say it's networks, but they just say, oh, well, it's the network, isn't it? But there is no network, you know.
Yeah. Everything is a network, in a way. Yeah.
Share something that's in the management of information system because they use the structural equation model a lot after they collecting the survey from the field. I mean, there's a relations among different constructs, and the constructs are based on the literature, the theories, from the MIS theory. They have some models. The models probably has been developed for 20 years, and they are trying to formulate that kind of the model and develop the model and to try to help people understand the operations in the business activity. So I mean, for each one of the constructs can consider as a node, and then the links between all of these constructs could be considered as a edge. So if you say the structural equation model would be also like a network, maybe, but they also integrate the relations or the causal effects among all of these constructs. So the network doesn't show the causal effects; it only show the relations. But I'm not sure if the network could also be developed in that way that presents the causal effects.
I agree. I mean, every decision definitely is subjective. That's up to the editor. Yeah, I totally agree. Yeah. Any other final comments? If not, thank you once again.
Thank you very much.
Valuable information. To save time, I suggest we just continue the final discussion before we go for dinner. So, Wayne, would you take over?
Hello, everyone, again. I'm the moderator for this discussion, and we probably have like almost 30 minutes to talk about this issue. And the topic I'm given, or for all of you, is for a better future of computational social science. So yesterday we talked about challenges. So today we're going to talk about the positive part. Opportunities or better future. And I think it's a very great opportunity for us to talk about at this time, because we have like very experienced scholars, and we also have like junior faculties, and we also have like even college students like here. So I just think about this topic, and I try to use like simple ways to find out if there are any topic or issues that we can talk about. But I know I didn't have time to do research, so I use a very lazy way to tackle this problem. So the first thing I did is to put the title into Google image. So this is an image I got, but I know like you already very familiar with this. Like we are trying to combine like many disciplines altogether and using their methods and domain questions or problems to try to solve a interdisciplinary problem, like social science and computer science, and even physics and mathematics in it. And we have a lot of domains like public health, economics, environment, and behavior, social systems. And we use a lot of different methods, like computational methods and geospatial methods, a modeling method, or simulation methods. So, of course, I'm lazy, so I just asked ChatGPT. I mean, this is hard because I know this is a very broad question to ask. Like, is there any better future for computational social science? And I think AI is a very could be a good answer. Could provide a good answer. So, and I think the answer is not bad because, like, I double checked with Manning there, is my co-author, and she also provides some answers to this question. But let's go through this together. So we are focusing on the positive part of this. So we can have interdisciplinary collaboration, and we can have like see if there is any ethical guidelines or oversight, because there's a lot of bias or privacy issues or dissemination among this. And we have a very good tool for to deal with this kind of problem, like a microscope or telescope we talked about yesterday, and open science practice, like Professor Wujerki just said. And we have a lot of methodological advancement, like from different fields. We have a lot of techniques, like computational methods, machine learning, network analysis, agent-based learning, natural language processing. And we can also integrate qualitative and quantitative approach, like Professor Shao just did this afternoon. And we have a lot of applications. These are very positive. We have different tools to deal with application in very different fields, but they are all like in broad sense social science. And I think it's somehow beneficial for education purpose. Like, people are coming from different discipline and they all have their question in mind. But this could be a very like a common tool for them to deal with or think about their problem. Like, I'm currently teaching computational social science right now, and I ask my students to bring a project, their final project, and they can use like machine learning or agent-based model to deal with their problem. And we also have challenges like we cannot deal with before, and it can bring out some data challenge. And if we have like open data or various data, then we have a lot of tools to deal with it. And we can deal with cultural sensitivity, diversity, and a lot of things. Is sustainability is also another keyword. So we have a lot of opportunities here according to the AI. So just summarize it to here and just put a title here for we have like half an hour to brainstorm and talk about opportunities. But I know we have a lot of, we are coming from different fields, we have different backgrounds, and we have different methodologies. So I think we can talk about the things that we are looking forward to it. And if we have challenges, if we want to talk about it, it's also welcome. So the floor is now open. Anyone want to give us any like any thoughts will be very welcome. Please, Professor Zhou.
I guess it's just some thoughts I recently have. There's a reason why it's called computational social science, but not social computational science, or another field of study that exists, which is taught usually in computer science department, which is social computing, okay? So the order of the term actually is important. It's social science first. Then there's the adjective, there's this word before it is computational. It's social scientists who use those methods to better solve or better deal with their own ideas, problems, research questions. So in many ways I see like people who try to publish or claiming that their research is some sort of computational social science. It has to be firstly some social science topic. Then they extensively use computing tools to a certain degree. And increasingly so that the use of computational tools become like kind of necessary, indispensable in many subfields. So I guess back to the topic of this discussion, the main topic of this discussion, for the future, unless we can have a very clear definition of what are the exact things we are interested in the field called computational social science. Eventually, many social science fields would be kind of doing computational social science, and then this specific term about computational would be kind of very ill-defined because everyone is using computational tools. Then there's no need to have a separate field called computational social science anymore, unless you already have a subset of ideas or topics that exclusively are done by computational social scientists.
Very good point. So you said the problems or the question should be driven from social science and should be like solid, legitimate. And there are a lot of tools already, and but we also try to think, like I remember your talk yesterday, a lot of like computer science acronyms and a lot of things could be used. They are available there, but the questions are always drawn by social science problem. Yeah. Professor Fu.
One issue about data challenges is probably about data representativeness, the one you mentioned on the previous page. Right, address number 8, addressing data challenges. Data quality, availability, representativeness, or about data generalizability. In your talk this morning, you said that one of the limitations is the findings cannot be generalized because most users are in the United States. But what if you use the data from the users in the United States only and come up with the very similar findings and put the phrase in the United States in your title? Would your findings be generalizable?
Yeah, that is a very solid question. We didn't think of it before because we will lose a lot of tweets. So there is another process. But sorry, go back to my talk this morning. But yeah, we didn't do that because. But I think it's doable, but we will have like less limitation. I think it's doable. So, but it is a trade-off because we will lose a lot of data, and we need to do a lot of extra work to make sure this data is only from the U.S.
Okay, but my question is really about the standard of generalizability. I mean, do people really care about generalizability with big data?
It's a very great question. I think
there was an old standard.
We know that we shouldn't stretch too much. So, but the thing for my presentation this morning is we think we already deal with the population because we scrape all the keywords we mentioned, and it should be the whole population that we define. This is our population. So, but we also know the behavior. The people provide the data are not from the U.S. U.S. is only like 40 or 50%, but a lot of them we don't know. So, but we don't want to specify this only apply to U.S. in the title or in the text. So we just say this is a possible limitation. We shouldn't extrapolate or stretch. I mean, this is only a limitation, but I know this is always a consideration or a trade-off.
Okay, there's a follow-up. In conventional survey research, we use large survey data, and that's when we talk about representative sample. But the response rate really goes down very, very fast in all the countries, every country in the world. The USGS used to have over 70% of the response rate. Now it's down to under 50 or 40 now. And if you have, so 40% is really not low. And if you, the phone survey, if you get survey data by telephone and you get a response rate under 5%, you cannot talk about representativeness. It doesn't make sense to have.
Yeah, I mean, it depends on I guess it depends on the study. I think many of you have the experiments of doing survey or doing like automated generate data, like Twitter data. Like the users, they cannot decide whether they want to be participate the research or not, because we just scrape it. So I think there are two issues. One is whether we can decide whether we want to join the survey or not, and we get paid. And I think, of course, the participation rate is getting more and lower and lower. But we see a lot of online platform like Amazon MTurk, like people get really paid by their work doing. I think it's another opportunity. But sometimes I think of an issue, but there are a lot of could be like people can join some research involuntarily. Like people just collect data like without their notice or without their will, because like if some governmental data or some private company collects some data and use the data to publish something or to do some investigation, then we like ordinary people cannot opt out. Like this is another issue I was always concerned, but I don't know. This is a challenge and also an opportunity for data scientists, right? Professor Wu.
Yeah, thank you. I have a related question because, you know, I'm not a data scientist, and this is my first time to encounter a large volume of data when I try to study the Twitter data. But I realize that there is a issue regarding data cleaning because, for example, I'm more familiar with the survey data. So when we got the raw data from a survey, we know how to recode the data, and we know the entire data generating process because we ask our interviewers to recode logistic issues when they are on the field. But it seems to me that when I try to collect Twitter data or I ask my collaborator to collect it, there are a lot of judgmental call first. And then sometimes you have some limitation of getting the data, and then you need to decide whether you are going to pursue it or you will try to ignore it. Then it seems to me that for this part of politics is not transparent enough to me. And I don't know whether there is a standard practice or there is a discussion on this kind of process, because it's totally different from what we already seen in the survey process. And when you conduct a survey project, you need to report the response rate. You need to say how many contacts you make, something like that. But for big data, although at the end of the day, we collect a lot of data through the fancy technique, but some process are not transparent to me, at least from my layman perspective. So I wonder whether you have any
Professor
thought on that.
Yeah, I would like to respond to Dr. Wu's question by putting another question. So since the topic is about better future computational social science, I have a provocative thought, and I would love to hear everybody's thought about it, which is, in survey, for example, in survey research, we come up with a research question first, right? We decide the concepts, and then we decide how to measure those concepts with either single items or multiple items, and then we do reliability checks, and then we administer the survey. But I think in like social media data, you don't need any of that. The question is, what do we operationalize? And then especially with text analyses, there are so many ways to do it. You can apply, for example, the Luke dictionary, and then you have all kinds of measures that you can operationalize 500 different variables. So that goes kind of counter to traditionally what social science has been doing, which is to come up with a theory, then hypotheses, then testing. And the danger is now it's easy to go to the data first and then run like 20 different regressions and then figure out what's significant, and then report that thing, and then come up with a research question that fits that specific model, which is absolutely counter to what survey research has been doing. So could we argue that for better computational social science, we need more training in deductive logic? Or is that pushing it too far? So I don't know, it's kind of follow up to Dr. Wu's question, but since it's so easy to fall in the trap of inductive and going to the data first, perhaps one of the principles that we should teach first in computational social science is the deductive logic. No? Yes?
Yeah, Professor Mukherjee.
I mean, that is one of the goals of the open science movement, right? So you come up with the hypothesis before you collect data, right? And so there is a recognition of this. And I mean, I think it was in 2008 when there was the cover story of Wired magazine was the end of theory, because the deluge of data makes theory unnecessary, was the controversial message. Where like, why do we need statistical inference when you can just look at the data and say if it's happening or not happening? Why do we need to test theory of does something lead to something when you can just look at the data and say, is this leading to that thing, right? So, and the pushback was that, I mean, apart from the fact that the available data is not really a representation of, natural human behavior, it's an artifact of what platforms people are navigating and the affordances of the platform. And so there was this whole movement towards, kind of being transparent about what analysis you do, about ensuring that you don't pass off exploratory analysis as rigorously thought out hypothesis testing, right? So that's what psychology tried to do with the open science movement. In that, so I feel that there is some recognition that we are putting the methodological horse ahead of the theoretical, the cart ahead of the theoretical horse. But yeah, I think we can probably do better. But yeah, I mean, I just feel that there is some cognizance that this is a problem around in the literature or in the academic community.
Still want to follow up on that, but typically the enforcement of the open science framework is for experiments, right? So it's rarely enforced on digital data. So do you think, for example, that we should enforce this open science pre-registration framework on social media data as well? What are your thoughts?
Yeah, that's a good point. There is no reason why you shouldn't or can't, because I mean there is a you can never test whether someone really did it or not. In that, with experiments, right? You pre-register before you collect data. Here, because of how it is, we have to somehow trust the authors that they did not do the analysis till they thought out the hypotheses. So there is I don't think there is any way you can really get to know if someone wants to commit fraud, they will commit fraud, right? If someone wants to circumvent the open science practices, they will do that. But I feel that even with, like, for example, if you look at the Open Science Framework website, they allow you to pre-register even non-experimental data, non-experimental studies. You can say if you've collected data from Facebook or Twitter, you can say this is what I'll be doing with the data. So there is no reason why we can't do that, but yeah, I think the question lies in, the trick is making it the norm, right? That's the thing, yeah.
Can I go ahead, Dr. Liang.
Actually, I can think of a reason why there are people who don't want to accept the open science, framework? Yeah, the OSF framework. And it's for legitimate reason. For example, if two teams happen, so in sociology of science, there is this tournament for priority, meaning that we are trying to be the first to publish a piece of new finding. And many times, without ever being aware of it, many different teams are pursuing the same project. And if I am a junior faculty member with only limited personnel support, and I'm pursuing a very ambitious project, someone else who is the big name X doing it too. And if I choose to publish my preprint and my codes already before it is formally accepted, and there's still a chance after long and tedious review that it get rejected. But if my stuff already are published as a preprint, then the Big Name X with a huge army of RAs could easily take whatever I've done and then put it to the RAs and finish it sooner than I revise and resubmit to another journal, right? So I think this competition for priority is a heavy risk for junior faculty members. And similarly, I would like to challenge number one, interdisciplinary collaboration. Although, I mean, in my talk yesterday, I'm picturing it as a very good thing. It's actually also have risks because as many of you already questioned, when you submit to a interdisciplinary journal, there's a risk of not being judged thoroughly and fairly because most people are still disciplinary based. The knowledge are disciplinary knowledge. So who is the best person who have enough knowledge from different bodies of knowledge to judge your paper? So this is especially difficult for junior faculty members, junior researchers, because they really rely on publication to be promoted. So the senior person are more able to take the risk to do a lot of novel things and get rejected and try again because they have time. But still, I think Michel Lamont at Harvard have published a book called How Professors Think. It's about the evaluation process in like grand panels, a publication, a journal editorial office, and so on. It's a qualitative one, but it exactly documented this process of not being judged fairly if you do a more interdisciplinary bodies of work rather than do traditional disciplinary work. So I think number one and number three, most people think they are perfectly positive, but they are not.
Great feedback.
I mean, I can just give a. I mean, I completely agree with that. I mean, being a early career faculty, I completely see your apprehensions with that. But I think that the problem. I mean, the ideal world, the fact that you have a preprint out means that you kind of did it before whoever published it maybe later, right? So I know that eventually the publication is what matters. Your preprint does not matter. But I think the whole point of this transparency in the open science movement is kind of moving away from the traditional conceptions of what is valuable work. I mean, is a preprint less valuable than a peer-reviewed article? Yes, it is, right? But is there a benefit to having a preprint out there for the sake of dissemination of knowledge for the wider community? Maybe there is, right? So, but yes, there is a risk-benefit trade-off depending on where you are in your career that determines whether you can take that risk or not. Like if you're, I agree. I maybe wouldn't take a risk with a really ambitious study. And I know it's very routine in, say, for example, in biology. I mean, my wife's in, does work in biology, and they're really secretive about what they do. And I kind of tell them that you are in the natural sciences, and I feel that you folks don't adhere to open science as much as even we try to do. So, yeah, so it feels like there is this, the whole, power plays a role, right? Yeah.
Yeah, one thing I want to follow up with your discussion. One thing I find fascinating is I came from natural science, and if we want to publish a paper, we always go to, most of the time we go to archive, like to put it there. But in social science, I find it's rarely people have done this. I just wonder the reason. Maybe part of you talked about it is because like maybe the idea or the data set, if we provide it, could be like some people will take away. But I think natural science have the same issue too. So I really don't know. Maybe we have a lot of scholars in your faculties here. Why there is no system in social science? I don't know.
There is just not used
why
much.
People just don't go to it? Because why there's not a norm yet?
So
I don't
know. The way they're used, the way I've seen people in my community use it is that when you publish a paper which in a journal which is not open access, you cannot put the main people don't have access to the main paper, so you put out a preprint after it's published. It's no longer a preprint, but an ungated version on, say, OSF or on SOC Archive or on SSRN, so that others who do not have access to the library or whatever can have access to them. So, yeah.
So it's allowed, right?
Yeah,
if
it's allowed.
published, then the preprint is still available.
Yes.
It's not a preprint.
It's not a
anymore.
preprint, but yeah.
Actually, it's very common to put your preliminary version of the paper up on the web in economics. And yeah. Very, very common. And yeah.
Other thoughts or some positive news, or we are still trying to think about some opportunities, apparently. Yeah, please, Professor Zhou.
Another, a little bit off topic, random thought, because when she mentioned survey research, I just keep thinking of this, like why survey research, like when we talk about survey research, we just kind of do not think of it as a part of maybe computational social science anymore. And like I did a extensive study of national surveys in the U.S. and did a comparison between probability and non-probability samples study, and it's a lot of computation, I'd say. Like there's a lot of data there. There's a lot of important data there. It's very interesting computationally to do kind of to do the kind of like survey design modeling, that kind of thing. It's probably very computational, more computationally intensive than some other projects I did later on. Okay, so like why for if we want to include more opportunities to have a long-term sustainability to kind of like sustain this field, like why is that? Like why would we just like not include survey research or survey data?
Any thoughts? Professor.
I'd like to extend that discussion. I think on a broader level, I think the opportunities of computational social science is multi-data collection sources. For example, what Dr. Ham presented yesterday was an excellent example. It's merging syllabi digital data with the performance metrics of the students, and I think that's kind of the way to go. And it's you know, we mean in CDNA we have this project where we combine digital data with survey data, and that's another example. And I think that's currently just analyzing digital data. I think it's a lot of people can do it, but as like social scientists, we have this toolkit of survey research, archival research, and I think that's where we can really step in and beat the computer scientists who know a lot of methods. We can't compete them with methods, but we do have this expertise and interviews and all kinds of data collection methods.
So I think I can share one possible combination of computational social science and survey research. And this is not my thought, but I heard from a workshop 2 months ago in our institute. So given that we have AI, we have ChatGPT, and then they can understand what particular people are thinking. And the approach now one team is developing is that to train ChatGPT or AI to be our responder in the future. So suppose that we can collect a lot of survey data for a certain group of people, and then they are going to train AI to mimic those people. And then someday in the future, if they have a new research question or new survey question, they would ask AI to answer those questions instead of asking the real people. I'm not sure if this is the right way to go, but I mean, that's what I am very puzzled, but yeah, I think interesting too. Yeah, so that's one. Yeah.
Yeah, I think there's always more opportunities to combine these things together, and we are seeing a lot of examples these 2 days. So I think it's still very promising. Yeah. Okay, I think the time is up, and we want to have Professor Zhang for some closing remarks. Because no closing remark. Anyone want to share any thoughts?
Because to finalize the discussion, I just want to share one positive side about CSS, is that I believe that people are spending even more time online. So that's if I call it positive. And the other thing is that I know as a social scientist, we struggle with the longitudinal data. I mean, every time we provide static, cross-sectional data, people always criticize, why don't you use longitudinal thing? But online world is a great opportunity. You can just track the dynamic thing. As I have a dream, actually, vision that actually we can test the theory online at regular time basis. I mean, we can, for example, implement different treatments online. And every time people have a reaction, the theory is correcting that, okay, you should do that and do that or do this. That's exactly the live testing, not just wait for a long time and then we collect the data. No, it's ongoing between theory and empirical data. That is my vision for the future of the CSS. Yeah.
Yeah, we hope that we can share a lot of thoughts and experiments for the future, this kind of occasion. So I think our session is done right now, and we can take a break and then for dinner. And thank you for your participation. Thank you.
Thank you, everyone. Quick announcement: we will meet in front of the elevator at 5 o'clock, and I will arrange the rides to the restaurant. Yeah. Eighth floor, yes, 8th floor.